So can we start? Yeah.
I think if you can request everybody to keep their uh, Zoom as mute, except the one who's
हाँ हाँ
speaking, it creates background noise.
हाँ जी मैम, शुरू करें। नेहा मैम।
Okay, ma'am. Okay, sir.
Neha ma'am, kindly let me know when we have to start.
Muskan, we can.
Okay. Ladies and gentlemen, esteemed guests and distinguished participants, a very good morning to each and every one you joining us from around the globe. I'm Muskan Srivastav. It's my honor to welcome you to this prestigious international conference on the recent trends in biological and chemical science. I am thrilled to be your host for this knowledge sharing session. This is my immense pleasure to tell everyone that this conference is organized by Sri Ram Sarup Memorial University in collaboration with Hindu College, University of Delhi. This collaboration represents a harmonious blend of academic excellence and commitment to advancing scientific knowledge all together. Before proceeding further, as we commence this enlightening gathering, let us invoke the blessings of Goddess Saraswati, the embodiment of knowledge, wisdom, and art, for seeking inspiration and guidance for the intellectual journey that lies ahead. Now, I would request our technical team kindly play the melody. Vartika, over to you. Vartika, am I audible to you? Vartika, your sound is not
पहले ही
audible.
देना
I
है।
think you're playing. Kindly unmute yourself. Sorry, it's a technical glitch. Kindly give us some time. Okay, no problem. We can have one shloka for audio.
हाँ जी मैम।
Okay, no issues. It's always a technical glitch. No issues. We can handle with the human efforts. So I would like to recite a shlok for all of you. And it goes like that. Krishnaya Vasudevaya Hare Paramatmane Pratyagye Kleshanashaya Govindaya
दीप ज्योति परम ज्योति दीप ज्योति जनार्दनः दीपो हरतु मे पापम् दीप ज्योति नमोऽस्तु ते शुभं करोतु कल्याणम् योग्यं द्वेषबुद्धि विनाशाय आत्मज्योति नमोऽस्तु ते आत्मज्योति प्रदीप्ताय ब्रह्मज्योति नमोऽस्तु ते ब्रह्मज्योति प्रदीप्ताय गुरुज्योति नमोऽस्तु ते गुरुज्योति नमोऽस्तु ते ॐ सरस्वती नमो नमः ॐ सरस्वती नमो नमः
What a mesmerizing start of the event. So we proceed further. It's my immense pleasure to introduce Professor Dr. Neena Mishra ma'am. She is currently the Director of the Institute of Biosciences and Technology with 30 years of experience in teaching, research, and academic administration. She has served in various prestigious institutions in India and in Nigeria. Her innovative work includes formulating treatments for diseases using medicinal and aromatic plants. She has secured and managed numerous research projects and authored over 50 publications and 8 reviews book chapters. Professor Mishra's leadership extends to her role as the member of editorial board of several international and national journals. Additionally, she has presented her work national and international conferences, guided PhD and graduate students as the process of publishing for books. Welcome, ma'am. Over to you.
Thank you, thank you. Thank you so much. Good morning, everyone. It is
Very
my pleasure to welcome all the participants today in one-day international conference on recent trends in biological and chemical sciences. I welcome all the eminent speakers from all over the world, from different walks of life. A very special thanks to the chief guest of the day, Professor Mitali Mukherjee, IIT, Jodhpur. All of you have come here to join us to share your knowledge and vast experiences in research and development. The theme of this one-day conference is genomics, proteomics, chemoinformatics, and medicinal chemistry. We are proud to announce that this conference is being organized by SRMU with collaboration of Hindu College, Delhi University, Delhi. Once again, a very warm welcome to all of you. All the best and thank you.
Thank you very much, ma'am. Here, I am Ananya. Today, we embark on a journey through the world of biotechnology, exploring innovations and advancements that shape our future. Our first speaker is a distinguished individual who needs no introduction in the field of biotechnology. Please join me in welcoming the convener of ICRTBCS 2023, Sri Ram Swaroop Memorial University. It's an it's an absolute privilege to welcome Dr. Tabish Kidwai, the coordinator of the Faculty of Biotechnology and the Faculty of Biosciences. His academic journey, adorned with an MTech and a PhD in biotechnology engineering, reflects excellence. Dr. Kidwai's accolades include the Rashtriya Gaurav Award and the University Gold Medal. With 13 years of expertise in genomics, immunology, and infectious diseases, he boasts an index of 25, H index of 20, and over 1,000 citations. Today, we are privileged to glean insights from his invaluable experience. Welcome, sir, and guide us through the conference.
Thank you, Muskan. Uh, a very good morning to respected dignitaries, delegates, and all the participants. On the behalf of the organizing committee of International Conference on Recent Trends in Biological and Chemical Sciences, organized by Shri Ram Swaroop Memorial University, Uttar Pradesh, in collaboration with Hindu College, University of Delhi, New Delhi. I extend my warm welcome to the chief guest, Professor Mitali Mukherjee, for the inaugural session of the conference and all present here. During the past 250 years, we have witnessed many landmark discoveries in the area of biological and chemical sciences. A lot of passionate research is being done in the field of genomics, proteomics, green chemistry, chemoinformatics, medicinal chemistry, diagnostics, and therapeutics, but still few challenges need to be addressed. Researchers are trying to explore the novel things, but still there are many roadblocks. The aforementioned research area in biological and chemical sciences are continuously advancing through day by day innovations. The idea behind this conference is to explore the recent advances in the field of biological and chemical sciences. The researchers, physicians, and participants throughout the world will discuss the cutting edge research focused on various aspects of that particular area and share their research ideas in this conference. This international conference include this international conference includes keynote talks, plenary talks, and oral presentations. Speakers from various countries like Saudi Arabia, Norway, Czech Republic, USA, and India will share their knowledge on this platform. This scientific event includes a wide variety of the topics related to the genomics, proteomics, immunology, pharmaceutical chemistry, immunotherapeutic, antibiotic resistance, and medicinal chemistry. The conference will be of utmost use for researcher, physicians, scientists, professors, and students from various colleges and universities. We have excellent speakers throughout the world, and I am sure we will have extremely fruitful sessions. And by the end of this event, we will walk out with better understanding of certain aspects of biological and chemical sciences, and useful collaborations for future. I welcome you all once again to be part of this international conference. Thank you very much.
Thank you so much, Tabisha, for your valuable words. Now, proceeding further, it's an honor to have with us the principal of Hindu College, Professor Anju Srivastav ma'am, a distinguished academician and principal at Hindu College, University of Delhi, brings 25 years of expertise in organic chemistry, biochemistry, environmental chemistry, and analytical chemistry, with a PhD in synthetic polymer chemistry from IIT Delhi. She has authored over 60 publications, co-edited impactful books. Professor Srivastav's leadership has propelled Hindu College to top rankings and through proactive initiatives, international collaborations, and bridging academic industry gap. Her commitment to holistic education is evident in diverse add-on the courses and embellishments of a cutting-edge center for interdisciplinary research. I would request Anju ma'am to enlighten us with her valuable words. Over to you, ma'am.
Thank you, Muskan, if I got the name right.
Yes.
Very good morning to everyone. And on behalf of Hindu College, which is jointly organizing this international conference on recent trends in biological and chemical sciences, I extend a very, very warm welcome. As I can see, there are lots of participants, and what is most heartening is that there are lots of students, and that is precisely the purpose of organizing such conferences. Honorable Vice Chancellor of the university, which is SRM University, and the chief guest of the event, Professor Mitali Mukherjee. Very warm welcome to you and the other dignitaries. Unfortunately, I'm not aware as to who all have joined. But indeed, in these times when, after having passed through COVID, the havoc caused by COVID, and the kind of devastation that we all experience, it is becoming increasingly important to have more such in-depth studies and detailed sort of analysis of how the various sciences, which were earlier considered to be, exclusive of each other in terms of study or research or innovations, they were in their separate silos. So the first important thing about holding such a conference is to show that there are no restricted compartments, and it is together that we can actually bring, whether it is biological or chemical or physical sciences, all of these, there are no boundaries. It is the integration of all of these areas, which the expertise from these areas, which can bring about and is bringing about much needed changes, much needed developments, innovations, and solutions, particularly for, particularly if I look at biological and chemical sciences together, the synergy is so rewarding, is so bountiful. It is bringing all possible breakthroughs, whether it is healthcare or it is environment remediation or it is any kind of development. If you look at the sustainability development goals, there also, I was just thinking just a short while back that almost the majority of the sustainability development goals can and are being addressed with the synergy with the synergy of biological and chemical sciences, because chemical sciences or chemistry particularly is a molecular science, so it deals only with molecules if we look at it. the behavior of molecules, the inside of molecules. And the same molecules, when are present in the biological systems, how do they behave? How do they become so specific and so specialized? And how can we, as chemists and as biologists, harness these attributes and bring about the much required changes? So today, if we want to do any advances in the understanding of life processes and developing solutions to complex challenges in healthcare or in biotechnology and beyond, we must have a synergy of such areas. And this combination has the potential to address all the global problems, as also the framed sustain. I mean, the goals have also become existential only because of the need that has arisen. So today, the problem that is being faced by particularly our country, and if I talk of this area where our college is located, it is in Delhi, and Delhi is particularly facing a huge problem of air pollution. Apart from soil and water, air is again getting deeply impacted and is causing serious problems. If you see the number of malignant cases that are rising in our country, it is absolutely shocking and shattering. So if today the research that is required is to bring solutions to mitigations, to agriculture, to environmental remediation, basically, to be able to have precision medicines, to be of course all of those things which have been going on for the past 3-4 decades, like drug discovery, drug delivery, and now renewable energy, which is a very important area and is again going to only empower us. So, and as we are developing more materials, the work of chemists is mainly to develop more materials, but we need to look into the biodegradability of these materials. So all of these problems can be addressed if we look at the natural scheme of things, which can be provided by the biological sciences, and if we look at a responsible way of conducting our research. So all of these things together, I am sure that with the long list of experts, speakers from various parts of the world, and most importantly, our chief guest of today, Professor Mukherjee, I think will be throwing light and will be giving enough and a lot of food for thought for the students, especially who are tending to develop their minds, tending to develop their opinions at this stage. If they are tapped and they are exposed to various areas of science and technology, it will do wonders in the long run, because these are the young students who are going to hold the country and the world for the future years, which are even more challenging than what we are facing presently. So I think it's a very good theme and a very good collaboration. As I was looking at the website of the university, Sri Ram Swarup Memorial University, I discovered that it is been established. I may be wrong, I'm not sure, but it has been established just about a decade ago, and we as a college are about 12 decades, more than 12 decades old, and it is a pleasure to have a combination of establishment and experts and non-experts from our side, I think, and experts from your side, to have a good synergy and give us very rewarding results. My compliments to all who are behind the organization of this conference, and I wish a very, very enriching, a very enthusiastic participation in today's conference. Thank you.
Thank you so much, ma'am, for enlightening us with your immense knowledge. continuing our exploration, we are privileged to have the Honorable Vice Chancellor, Professor D.K. Sharma, whose leadership has been instrumental in shaping the academic landscape. Let's hear his thoughts on the role of biotechnology in shaping the future. Welcome, sir.
Dixie sir, over to you. Sir, are we audible?
Muskan, I think there is some technical issues. Till then, you can
Okay.
wait.
We will
Okay?
proceed for.
Let me confirm.
Okay. Ananya, over to you.
Okay, so moving forward, we have the esteemed presence of Engineer Pooja Agrawal, the Honorable Pro-Chancellor, whose dedication to education has left an indelible mark on our institutions. Let's welcome her for an insightful address. Welcome, dear ma'am.
Thank you, Muskan. Good morning, everyone. I extend my heartiest congratulations to our university, Ramsarup University, with Hindu College. Dr. Anju, as she has very rightly said, that it's a very nice synergy and combination of young and old. I feel we need to unlearn to learn new things in life. And today's conference is about recent trends in biology. So this is something which will stay forever, till eternity, till nature is there, till humanity is there, till every little being and organization is part of our universe. We belong to a land of Sushrut and Charak, and we owe a lot of responsibility towards knowledge, developing knowledge, sharing it, and utilizing it to the good of society. This is one thing that we should be committed to. And fortunately, being in this profession, we all have this opportunity of making some difference in lives of so many around us. And not just healthcare, there are so many things that nature needs to be dealt with, not only with respect, care, and love, but also with a lot of challenges, with responsibility that we owe towards all that God and Almighty in the form of nature is giving us. We have been nature worshippers ever since. We have always believed in the concept of having a sense of gratitude towards what we get from nature. And that sense of gratitude is and should be the driving force in coming up with new things, experimenting new things, and delving it down to the molecular level of bringing about those fundamental changes which can be monumental in times to come. I have friends sitting in a lot of good academic institutions. Being from IIT, I have friends all over. So they are working on such groundbreaking research. I never thought a friend of mine who's a mechanical engineer would come up with something which is robotic hand, which helps a surgeon doing surgery. So imagine somebody who has that knowledge base is assisted through technology, through a lot of data analytics, and all that can be encapsulated in a much more faster and efficient way of moving ahead. Not being a student of biology, but still, I just know that being part of the ecosystem, we need thinkers. We need people who do research and come up with ideas. We need people who work on drugs, good delivery of drugs. We have seen COVID, and we all were baffled with the whole scenario. Need not go into details of it, but all that we know that we need a very efficient drug delivery system. God forbid, epidemics and pandemics, they just knock at our door at the very last minute. So the idea here is to be prepared, and academicians have a lot of responsibility towards it. We at Ramsarup University are trying to develop concepts which actually look into the research part, and not being young, it's okay, but we are very fresh and young and very energetic, and we want to really get into this area and make some kind of impression in biological and chemical sciences. And I'm very proud of my team, which is committed towards this cause. So with the same thing in line, we are trying to develop a course on biomimicry. It has always fascinated me as an engineer, and biomimicry, I feel all the time we say that we have to learn this and that from nature. But do we really question the fact that why do butterflies have those colors, or why do animals have certain features, certain adaptations? So all that needs to be addressed in a course. And we had very recently, we just started this whole brainstorming sessions on that. And I think in times to come, we'll launch a very good course on biomimicry as a subject. Other than that, I would encourage the students here to take up research with respect to biofuels and bioenergy. We just can't be eating up all the biofuels that have been there in our bank since millions of years. We also have to return back to nature. So what are we doing about it? Are we just raising those placards stating slogans of no plastics, or are we actually implementing it in real life applications? Our university is known for making such initiatives and going ahead with such kind of ideas and such theories in place. To give you a very small example, to promote the idea of no plastic, we don't encourage use of plastic water bottles or plastic folders. We don't like creating biotrash by giving bouquets to our guests. If you come on campus, you will probably not be greeted with a bouquet with the plastic wrapping all around it. You will be given a sapling or maybe a packet of seeds if you're an outstation candidate. So these are certain very small fundamental changes that we are trying to inculcate in minds of people. And I know my entire team is very excited to be a part of this whole initiative and whole process of transforming lives which will not see plastic as part of us, but will see all nature and the beauty of nature, which needs to be appreciated in true sense. I can see my students and team appreciating that fact. I congratulate all the speakers who have taken out time, and all the listeners, most important, who want to learn today and want to have they want to take back something to think upon. My heartiest congratulations to Ramsarup University and Hindu College for joining hands in this very noble cause. And I wish you all the best. Thank you so much. Thank you.
Thank you very much, ma'am, for making us understand the importance of natural resources. As the youth of this country, we promise you all that we will lead to a sustainable world in future. Ladies and gentlemen, and all the dignitaries, unfortunately, due to foreseen circumstances, Chancellor Engineer Pankaj Agarwal sir and our VC D.K. Sharma sir unable to join us virtually today. However, his support, guidance, and blessings are always with us. Despite his absence, his contribution to this conference remains an integral part of this collective exploration of fascinating world of biotechnology. Thank you, and we will proceed further. I would like to introduce Director and Research Consultancy at SRMU, Dr. Sikha Singh ma'am. She is an electrical engineer. She has done her MTech and PhD from IIT Delhi. Over to you, ma'am. Kindly lead us to the most awaited moment for this conference.
Thank you very much. A very warm welcome to all the delegates present in this online conference jointly organized by Sri Ram Sarup Memorial University and Hindu College, University of Delhi. It is my immense pleasure to introduce such a renowned personality, Dr. Mitali Mukherjee. She is a professor and head of the Department of Bioscience and Bioengineering at IIT Jodhpur. She has a PhD in molecular genetics from Indian Institute of Science, Bangalore in 1997 and was earlier a chief scientist at CSIR, Institute of Genomics and Integrative Biology. Her research is in broad area of understanding human genome structure and variation for its application in the discovery of biomarkers for predicting susceptibility to diseases, understanding human phenotype and environmental adoption, and mapping nutritional history. She had been the convener of the Indian Genome Variation Consortium project, which provided the first comprehensive genetic landscape of Indian population. She has been involved in developing a new area of research, Ayurgenomics, which aims to integrate Ayurveda with modern medicine through genomics, and was the program director of CSIR and program director of CSIR Ayurgenesis Unit Trishutra at IIT Jodhpur. She is presently involved in developing a center of excellence in Ayurtech, supported by Ministry of Ayush, that combines electronics, digital health, and AI and multi-omics approaches for realizing evidence-based Ayurveda solutions in a transdisciplinary framework. Dr. Mitali Mukherjee is also coordinating a project in the Jodhpur City Knowledge Innovation Cluster called the Desert Ecosystem Innovation Guided by Nature and Selections, that aims to carry out an integrated study of the desert ecosystem to propel discoveries, invention, and innovations for addressing health challenges in arid regions. Dr. Mitali Mukherjee has over 100 publications in international peer-reviewed journals. She has been the recipient of a number of national awards, such as CSI Young Scientist Award 2001, DBT Young Women Scientist Award 2008, Shanti Sarup Bhatnagar Award 2010, Vaspik Award 2016, and is a fellow of Indian Academy of Sciences and National Academy of Sciences. She is also the board member of International Consortium on Human Genomics. With these words, I would like to introduce Dr. Mitali Mukherjee and invite her for a lecture. Thank you, ma'am.
Thank you so much for inviting me in this occasion, and I would like to congratulate the organizers for actually being able to attract nearly 150 participants for this very interesting conference, I think, because in India, traditionally, we've been working on mono regions where we talk about biology, we talk about cell biology, we talk about human genetics, but it's high time that people from different disciplines start to come together and have these kinds of conferences which allow bridging of sciences. I have a short presentation just to kind of, because they are students and I would like to excite them on the frontiers, not speaking so much about what I do, but what we have available now. It's a very fantastic time for harnessing biological intelligence. And if I can share my screen, I'll just short presentation I'll make. Okay. Is my slide visible? Can
Yes.
Yeah.
Yes, ma'am.
So this is IIT Jodhpur. Anybody visiting here? It's a fantastic campus. I moved here 2 years back, but I like this institute. It provides a lot of transdisciplinary environment to understand various things. So what I titled my talk as Harnessing Biological Intelligence for Innovations and Sustainable Solutions. Going forward from the initial address, as you know, we most of us tend to have an anthropocentric view where we think that humans are the most evolved. But if you see, even from microscopic to macroscopic animal life, everybody has some things to teach us. Even coronavirus, which is a small virus which cannot live outside a human host, could actually turn the entire world upside down. And that shows about the biological intelligence which resides in even smaller genomes, so that how they evolve themselves, or how they manage to evade the host from killing them. These are amazing feats of biological intelligence. And many of these biological intelligence have actually inspired lots of engineering solutions. If you take camel, every body part of camel is optimized for survival in desert, be its body size to kind of dissipate heat in the desert environment, or its skin and coat to avoid sunburn, or its eye for avoiding sand, or things inside in liver for kind of coping up with water scarcity, how it conserves water even out of metabolism, or how it kind of uh, prepares itself for scarcity of food through storing fat in the hump, or many other kinds of things where it gets food which is scarce, which is grassy, how it can actually digest it. And finally, how it also walks on the footpaths. This has inspired tires, which could be sturdy in desert environment. So each and every part of an animal has been a source of inspiration, either for understanding biology or for inventions. And this is true for many such animals. And beyond that, there are intelligence within animals, which can also inspire us from learning how python can actually engulf an entire animal without the animal rotting in its stomach. How does it do that? How does an oyster survive despite the devastation to the ecology of the sea, where it has no control? So how does its genome evolve, or how a naked mole rat can avoid cancer or does not have any pain? So these are the things which have inspired genomic people to look into the genome, to identify if they can know the cause through reading the letters, chemical letters, so that maybe there might be better intervention strategies even in management of human health. And more importantly, how do we understand ourselves? How did we start to walk, become bipedal, where gravity would have played a major role, because from being four-legged movement to standing erect, it would have been a major uh, challenge to the body's mechanics. Or how we learn to control fire so that we could eat cooked food, and our digestive system our cognitive system evolved at the expense of the not needing so much energy towards our digestive system. And finally, how did we learn to speak? So these are all the things which propel people to get into genomics, to understand genome. And today's day, from how we started in the 80s, we actually have a handheld device where everybody at the point of care setting can sequence a human genome. And this has been a marvelous feat where biology, chemistry, engineering, imaging, technology, all these different disciplines have come together. And one of the things which everybody now knows after the COVID, irrespective of what field they come from, is how these technologies had been seminal to tracking COVID, or understanding how to manage it in a very tested manner, right? So this is where transdisciplinary science has its importance. And now people are moving that to chemical space, to polymer space, to something which is now called as DNA of things, where one is thinking that DNA is the most optimized way of storage of information, and how one can actually encapsulate that information in products like nano particles, and embed it and do 3D printing. And once that way you can actually have huge amount of information stored even in a miniaturized manner. And this is what people are now thinking of, having it in wearables, and there's so much of data. Now there's a Netflix serial called Biohackers. The entire series has been encapsulated in DNA as a proof that how you can actually start to store information in DNA, and as the sequencing technologies get cheaper, it would be very easy to retrieve that just by sequencing the information. So that's where science has reached. And the genomics primarily is also moving on to individualized medicine, one of the areas where I work on. And every a part of a human health, from being a newborn to the cause of death, understanding health span, managing diseases, in all these spaces now, genomics is coming in useful for preventing, predicting, personalizing therapies. So this is another area which has come up, and now people are integrating it with artificial intelligence, because many variables have lots of data collected on how we move, how do we talk, how much water we drink, how much exercise we've done, how many calories we have burned, and all these things, if they are now being captured. And the idea is, if you can capture an individuality or an individual in all these dimensions, tomorrow you can actually create a digital twin of that person, so that any kind of a movement that person wants to make in any direction, there is a recommendation engine which guides them for actually maintaining optimum health. And this is the future of genomic sciences, where just like you have the GIS which guides you through complex routes of Delhi, you would have a personal GIS in your watch, and you tap it and it tells you how much you should eat today, or how less you should eat to be able to manage an optimum health. And this is important because now, even if we have been able to control diseases, our health span has reduced. So the last 10 years, we actually live with ill health, which actually costs quite a lot for the healthcare. And the idea is, how do we increase our health span as we have increased our lifespan? And if we live healthy in a scientific manner, if we get evidence and we are able to calibrate ourselves, how do we prevent lots of diseases? And this is the need of the hour. I just in IT, as I moved here, we started a center of excellence in integrated precision health, where we think that we can actually integrate a large number of people from different departments together to be able to address this in a very competitive manner. And moreover, we can actually integrate the science of Ayushas, which actually is written 5,000 years back as to how to manage health and longevity. If we can actually develop evidence around that, and if we are able to integrate that in today's understanding of precision health or scientific wellness, that would give us a strategic advantage. So that's what we are doing here. We are integrating the principles and practices with data science, engineering, and multi-omic technologies to be able to translate this in a setting which we think would be very, very ideal win-win situation, where we can integrate the best of modern medicine in objectivity, and best of Ayurveda in treating disease in a proactive manner and holistic manner, and how we can actually have a think about tomorrow an integrative medicine setting where Ayurveda and modern doctor can coexist, crosstalk, and the patient has an evidence-based choice or personalized option for what treatment to avail. This is where we are moving. The other thing is the climate. There are natural resources which are getting depleted, which are getting exploited, and because of anthropogenic activities, some of it we need to live with. But how do we envision a future state where we also live in a sustainable manner despite all these developments? And for this, we need to understand the rules of the ecology. We need to understand what comprises a sustainable ecosystem. We need to capture the information in the holistic dimension, and then understand using big data sciences to understand, if we want to rewild it or bring it to a sustainable state, what are the kind of intervention needs would be there, and that way we plan it in a proper manner. So this is what we are trying in Thar, the desert eco region, but this would be true for different places. And in all these things, a whole lot of participation of college students, citizen science, for crowdsourcing local information, aggregating it, becomes very seminal. So I'll just end up here with a small thing we initiated with college students in Jodhpur, where we engaged them in something which is called as a Vinogradsky column. They made these columns in these are micro ecosystem in a bottle, where you can actually collect the local ecology, local soil, and grow it in the presence of a sulfur and a water source, and try to see what happens. So it will tell you if the soil is good, if the soil is bad. The microbes which are present in the soil are an indicator of that, and the activity of those microbes are an indicator of the soil health. Most often times we do not consider this, but we did this, and students collected soils from different parts of the city, and you can make out that this is an agriculture soil, then there is a polluted soil, which shows how nature's experiment has gone wrong, because those bacteria are depleted, and maybe because of the fertilizers, because of the toxicants, because of the pollutants. And if we start to aggregate such information all across the country, we might be able to inform the citizens as to how to sustain, how to treat, how to bioremediate, as well as bioprospect from the organisms which thrive in such toxic environment. How do they detoxify the environment? So this is what we are doing, and I just wanted to stop here and try. I just tried whether there is excitement we can actually build up through this. Thank you so much.
Thank you so much, ma'am. One thing I want to mention here, as Pavis sir told us in the starting, that hopefully we will be having a fruitful conference. And now we can surely say that yes, this is definitely a very fruitful and marvelous conference going on. Because as ma'am mentioned about a series in her talk, so it's very admiring and fascinating that after so much of experience, she's still learning and exploring new aspects. So it's a learning for all of us that we must always keep seeking new things in life. Thank you very much, ma'am, for your valuable words.
Thank you so much.
So we proceed further for the vote of thanks. I would like to introduce Dr. Meenu Srivastava, ma'am. She's the teacher in charge. Over to you, ma'am, for the vote of thanks.
Thank you, Muskan. Good morning, one and all present here. It is my great privilege to present the formal vote of thanks. We have entered a period of significant change, which is driven by the ever intensifying needs of our society for knowledge and awareness. Most challenging of all is to develop the capacity for change in our future generation. Only a concerted effort towards sustaining important traditions of the past, challenges of the present, and possibilities of the future can enable our educational institutions to thrive during a time of such a rapid and radical changes. Hence, the conference of this measure has been very effective in meeting its purpose. I am certain that the takeaways from today's international conference, jointly organized by SRMU and Department of Chemistry, Hindu College, will deepen our thinking and stimulate our students for the future. Foremost, I express my heartfelt gratitude to Professor Mitali Mukherjee, the chief guest of the conference, for sparing her valuable time and gracing this occasion. Thank you very much, ma'am. On behalf of the organizing committee of the conference, I take this opportunity to express my gratitude to the patrons, Engineer Pankaj Agrawal, Chancellor, Engineer Pooja Agrawal, Pro-Chancellor, and Professor D.K. Sharma, Vice-Chancellor, Shri Ram Swaroop Memorial University. We are in fact indebted to our Vice-Chancellor, Professor Yogesh Singh, Vice Chancellor, Delhi University, for enabling us to organize the conference, and our worthy principal and patron of conference, Professor Anju Srivastava, for her constant support, guidance, and encouragement. Thanks are due to Professor Neerja Jindal, Registrar SRMU, and Professor Reena Jain, Vice Chancellor and co-patrons of the conference. I would express my appreciation to Dr. Neelam Mishra, Officiating Director, IBST, and RMSU, and co-coordinator of this conference. Dr. Tabish Kidwai and Dr. Neha Kapoor, the conveners, whose tireless efforts have made this conference possible. My gratitude to all the members of Advisory Committee. Needless to say that today's conference has been possible because of the last minute involvement of Director DUCC, Delhi University, and Mr. Nitin Dawar, TA DUCC. Gratitude to both of you, sir. Thanks and deep appreciation to the all members of organizing committee from SRMU and Department of Chemistry, Hindu College for their contributions. Finally, thanks to the student coordinators, Pawan and Pooja, for all their efforts. With this, I wish you all a very significant and meaningful day today. Jai Hind.
Can I just pitch in, Meenu, if you don't mind? I just could not help speaking that Madam Mitali, you were so good. You were so nice in a very small, very short, very crisp, which is most important for students today because their attention span is very poor. So you've given a very good capsule, which is a dynamite in itself. And I really look to, in fact, I've sent a private message to Meenu just now that since Madam is encouraging, college students to be involved in studies which are so interesting, I would expect our organizing team to take it further with the permission of Professor Mukherjee to explore similar, activities for our own students of Hindu College.
Sure.
And of course
We
for
would-
SRM as well.
Sure,
But that
we
was
would,
very interesting and you really
encourage-
put it in a beautiful way. Really enjoyed your lecture.
And
Thank you so
Professor
much.
Kukreti is also there actually.
Sorry?
Professor Kukreti is also there actually.
Oh, wonderful. Kukreti
Yeah,
sir,
yeah.
namaskar. So I think it should be a day full of, such nice interactions. Takeaways is very important because conferences happen and then things, if the follow-ups are not done, then it becomes little meaningless. So my suggestion is that we should definitely take it forward. And I
Sure,
find Madam Mukherjee very, very accessible. A good journey if we start with it. But the first step has to be taken by our own people, right?
Sure, our colleagues, we can work out a Vinogradsky column
Yes.
thing. Would be
So
really-
nice, ma'am. So nice. Thank you so much. Lovely.
I extend my heartfelt gratitude to all the esteemed speakers for sharing their wisdom. As we draw the curtain to the insightful inaugural conference, I would like to ask, it's a humble request, can everyone switch on their cameras so can we have a quick picture with all of the dignitaries? Vertika, is it possible?
Pawan, can you?
Yes, anybody who can do this.
Yeah.
I'm also taking it, Muskan. No worry.
Okay,
Okay.
okay, Veena.
All the dignitaries, please.
It's a humble request to all the dignitaries and the students. Please open up your camera so that we can take a collage photograph of the conference.
Hello, Mitali.
Hi, Shrikant.
Wonderful to hear you and to see you after a long time.
Thanks.
Yeah.
Done, ma'am.
Okay, thank you.
As the conference pauses, may for an interlude, refreshing tea break to refresh the minds and join back with immense energy again.
Thank you so much.
Thank you, everyone. We are having a quick tea break. After that, we will be joining soon.
Thank you.
Thank you, Mitali ma'am. Thank you to all. हाँ जी मैम.
Vartika, kindly play the video of Hindu College. We are waiting for that. Vartika, am I audible to you?
Yes, ma'am.
Can you play the video of Hindu College?
Dinesh, डॉक्टर दिनेश
यस मैम.
वीडियो जो है प्ले करिए प्लीज.
ओके.
And one more thing, after 10 minutes, we will be joining for the session second. And please join after 10 minutes.
देश के दिल दिल्ली में राष्ट्र प्रेम की आराधना, स्वदेश वंदना, माँ भारती के अभिनंदन, कुर्बानियों की कहानी, साहस का प्रतीक बन एक सदी से भी ज्यादा समय से महान राष्ट्र की सेवा में समर्पित हिंदू कॉलेज। इसके प्रांगण, कक्षाएं, नाट्यशाला, रंगमंच, सभागार वीरता, धीरता, उदारता और समर्पण के रंग में रचे बसे हैं। जिन कुशल हाथों से हिंदू कॉलेज बनता, निखरता, बढ़ता, चलता आज सुरक्षित है, उससे सबको एतबार है कि इसका मान, सम्मान और गौरव नित नए शिखर सदा ही छूता ही रहेगा। जय हिंदू कॉलेज, जय जय हिंदुस्तान। सभ्यता, संगीत, संस्कृति, विरासत, वीरता और कला का सिरमौर बन देश की आजादी से भी पहले अंग्रेजों के जुल्म की जंजीर को पिघलाने, हिंदुस्तान के मान की ढाल बन वरदान बना सदा खड़ा है हमारा हिंदू कॉलेज। कभी आजादी के परवाने चंद्रशेखर आजाद की पनाहगाह बन, तो कभी मदन मोहन मालवीय की कर्मस्थली बन, कभी महात्मा गांधी के अवलोकन का आंगन बन, तो कभी जन गण मन के रचयिता रविंद्रनाथ टैगोर के संबोधन का साक्षी बन। मां भारती की सेवा में जन्म से आज तक समर्पित है दिल्ली का यह हिंदू कॉलेज। आइए वक्त के झरोखे से झांकते हैं। बात 1899 की है। महान राष्ट्रभक्त श्री कृष्णदास जी गुड़वाले और उनके सहयोगियों ने किनारी बाजार चांदनी चौक की एक छोटी सी हवेली में हिंदू कॉलेज की नींव रखी। 1 मई 1899 को पंडित मदन मोहन मालवीय ने कॉलेज का शुभारंभ किया। अंग्रेजों के राज में उन्हीं को चुनौती देना कोई आसान काम नहीं था। कॉलेज की शुरुआत में मात्र 4 शिक्षक और 13 विद्यार्थी थे। 1910 में आजाद भारत का स्वप्न देखने वाले हिंदू कॉलेज के साथ ही स्वदेशी और बहिष्कार आंदोलनों में सीधे शामिल थे। सन 1916 में हिंदू कॉलेज ने अपनी पत्रिका इंद्रप्रस्थ आरंभ की, जिसमें गुरुदेव टैगोर सहित कई विद्वानों की रचनाएं छपी। इंद्रप्रस्थ की बदौलत भारत को अनेकानेक साहित्यकार मिले। वैसे तो हिंदू कॉलेज का अपने आरंभिक वर्षों में पंजाब विश्वविद्यालय से संबंध रहा, लेकिन 1922 में दिल्ली विश्वविद्यालय की स्थापना के साथ ही यह दिल्ली विश्वविद्यालय का अंग बन गया। साथ ही यहाँ एमए की कक्षाओं को पढ़ाने की स्वीकृति भी मिल गई। इसके बाद प्रांगण में सजी लोकतांत्रिक परंपरा। सन 1935 में कॉलेज संसद का जन्म हुआ और यहाँ से तिलक, गांधी, नेहरू, सरोजनी नायडू, पटेल और जयप्रकाश नारायण जैसे नेताओं ने समय समय पर छात्रों को संबोधित किया। इस तरह यह कॉलेज अंग्रेजों के विरुद्ध स्वतंत्रता की लड़ाई में अगुवाई करता रहा। सन 1942 में भारत छोड़ो आंदोलन के दौरान सत्य अहिंसा के पुजारी गांधी जी के एक इशारे पर हिंदू कॉलेज के छात्रों ने सहर्ष जेल जाना स्वीकार किया। गांधी जी के एक नारे ने कॉलेज में स्टूडेंट सर्विस लीग की नींव रखी थी। करोड़ों हिंदुस्तानियों के साथ हिंदू कॉलेज के छात्रों का संघर्ष भी रंग लाया और 15 अगस्त 1947 को भारत आजाद हुआ। समय ने फिर से करवट ली। सन 1953 में दिल्ली विश्वविद्यालय परिसर का ज्ञान दीप प्रज्वलित किया गया और 25 एकड़ का यह भूभाग हिंदुस्तान के गौरव, शिक्षा के वरदान और देश की शान हमारे हिंदू कॉलेज के हिस्से आया। हिंदू कॉलेज का अनूठा स्वरूप निखर कर जब सबके सामने आया तो देखने वाले तो मानो देखते ही रह गए। आकर्षण के इस केंद्र को पहला ग्रहण तब लगा जब 1966 में आग ने यहाँ के सभागार भवन को अपनी लपटों में घेर लिया। आग की तपिश और धुएं के गुबार में यह दिव्य भवन राख हो गया, पर हिंदू कॉलेज ने हार मानना तो मानो सीखा ही नहीं। गौरवमय कॉलेज के गौरवान्वित तब के छात्र नेताओं ने नव निर्माण का बीड़ा उठाया। देखते ही देखते कड़ी मेहनत और अथक साधना से साकार हुआ सभागार का नया स्वरूप, जिसे कॉलेज को सौंप यहाँ के विद्यार्थी समूह ने इतिहास के पन्नों में एक नया अध्याय जोड़ दिया। फिर एक बार कला, संस्कृति, नृत्य की कलियां खिलने लगी, स्वर लहरियां गूंज उठे गीत। सन 1999 में हिंदू कॉलेज का शताब्दी समारोह आयोजित किया गया। उस समय के तत्कालीन प्रधानमंत्री अटल बिहारी वाजपेयी ने बतौर मुख्य अतिथि कॉलेज में शिरकत की। वरिष्ठतम छात्र रहे 99 साल के जीवनलाल सेठ को गवर्निंग बॉडी के तत्कालीन चेयरमैन डॉक्टर भरत राम और तत्कालीन प्राचार्य डॉक्टर कविता शर्मा ने सम्मानित कर यह साबित किया कि हिंदू कॉलेज का हर शख्स खास है जो हमारा हिस्सा है। सम्मान के शिखर को बढ़ाने वालों में न्यायमूर्ति जयराम नरेश का आगमन हुआ। इसी दौर में विदेशी भाषा की पढ़ाई भी हिंदू कॉलेज में शुरू हुई। इस कॉलेज की एक स्वस्थ एवं सराहनीय परंपरा रही है कि यहाँ के विद्यार्थी अपने पुराने अध्यापकों को कभी भुलाते नहीं हैं, बल्कि उन्हें सम्मान के उच्चतम शिखर पर विराजमान करते हैं। यह उत्सव एम्पी थिएटर प्रोफेसर प्रेमचंद की याद में बनवाया गया है, जिन्होंने अपने जीवन के 40 वर्ष हिंदू कॉलेज की सेवा में लगा दिए। पूर्व प्रिंसिपल NV थढ़ानी, जिनके नाम पर थढ़ानी मेमोरियल भवन का निर्माण हुआ। हिंदू कॉलेज के प्रिंसिपल रहे डॉक्टर BM भाटिया के नाम पर यह रिसर्च फेलोशिप प्रारंभ हुई। इसी कॉलेज के अत्यंत लोकप्रिय शिक्षक रहे प्रोफेसर डॉक्टर अशोक मित्तल, जिनके नाम पर उनके विद्यार्थियों ने यह कॉन्फ्रेंस रूम निर्मित करवाया और अपने प्यार एवं सम्मान का प्रमाण दिया। आज कॉलेज में 6 कॉन्फ्रेंस रूम हैं, जो कॉलेज की शोभा बढ़ा रहे हैं। इन महानुभावों ने अपने जीवन का सर्वोत्तम समय कॉलेज को समर्पित कर कॉलेज की नई रूपरेखा, नव निर्माण व नए आयामों तक इसे पहुंचाने में अहम योगदान दिया है। आज देश में जब भी कहीं आदर्श कॉलेज की चर्चा होती है तो हिंदू कॉलेज सर्वोच्च शिखर पर काबिज दिखाई देता है। हिंदू कॉलेज से जो पढ़ा उसने हिंदुस्तान को बढ़ाया। गर्व है हमें हिंदू कॉलेज से पढ़े अपने विद्यार्थियों पर, जिन्होंने हमारे देश का मान बढ़ाया। मुख्य न्यायाधीश रहे YK सभरवाल, न्यायाधीश मुकुल मुदगिल, BP सिंह, देश के ताकतवर प्रशासक अरुण भगत, आशा स्वरूप, संस्कृति कर्मी कपिला वत्स्यायन, कवि गुलजार देहलवी, मधुप मुदगल, रिपब्लिक टीवी के अर्नव गोस्वामी, NDTV के श्रीनिवासन जैन और इंडियन एक्सप्रेस के WD माथुर, रुपहले पर्दे से अभिनेता मनोज कुमार, अर्जुन रामपाल, आशीष विद्यार्थी, गायिका रेखा भारद्वाज, फिल्म निर्देशक विशाल भारद्वाज, इम्तियाज अली, खेल की दुनिया से अजय, सबा करीम, गौतम गंभीर, मुरली कार्तिक, ये सब भी हमारे ही आंगन की उपज हैं। नेता नगरी से प्रखर वक्ता सांसद सुब्रमण्यम स्वामी, केंद्रीय मंत्री हरदीप सिंह पुरी, केंद्रीय राज्य मंत्री राव इंद्रजीत सिंह, केंद्रीय राज्य मंत्री मीनाक्षी लेखी जैसे दिग्गज मंत्री बने। और दिल की धड़कनों के कारीगर डॉक्टर नरेश त्रेहान भी शान है हमारे हिंदू कॉलेज की। हिंदू कॉलेज के चांदनी चौक की बुनियाद हो या कश्मीरी गेट की इमारत या फिर वर्तमान परिसर का सुंदर स्वरूप, हिंदू कॉलेज प्रतिपल नए रूप, स्वरूप, नई विविधता, नई उपलब्धि, नई कुशलता, नए कीर्तिमान को आयाम देने में अनवरत संलग्न है। और इसी कड़ी में आज इसे सबसे मजबूती से आगे बढ़ाने का श्रेय जाता है हमारे कॉलेज में पढ़कर आज यहीं पढ़ाने वाली हमारी पहचान प्राचार्य प्रोफेसर अंजू श्रीवास्तव को। पूर्व चेयरमैन स्वर्गीय सत्यनारायण प्रकाश पुंज साहब, सदाबहार कर्मठ प्राध्यापक डॉक्टर अशोक मित्तल और वर्तमान चेयरमैन टीसीए रंगाचारी का जिक्र किए बिना कृतज्ञता की इस झांकी को पूरा ही नहीं किया जा सकता। हिंदू कॉलेज का विज्ञान विभाग, आधुनिक सुविधाओं से सुसज्जित ये इमारत, दमकता चमकता सभागार, जिन सज्जन ने हमारे लिए वरदान बना सौंप दिया, वो हैं भामाशाह की धरती से जुड़े हिंदू कॉलेज के भामाशाह श्री संत सांगानेरिया। उनकी सोच, स्वप्न, शिक्षा दीक्षा के लिए ये दो उपहार श्री संत सांगानेरिया की हिंदू कॉलेज से लगाव, अपनापन, समर्पण का साकार स्वरूप है। सांगानेरिया जी की ये निशानियां हमारे हिंदू कॉलेज को दी अमानत है, जो हमारे भविष्य को सजा, संवार, निखार रही है। खम्मा घणी सांगानेरिया शाह, खम्मा घणी। 1953 में यह बॉयज हॉस्टल, खेल के लिए स्पोर्ट्स कॉम्प्लेक्स, बेटियों के लिए यह वातानुकूलित गर्ल्स हॉस्टल, संगीत, नृत्य, खेल, कला, संस्कृति और संस्कारों से ओतप्रोत यह हिंदू कॉलेज, जहां पढ़ाई के साथ साथ वे तमाम सुख सुविधाएं मौजूद हैं जिनसे विद्यार्थी अपनी मंजिल की राह आसानी से बना लेते हैं। हिंदू कॉलेज ने सन 1974 में जब अपनी 75 वर्ष की यात्रा पूरी की, तब से कॉलेज ने अपने वार्षिकोत्सव मैका के आयोजन की शुरुआत की। आज मैका के बिना हिंदू कॉलेज की कोई भी चर्चा पूरी ही नहीं हो सकती, क्योंकि आरंभ से ही यह दिल्ली के सांस्कृतिक गतिविधियों का केंद्र रहा है। हिंदू कॉलेज के आंगन में मैका की महफिल, यही तो है हमारी महान परंपरा। अब कॉलेज रिसर्च की ओर बढ़ चला है, जिसका मकसद विद्यार्थियों को आधुनिक समय की शिक्षा दीक्षा दे आत्मनिर्भर बनाना है। इसके लिए रिलैक्सो फुटवेयर रिसर्च सेंटर का निर्माण हुआ है। यह 4 मंजिला भव्य भवन रिलैक्सो फुटवेयर इंडस्ट्री द्वारा बनवाया गया है। हिंदू कॉलेज ई-लर्निंग लाइब्रेरी बनाने जा रहा है, जहां विश्व की तमाम यूनिवर्सिटी की किताबें कॉलेज की वेबसाइट पर उपलब्ध होंगी, और इसे बनाने का जिम्मा उठाया है हिंदू कॉलेज के पूर्व छात्र जैकुआर इंडस्ट्री के मालिक राजेश मेहरा ने। आइए हिंदू कॉलेज की इस अनुपम, अद्भुत, अद्वितीय, अभूतपूर्व गौरव गाथा को युगों युगों तक अनंत प्रवाहित करने की हम सभी प्रतिज्ञा लें और ये प्रण करें कि जब तक हिंदुस्तान है, तब तक हमारा हिंदू कॉलेज यह सम्मान धड़कन की तरह संजोए रखेगा। जय हिंदू कॉलेज, जय जय हिंदुस्तान।
Am I audible?
Yes.
Yes, Neha ma'am, we can start with session 2.
Yeah, we can.
Oh, okay. Hello.
Yeah.
I'm audible?
Mr.
Yeah,
Sir,
absolutely.
Mr. Sir, good morning.
Good morning, very good morning.
Good morning, sir.
Good morning, ma'am. I hope all the panelists in my session have joined with my co-chair.
Yes, sir.
Great.
Yes, Tavis sir, may I start?
Yeah, sure.
Yes.
Vinita ma'am is there. Vinita ma'am is there, na? Yeah. Okay.
मधु दीक्षित मैम ने ज्वाइन कर लिया है। मैम, आपका प्रेजेंटेशन शेयर हो रहा है।
तो
अभी सर मैं इंट्रो करा देती हूँ, फिर उसके
ठीक है जी मैम।
यस, गुड मॉर्निंग टू ऑल। Yes, good morning to all. I, Engineer Manju Bharadwaj, Assistant Professor in Department of Electronics and Communication Engineering in Shri Ram Swarup Memorial University, welcome you all
in International Conference on Recent Trends in Biological and Chemical Sciences ICRTBCS 2023, which is organized by Shri Ram Sarup Memorial University and Hindu College, University of Delhi. I welcome Dr. Professor B.N. Mishra sir and Professor Nikhat J. Siddiqui ma'am as chair and co-chair for this session. Dr. Professor B.N. Mishra sir is Dean Research and Development and Industrial Consultant at Dr. ABJ Abdul Kalam Technical University, AKTU, Lucknow, and Professor and Head, Department of Biotechnology at Institute of Engineering and Technology, IET, Lucknow. He has nearly 30 years of experience in teaching and research, including more than 13 years of experience as professor. Previously, he has worked as Dean Administration of IET, Lucknow, and Controller of Examination of AKTU, Lucknow. Professor Mishra has a strong network of national and international research collaboration. He has got funding for many research projects from various funding agencies. Professor Mishra has more than 100 quality research publications in national and international journals to his credit. He is one of those counted few academicians who started working in the area of bioinformatics when the research in this field in the country was in the nascent stage and supervised one among first 5 PhD bioinformatics theses of the country. Professor Mishra has supervised 200 MTech theses and 14 PhD theses and mentored four postdoctoral students. Professor Mishra has also served as reviewer of many research papers for reputed national and international journals. His significant research contributions were covered by leading electronic and print media, including Wired Magazine, Times of India, The Pioneer, and Hindustan Times. The academic contribution of Professor Mishra was recognized and subsequently he got elected as a life member of the National Academy of Sciences, India, NASI Allahabad in 2009, a highly prestigious and oldest Science Academy of India. Congratulations, sir. Further, he received many honors awards, including Visis Samman for outstanding research and development work in the area of environment in 2010, Excellence in Innovation in Technical Education Award in 2014, and Outstanding Contribution in Education Award in 2015. He has been a member of core group on biotechnology, Council of Science and Technology (UP) for nearly a decade and reviewed the biotechnology policy
Madam,
of Jammu
thank you so much. Thank you so much. In fact, I'm joined with my co-chair, that Professor Nikhat J. Siddiqui. And first of all, I must thank you, Ram Sarup Memorial University and Hindu College for organizing such a very timely conference on recent trends in biological and chemical sciences. And I'm really thankful for this to the leadership of both the institutions, as well as special thanks to Dr. Neelam Mishra and Tabis Kidwai and Dr. Meenu Srivastava, who are leading this at the core level. And I'm really thankful for having such vision. In fact, I have got three members in this panel. Professor Madhu Dikshit, Dr. Ved Prakash Dwivedi, and Dr. Mariam Imam. And what I feel that all the speakers are really a great personalities. And Professor Madhu Dikshit, who lecture it first, she is really not just as a scientist, but she is an institution. She headed the CDRI Lucknow, that is one of the most prestigious institution in the world in the field of drug discovery. She has been a professor in an IIT. And similarly, my two other panelists, Dr. Ved Prakash Dwivedi ji, a group leader from ICGB, and Dr. Mariam Imam from Norway. Hence, what I feel that it could be going to be a very interesting discussion during these talks. We are a bit late, maybe hardly 20 minutes from our scheduled time. Hence, since for each panelist 30 minutes has been allocated, hence I feel that having a talk as well as some question answers and just summing up, as I think 20 minutes could be fair enough if our respected panelist whose talk is there could sum up their talk in that period. And over to Professor Nikhit Siddiqui ji, if would like to say something on this.
Good morning, sir. Good morning. And good morning, everybody, the delegates, the participants, the students, the organizers. I would thank everybody, especially the organizers, for having us in the conference. And such an excellent person to chair this session, Professor B.N. Mishra. I think he has introduced all the speakers. And therefore, I think we should start with Professor Madhu Dikshit. If the Professor Mishra allows, we can invite Professor Madhu Dikshit to deliver her talk.
Absolutely, absolutely. She is really a great leader in this field of biological sciences, and she has been a former director of CDRI Lucknow. It's a CSIR institute. She is also a J.C. Bose National Fellow and Distinguished Scientist Chair, Ministry of Ayush. Dr. Madhu Dikshit also worked as a consultant in Translational Health Science and Technology Institute, THRISTI, and NCB Biotech Science Cluster, third milestone, Faridabad, and then she also worked as a visiting professor in Department of Biosciences and Bioengineering, IIT Jodhpur. Hence, most welcome to Dr. Madhu Dikshit, madam. You are a great leader and just enlighten us on your thought in this area. Okay.
So, thank you so much for very elaborate introduction, Dr. Mishra, and also Dr. Siddiqui. I'm very honored that I have been invited to address students in particular about new drug discovery and development. This is the topic which I have chosen. And I will also like to thank Dr. Tabish Kedwai for actually persuading me to be here today. And I'm very, very pleased. So as you have said that the time is now restricted to 20 minutes, I will request that if I can be told at what time I have to stop. So my talk is arranged in such a manner that it can be stopped at the time when you say so. So I will first like to share my screen and have the slides. I hope they are visible and people can see that. So please.
Yeah, it's visible.
Okay, and I think it is moving also. Yeah, so as I told you, I actually chose the topic to make students interested in this sort of science as well. And like it is as you have already told, that Central Drug Research Institute is an institute which was dedicated to new drug discovery. And you will be surprised to know, or may it be already aware, that out of the 20 new drugs, 13 drugs were actually introduced by CDRI. As CDRI do not have a marketing permission, so it has been done by licensing to the companies, and they are being used. Many of them are still in use. So if we see the drug discovery in actually, it dates back to the early days of human civilization. And as we already know in our home, our grandparents are actually very, very fond of the homemade medicines like tulsi ka kada and different other things like this curcumin or haldi milk. They're very popular still in our households, and they do have a lot of medicinal properties. So in early times, these medicines were actually used in our food, and they were also used and along with some religious and spiritual practices. And how did they come to, how did we start using them? It is actually a combination of trial and error experimentation, where people try to consume few things and then see if they are getting benefited by that. So if we see the history of the drug discovery, it actually dates back around 5,000 years, because we do see the documentation of those. So in Ayurveda, there are a lot of prescriptions which are there. Similarly, in the traditional Chinese medicine system, which is again similar to Ayurveda, and then the Egyptian medicine system, we do have lot of natural products which are still being used by the humankind. If you remember, during COVID-19, there were a lot of Ayush Ministry actually introduced kadha as well as different formulations for the prevention and also for the treatment purposes. So as I was mentioning, in the early times, which type of diseases were more prevalent? So they were the actually infectious diseases, which were caused by viruses, bacteria, and other microscopic organisms. And as early as 1900, actually 1/3 of all deaths which have been recorded in the US were mostly due to the pneumonia, tuberculosis, and diarrhea, which are now being treatable. And because there was discovery of antibiotics, and these antibiotics were able to kill the bacteria. While we have recently come out of COVID-19 and the SARS-CoV-2 virus, we did not have any medicine to treat that. So a lot of different antivirals were used, which were not so successful, but our immunity as well as other traditional medicine systems helped in fighting this menace. Currently, we are also struggling with the lifestyle disorders such as cancer, diabetes, heart ailments, and mental disorders. They predominate now. So we are able to treat a bit, up to a large extent, the diseases which are infective, while we are still struggling to treat these diseases. Although with modern medicines, there are medicines which are available to even treat and prevent the lifestyle disorders by changing our lifestyle. So if you see that the beginning of modern pharmaceutical industry actually dates from the beginning of early 1900. It is a very early thing which has happened. And most of the drugs which were introduced during early times, they had their origin from the natural products. However, with the growth of chemistry, there were synthetic compounds, which were also started being used for the chemotherapy purposes. So the first disease which was actually treated by a chemical compound, which is known as salversum, and it was introduced by Dr. Paul Ehrlich, a German scientist, to treat syphilis. Simultaneously, there were prontosil, which led to the sulfur drug discoveries, and they were able to treat the bacterial infections. Quinine, which is actually derived from the cinchona tree, was also used for the treatment of the malaria. And there is a bark which has been used by Egyptians to treat dysentery. And this is a plant which is known as Ipecacuanha. And this was very popularly used for the treatment of infectious diseases. At the same time, the bark of willow tree, which has, from which aspirin was derived later on, also used. At that time, they were using the extracts for the treatment of the fever. Digitalis, again, a plant-derived product used for the cardiac ailments. So when salversum was introduced to treat syphilis in the European countries, at the same time, almost in the similar time, Dr. Upendranath Brahmachari, who was an Indian medical practitioner at that time, he became aware of the Kala Azar, and he also started work to treat Kala Azar, and stimamine was actually introduced by him. And we are still using to treat leishmania the similar and the compounds derived from these stimamine. So it is still a mainstay of the treatment for the leishmania, which is actually due to the protozoa, which is known as Leishmania donavani, which is the infective or which is responsible for the Kala Azar. I thought it is important to make you aware that how old is our Indian pharma industry. Although, like I was talking about the Indian discovery as well as the discovery which was made in Germany for the treatment of syphilis. Our Indian pharma industry at the time of independence of India was worth only 10 crores. And we were actually exporting all the technologies from different countries to prepare drugs post-independence. We did not, at the time of independence, it is true that we did not have any technology even to synthesize paracetamol. So our institutes, several central like CDRI, IICT, and NCL Pune, they were the main institutes which actually were responsible for the preparing or developing different technologies to synthesize these molecules and help the Indian pharma to come up and sell those compounds. So up to now, I'm telling you, like I told you about the independence and post-independence, but in 1970, up to 1970, it is actually the multinationals which were dominating the Indian pharma business. And in around 2000 or early, you can say that Indian companies started having around 61% of the local market. And in 2007, we became actually the leaders of the generic drugs. And we produced around 20 to 22% of the total world supply of the generic drugs. And at the moment, like we have a market worth 50 billion. And by volume, we are actually very, very on a very respectable position in the world. And it will be interesting to know, like, which was actually this slide is for the students, that our first Indian pharmaceutical company is Bengal Chemicals and Pharmaceutical Limited, which was opened in the April 1901. And then, as I was mentioning, there were several multinationals, and then in post-independence, there were several companies which were established, and they produced several antibiotics which actually used the technologies which were transferred by different multinationals to India. Now, as I was mentioning, that there are several drugs which are discovered and marketed in India. There is some list which I am sharing, and I hope you are able to see. And today I will try to tell you about the discovery of anti-malarial drug as well as Centroman, which is actually still in market. And they have been developed by the CSIR labs. Centroman was totally developed at Central Drug Research Institute. And then later on, the technology was transferred to HLL and Torrent Pharmaceuticals, while RT Ether was developed by at CDRI with the help of CMAP. And this compound or technology was transferred to Themis. And at the moment, like more than 150 pharmaceutical companies are synthesizing this and selling it all over the world for the treatment of cerebral malaria. So what is the history of this drug discovery and development in our world? So as I mentioned, like although I told you about the early drugs, but if you see in early 1900, it was actually most of the molecules were from natural products or their derivatives. And it was totally a serendipitous discoveries. Like people were it was based on the observations, HL trials, and we could identify that yes, there is some benefit by using those natural products, and it can be used for the to actually treat some some ailments. As soon as we started having more understanding about the diseases and also becoming aware about nutrients, micronutrients, and then also there were some vaccines which were being identified, but still by and large it was serendipitous discoveries. So up to 1950 or maybe up to 60, there was a mix of chemistry, medicinal chemistry, serendipity, and there was several antibiotics which were being discovered. However, when we had more idea about enzymes and the receptors, then we started having more targeted discoveries of molecules. They were the synthesis of different molecules, which were there were maybe some indication from taken from the natural products, but then by and large medicinal chemistry was started happening, and there was also introduction of biotechnology, and that helped in also identifying proteins which were and receptors. So we could synthesize molecules by identifying the structures, by identifying their target sites or their active sites which were responsible for the biological activity. So how can we block those proteins or those sites and then inhibit their function? So then 1970 onwards, there were structure-based or medicinal chemistry-based or structure-activity relationship-based synthesis and identification of molecules. Then there was a lot of combinatorial robotics and technologies were also introduced. And they helped in reducing the discovery time and also the development. In 2000, when human genome was actually understood, and I think Mitali covered in our presentation this, that as we started having a understanding of the genes which could be correlated or which could be linked with some diseases, we had more idea of the disease processes, and then some gene manipulation started being used. Then there was introduction of biopharmaceuticals to enhance the specificity of their action. And 2000 onwards, there are a lot of discoveries and development which is happening. And this is more so because we are understanding more the disease pathobiology and trying to target and have very specific molecules. So in this times, we are using very, very evolved science for treating diseases or for preventing diseases. So now we use antibody drug conjugates to enhance the specificity and selectivity as well. Then we also have newer mRNA platforms. So how can we manipulate the different proteins or different organisms to actually prevent their action? CRISPR gene editing is also very well used in different forms of diseases. Then proteolysis target chimera. How can, if there is a bad protein which is responsible for pathology, how can we remove it by using these products and enhancing the proteolysis, degradation of those bad proteins? Then DNA encoded libraries are available to actually enhance the discovery process. We also understand diseases by metabolomics and multi-omics approaches. Artificial intelligence and machine learning is also helping us in predicting a lot of things. And this is the era where actually artificial intelligence is being very effectively used in the drug discovery and development processes as well. So this is to give you some idea that even we are understanding more about diseases. Then there are some neurodegenerative diseases. There are some diseases which are actually affecting the particular organs. Can we replace them with the healthy cells and recover their functions? Like in neurodegenerative diseases such as Alzheimer's disease or in Parkinson's disease, there are loss of neurons. Can we use our stem cell therapy to actually differentiate them into neurons and then implant them at the site where it is required? So this way, so this is helping us in many ways. And this is again a area of talk for actually almost an hour. So I am just giving you glimpses that which are responsible. So here, if you see, like the drug discovery is actually a very, very money and revenue intensive area. If you see in a recent study which has been conducted in 2020, the median cost of getting a new drug to the market is around $1 billion. And almost 10 to 12 years are taken from the discovery to the introduction of a drug into the market. There are methodologies and technologies which are being used to reduce the discovery process and also the preclinical development. But clinical trials do take a lot of time, and they are also very, very money intensive. So to give you an idea, when we start with 10,000 compounds, we actually are able to introduce only one FDA approved molecule to the market. So you can understand that it is not only money intensive, but there are a lot of failures. So the people who are involved in this, they have to be in particular very enthusiastic, resilient, and very consistent and perseverant scientists who can do this. So I think I have completed 20 minutes. So I will like to stop here, although I had more slides, but I think with the time which was allocated to me. So thank you so much for your time and patience. Thank you, Dr. Mishra. And I will also like to thank students and organizers for inviting me and to be here. If there is any question or the questions are to be taken later, please let me understand this. So Dr. Mishra, you are muted, I feel.
Dr. Mishra, please unmute yourself. We can't hear you.
So I think he's muted by the organizers. And yeah.
Mr. Rohit, can you help out? Doctor? Please. Please unmute Dr. Mishra. Are you able to do it, Rohit?
जी मैम, विनीता मैम.
Dr. Mishra is not able to unmute himself, so I asked Rohit to please help.
Okay. But Dr. Mishra is host, na? Co-host.
But he's not able to do it somehow. I don't know what is the reason behind.
Okay, okay.
I think सर अवेलेबल नहीं है मैम, यहाँ पे सर है नहीं अभी, सुन नहीं पा रहा हूँ.
You're not able to do it. Then Madam Siddiqui probably can help us.
Yeah, in the beginning, I'd like to thank Professor Madhu
Okay, but
Dixit
Dr.
for,
Mishra is here actually. He is written. He is here, Dr. B.N. Mishra. You can find in the participant list. Dr. Rohit.
Yes, ma'am. Yes, ma'am.
B.N. Mishra sir here is. You can find in a participant and then I think you make it him co-host.
Anyway, I will like to thank Dr. Madhu Dixit for a very concise and an excellent lecture. And on a personal note, I would like to tell her that she has been my source of inspiration. She was a scientist in CDRI. I don't know if she remembers me. I was a research fellow JRF at that time, and she was my ideal. I would look up to her. So anyway, it was nice to hear you again after all these years. Thank you, ma'am, for the concise lecture. Thank you very much.
I wish I could have given the more extensive view on the CDRI drug discovery programs. But anyway, it was pleasure. And Nikhat, I of course remember you. I could immediately identify. Yeah.
Yeah, thank you,
And
ma'am.
because of
And
you people only, I am here.
thank you very much. And you were a source of inspiration for us. And it was nostalgic to have a lecture with CDRI included in you and hear you talk. Thank you, ma'am.
Thank you. It is a pleasure to be here. So I will just like to know if there will be any questions, then I can immediately take up, or otherwise I will log out. Can you, Nikhat, please tell me?
I don't know if we are asked. Is there any questions, please? Or will the questions will be in the end? But I think it would be better if we can take questions now. Any questions, please?
I got unmuted. Thanks, Dr.
Oh,
Siddiqui.
thank you.
It's a very interesting when
good.
Chair got muted.
I could have used that time to actually cover more of my talk, maybe.
But ma'am, I must really thank you for one thing that you told the real story how India became the pharmacy of the world and what has been the real milestone that were covered in that difficult situation, starting from a business of 10 crore.
Yes, yes.
And with the history, that is the first pharmaceutical company originates in Bengal. And ma'am, I have one small question from you, and that answer would help the participants. That
Yeah, please.
what happens if you see across various disciplines, many students have in mind that, well, it's a very difficult discipline. Starting a business in biotechnology means something very big thing, big investment, big failures. I just want you that if you can overcome their fear, because this inspiration will help many people to come out as their own startups, because India really needs that.
So I will I will say that the discovery process is not so money intensive. If you have identified a target, if you identify targets, then medicinal chemistry as well as biotechnology, for that purpose, you can have collaborations with scientists who are available in this country and test them. So up to the discovery process is not so highly money intensive. However, further development, you need to go to the industries. And the reason is because these molecules, whether it is a biotechnology product or a small molecule, they have to be manufactured or synthesized for scale-up processes. And scale up is another science which is important and involved in this process. And there you have to have GMP certifications, and these certifications and even FDA approvals. So if you are going into Indian market, GMP certification. If you are going into international market, you need FDA approvals. So these processes are money intensive, and they have to be done with the help of regular pharmaceutical companies. So it is important to identify the areas in which Indian pharmaceuticals are interested. Your startup should be aligned with that. Identify good targets which are druggable and start the screening in vitro, protein-based, and also the animal-based models. So these can be taken up, but you need a lot of resilience, lot of perseverance here. You cannot be a person who wants quick results. So this involves a lot of commitment and confidence in you. So this is how I can tell in a very brief time about this. But if people are interested, maybe they can also talk to me. I am available. I still go to Syria, right? So that is how I can help the actually early enthusiastic people.
Thank you so much, ma'am, and your blessings are always required for the scientific community, and we'll remain in touch with you so that we can take your blessings and advantage of your long-standing knowledge. Now,
Thank you.
We are going to invite another stalwart, Dr. Ved Prakash Dwivedi, who is the group leader at ICGB New Delhi. And
Mishra sir, actually your voice is not very clear. I think some things.
Am I audible?
So you are audible, but little.
Yes, sir.
Yes, sir.
Okay. I would request Professor Siddiqui, please, if you can read about the credentials of Dr. Ved Prakash Dwivedi.
Thank you. Thank you, Professor Mishra.
Yeah.
Dr. Ved Prakash Dwivedi is working as a group leader in Immunology Department, ICGEB, New Delhi. Dr. Ved Prakash has been awarded Indian Academy of Sciences Associate Fellowship 2023 for his contributions to the field of immunology of tuberculosis. He has also been awarded the fellowship for having demonstrated focused and productive research experience on tuberculosis dedicated to immunopathology. His research attempts to curtail and eventually eliminate the high disease burden of TB in India. Dr. Dwivedi is having a number of publications in reputed journals. Dr. Dwivedi has also received several national and international awards and is recipient of various research grants. In 2023, he was selected for the membership of National Academy of Sciences India. So we have a very highly qualified scientist as well as a guide for the students today. And I would request Professor Mishra to invite him to deliver his lecture.
Thank you, Dr. Siddiqui. I welcome Dr. Dwivedi. और डॉक्टर साहब एक रिक्वेस्ट आपसे यह है कि while delivering your talk and giving insight about the topic you are going to deliberate, आप जो पार्टिसिपेंट हैं उनमें थोड़ा इनोवेशन और स्टार्टअप का जोश भरिएगा, क्योंकि that is very important for India to become a developed country.
I'll try, sir. I'll try my best, sir. Yeah.
Most welcome, Dr.
Thank you, Professor Mishra and Dr. Siddiqui for very nice and humble introduction. And first of all, I would like to say that it's always, pleasure to hear Professor Madhu Dikshit. And it was really very informative talk. And I would like to thank Dr. Tabish Kidwai and other organizing member for inviting me to, discuss my work in this international conference. Thank you. So should I start?
Sure.
Yes.
Just try to limit because we are running a bit late.
I know.
Hence, your time would be 18 minutes because we are going to cut. Yeah.
Yeah, I can understand. Yeah. So it's visible. Hmm.
Yes.
So at basically at ICGB, we are working on the formulation of various novel immunotherapeutic and immunoprophylactic approaches to combat tuberculosis. As we all know, understanding the host productive immunity against TB is really very complex. It is still unclear which antigen or which immune cells provide protective immunity against this deadly disease. So every day we are trying to understand and unscramble the complexity of the immune response and associated immune pathology. So first of all, I would like to give a very brief introduction about tuberculosis. Tuberculosis is pandemic disease. As per WHO report, 1/4 of the global population is latently infected with Mycobacterium tuberculosis, that is causative agent of tuberculosis, and is responsible for millions of deaths each year. It has spread worldwide, but more prevalent in Southern and Central Africa, South Asia, and Latin America. So Mycobacterium tuberculosis mainly infects through respiratory tract, where the alveolar macrophages engulf airborne bacilli. Bacteria replicates inside the macrophages. Macrophages secrete some cytokine, chemokine in response to bacteria to activate the lymphocytes. Once they get activated, they migrate to the site of infection and form granuloma. The main function of the granuloma is to prevent the spreading of bacilli from lung to other organ, as well as concentrate the immune response at the site of infection. If the immune response is stronger, then bacteria will be retained, granuloma will be reduced, and characteristic will be asymptomatic. However, if there is weak immunity, then bacteria will replicate, granuloma will caseate, rupture, and spill the bacilli into the airway to infect others through coughing and sneezing. So depending upon the cytokinic environment, T helper cell can get differentiated into Th1, Th2, T helper 17, and T regulatory cell. So IFN gamma is the representative cytokine for Th1, IL4 is for Th2, IL6 and TGF beta is for Th17. However, IL10 and TGF beta is for T regulatory cells. So previously, we and others have reported that Th1 along with Th17 cells provide protection against TB. However, Th2 and Treg cell assist in disease progression. So although TB is present on the earth since ages, but it is still considered as global pandemic. The problem lies both in its prevention, wherein we have only one vaccine that is very effective, that is BCG, that is very effective in case of disseminated and meningeal TB in young children. However, has questionable efficacy against adult pulmonary TB. On the other hand, it's a treatment which consists of multiple expensive antibiotics with no emphasis whatsoever on the host. Although there are multiple T cell subsets which are known to play a crucial role in containing MTB infection, but still the exact correlates of productive immunity against TB is unknown. So my lab is basically involved in the formulation of novel adjuvant vaccine candidate, novel immunotherapeutic strategies, characterization of various unexplored non-conventional and rare population of T cell, as well as formulation of various host-directed therapies. So, to understand, to design a vaccine candidate, first we need to understand why the present available tuberculosis vaccine BCG doesn't work. So for this, we infected a group of mice with virulent strain of Mycobacterium tuberculosis and vaccine strain BCG. And at different time point, after MTB after infection, we took out the lung to look at the bacterial burden and immune responses. So interestingly, what we observed that initially, both strains replicated in similar manner, but at later time point, growth of BCG was gradually diminished. So it might be the reason that adaptive immune response plays an important role for the clearance of BCG at later time point. So then we looked at the immune response and we observed that both strain induces comparable amount of Th1 producing, IFN gamma producing Th1 cells. However, BCG was unable to induce significant amount of IL-17 producing Th17 cells. So then we thought, what could be the reason behind this? So as we all know that as compared to virulent strain Mycobacterium tuberculosis, BCG vaccine strain causes multiple deletion mutations And these mutations are known as region of differences, RDs. And among these RDs, there are RD1 to RD9. Among these RDs, RD1 is the most dominant, prominent, and important one for providing virulency to Mycobacterium tuberculosis. Then we thought whether RD1 has anything to do with the TS17 differentiation. So for this, we deleted RD1 from S37RV and put back RD1 into BCG. And then we did the entire experiment again. And this time we infected the mice with S37RV, with RD1 deleted S37RV, BCG, and RD1 knock-in BCG. And interestingly, what we observed that RD1 deleted S37RV was behaving like BCG. However, RD1 knock-in BCG was behaving like S37RV in terms of bacterial burden as well as immune response. So now we have proved that yes, RD1 has some role in the differentiation of TS17 cells, and that BCG doesn't have. So now, even if RD1, then we looked at the TS17 differentiating cytokine in the bile fluid of infected animal, and we observed that BCG and RD1 deleted S37RV were unable to induce IL-6 and TGF-beta in the bile fluid, and these cytokines are required for the differentiation of TS17 cells. So even if RD1, even if S37RV induces better protective immunity as compared to vaccine strain BCG, but still, where is the protection? We are not getting protection. So then we went back to the literature, and where we came across through literature research article that was shown by Shabana Khadir and Andrea Cooper, and they showed that TS17 might play a protective role during secondary infection. So for this, we again performed a vaccine experiment wherein mice were infected with all these strains. And then after 30 days, we started treating these mice with antibiotics. And then for 2 months, and then gave 1 month of rest. And then after that, these mice were again infected with S37RV. And then after 1 month of rest, we profiled the bacterial burden and immune response. And interestingly, we observed that the mice which were initially infected with RD1 deleted S37RV and BCG now showed better protective immunity during secondary infection as compared to primary infection. And the mice which were previously infected with S37RV or RD1 knock-in BCG showed robust protective immunity as evidenced by reduction in bacterial burden and increased TH1 and TS17 responses. So here we showed that yes, RD1 region enhances protective immune response during secondary infection. To further confirm that this hypothesis is correct, that IL-17 provide protection during secondary infection, we again performed the same experiment, and this time we injected anti-IL-17 antibodies throughout the rechallenge period, and we observed that treatment with anti-IL-17 abrogated the enhancement in protective immunity induced by S37RV or RD1 knock-in BCG. Therefore, TS17 cells plays an important role for better protective immune response against Mycobacterium tuberculosis. So now, within RD1, there are multiple protein, and in that, CFP10 and ESAT6 has been extensively studied. Even we have shown that ESAT6 specific CD4 positive T cells are present in the mice during MTB infection as well as in TB patients. So we thought whether ESAT6 has anything to do with IL-17 differentiation, and we observed for this, we generated dendritic cell from femur bone marrow of the mice and treated with ESAT6 and co-cultured with CD4 positive T cell that was derived from OT2 transgenic mice. And then, after different time point, we collected the supernatant to look at the cytokine level through bioplex assay. And interestingly, we observed that ESAT6 was able to induce IL-6 and TGF-beta that is required for the TS17 differentiation in TLR2 and MOIDT dependent manner. Furthermore, ESAT6 also induces IL-17 level in the culture supernatant in TLR2 and MOID88 dependent manner. So in order to observe, in order to look at the molecular mechanism, we again went to the literature and observed that Baltimore group first time reported that yes, microRNA has some negative microRNA negatively regulates innate immunity. So taking cue from the these studies, we profiled various miRNA, and we observed that ESAT6 inhibited microRNA 146A and thus allows the induction of IL-6, and that is required for the differentiation of TS17. So to summarize this part, the ESAT6 protein, which is present in S37RV but not in BCG, directs TS17 differentiation by inducing IL-6 and TGF-beta in a TLR2 and MOID88 dependent manner by down-regulating MIR146A. So now we have proved that yes, virulent strain of Mycobacterium tuberculosis induces better protective immune response as compared to vaccine strain. But for obvious reason, we cannot use virulent strain of Mycobacterium tuberculosis as a vaccine candidate. Therefore, we thought to design a MTB mimic molecule. So idea was to induce the immune response without causing any pathogenicity. So for this, we screened various MTB peptides for their efficacy to induce T-cell activation as well as protective immune response. We selected a few of them, combined together with TLR ligand, and then absorbed these molecules on the surface of liposome to facilitate their entry into the lung of mice through intranasal injection. And we named this molecule as PTL, peptide TLR liposome, and then we patented this molecule. Presently, this is in national phase of various Southeast Asian and African countries. So then we asked whether this molecule has any capability to enhance the vaccine potential of BCG. So for this, we performed a vaccine experiment wherein BCG immunized animals were subsequently boosted with these PTLs. And then these mice were infected with MTB. And then at different time point, we took out the lung to look at the bacterial burden and immune responses. And interestingly, what we observed that PTL co-immunization significantly reduces the bacterial burden and enhance the BCG-induced antitubercular immunity, as evidenced by reduction in bacterial burden by more than 2 log. And PTL co-immunization significantly induces polyfunctional cytokine responses and memory responses, which further led to the reduction in the rate of TB reactivation, which is the major challenge being faced due to current antituberculosis therapy. So this work was published in the JCI Insight, and we patented this molecule. So we also observed an increased population of double positive T cell, which is very rare population of T cells in the lung of MTB infected and PTL co-immunized mice. And as we all know that these double positive T cells are initially produced in the thymus and are involved in the generation of single positive T cells, which eventually migrate to the periphery and provide protection against different disease conditions. However, there are a number of reports showing the presence of these double positive T cell in the periphery in a number of virus infection and cancer through techniques like flow cytometry and confocal microscopy. But still, there are a number of questions about their generation and presence in the periphery remain unanswered. So when we analyzed in detail about the infiltration of these double positive T cell in the lung of MTB infected and PTL co-immunized mice, we observed that these double positive T cell produced increased polyfunctional cytokine responses and increased central memory responses. These memory responses and polyfunctional cytokine responses are required for the long-term protection against tuberculosis. So furthermore, when we performed the adoptive transfer studies in rag knockout mice, we observed that these double positive T cell displayed increased antitubercular immunity as evidenced by reduction in bacterial burden than their single positive T cell counterparts. So in order to find out the mechanism, we performed various studies like proteomics and transcriptomic studies to understand the differences between these T cell subsets and proteins and pathways involved in the generation and maintenance of these double positive T cells. So hopefully next meeting, I'll be able to present this data. So depending upon this data, we concluded that yes, this double positive T cell has some protective potential against tuberculosis. So moving on to the next arm of the lab, I will quickly go, in just 2-3 minutes. So moving on to the next arm of the lab, where we are involved in the formulation of novel immunotherapeutic agents against tuberculosis. As we all know, the present anti-tuberculosis therapy is very lengthy and very expensive due to length of treatment. Once the patient starts feeling better, they withdraw from the therapy, and that is the main cause of emergence of drug-resistant variants. It also has various side effects like hepatotoxicity, and most importantly, it causes immune impairment responses, therefore increases the host vulnerability to TB reactivation and reinfection. So we believe that addition of certain immunomodulator during treatment can reduce this adverse effect of antituberculosis therapy. So for this, we screen many immunomodulatory compound for their antimicrobial activity, and we selected a few of them. Here I would like to give an example with berberine. Berberine is an alkaloid compound with having very weak antibiotic activity. People also have shown as an efflux pump inhibitor. It has anti-diabetic nature, also reduces hyperlipidemia. People also have shown that it has anti-cancerous activity. Then we asked whether it has any antimicrobial activity or immunomodulatory activity. For this, we took TSP1 monocytes and peritoneal macrophages, peritoneal murine macrophages, and then we infected these macrophages with virulent strain of Mycobacterium tuberculosis, and we treated with berberine and isoniazid. And these results, concluded that berberine potentiates the antimicrobial potential of frontline anti-TB drug isoniazid. Then we translated this finding in vivo model, and where we observed that berberine treatment significantly reduces the bacterial burden, not only in case of drug-sensitive bacteria, but also in case of drug-resistant strain. By inducing macrophages activation, T cell responses, B cell responses, and significantly heightens the stem cell memory responses, central memory responses, and tissue resident memory responses. These memory responses are required for the long-term protection against tuberculosis. Then, in order to find out the mechanism of the heightened immune response, as we all know that naive T cell upon stimulation gives rise to stem cell memory responses, which further gives rise to effector memory responses, central memory responses, and tissue resident memory responses. These memory responses are required for the long-term protection as well as tissue-specific site protection. So for this, we took human PBMCs derived from PPD positive individuals and treated with CSA, that is complete soluble antigen of Mycobacterium tuberculosis, and berberine, and then looked at the T cell differentiation, and we observed that berberine treatment significantly drives the differentiation of naive T cells to effector memory and resident memory T cells. So then we further performed the proteomics of these PBMCs, and we observed that berberine treatment significantly affected the proteome landscape of CD4 positive T cell, resulting in the upregulation of diverse signaling pathways which are required for the protection against tuberculosis. So interestingly, NOS signaling and glycolysis pathways were upregulated. As we all know, NOS signaling induces PTEN molecule, which further inhibits AKT molecule and activates FOXO1, that is required for the transcription of TRM-specific gene. And then we validated this finding by RT-PCR and observed that berberine treatment significantly induces the TRM-specific gene like NOS3, BLIMP1, PTEN molecule, etc. Then we again looked at the glycolysis, and we observed that berberine treatment significantly induces the glycolysis by measuring the lactate dehydrogenase in the culture supernatant, and then that is required for the effector function of T cell. And then we again validated this finding with Bioplex assay, where we observed that berberine treatment significantly upregulated almost all the pro-inflammatory cytokine that is required for the protection against tuberculosis. Then we asked whether this berberine can be used as immunoprophylactic compound, and for this we again performed a vaccine experiment wherein BCG immunized animals were subsequently boosted with this berberine, and interestingly we observed that berberine treatment significantly enhanced the BCG-induced antitubercular immunity, as evidenced by reduction in bacterial burden by more than 2 log in their lung and spleen of the mice, lung and spleen of the BCG-immunized animal, by enriching the tissue resident memory T cell in the lung of BCG immunized animals. Then which further led to the reduction in the rate of TB reactivation and TB reinfection, which are the major challenge being faced due to current anti-tuberculosis therapy. So in order to summarize this finding, we observed that berberine treatment significantly induced the expression of PTEN FOXO1 molecule, and that enriches the immunological memory against tuberculosis that is required for the long-term protection against tuberculosis. So this work was published in PLOS Pathogen, and on similar note, we performed other, we took other immunomodulatory compound and published other reports as well. So then moving on to the, just I would, okay, I'll quickly go. So we are also working on how epigenetic changes can, improve the host protective immunity. And here we showed that sirtuin-2 inhibition during MTB infection can improve the treatment outcome by, enriching the host protective immunity and by enhancing the vaccine potential of BCG. So on this note, I would like to acknowledge my lab member and collaborator, and of course, ICRTB core facility and funding partner. Without their help, I could not be able to generate this data. Thank you. I hope I took longer time, but yeah.
Thank you so much, Dr. Dwivedi. In fact, it's a coincidence that the first lecture, Dr. Madhu Dikshit, she is really a stalwart in the field. She elaborated how India became the pharmacy of the world. And you discussed very timely, very important topic on vaccines. And you know that today India is the vaccine hub of the world. And it has well demonstrated during COVID-19 pandemic. Am I audible, Dr. Dwivedi?
Yeah, it's very slow. I mean, I can hear you, but it's really very slow.
Okay.
Yes, sir, you are audible. Actually, some students want to ask questions.
Yeah.
Rohit, can
I'll
you
be happy to take.
I think one question
Yes,
can
ma'am.
be raised and
People
remaining
hand
questions regarding Dr. Madhu, Dr. Dwivedi, and even the next talk about Dr. Mariam Iman. I think these questions should be put forward to the mail ID provided by the organizer, and then it will be forwarded to the concerned speaker as well as the chair, co-chair, so that we can reply even on email. But yes, one or two quick questions can be there.
Yeah, thank you, sir. So Rohit, can you unmute them? I think Mr. Chetan is.
Yes, ma'am. If student can write in the chat box, and other option is he can hand raise. Then I can unmute.
Please raise your hand. If Mr. Chetan is there, actually.
Otherwise, you can write your questions and email these questions to the organizer email ID, and it will reach to us and will respond as soon as possible, so that proper reply can reach to you. In the meantime,
Yeah, I'll be happy to take question. Although I mean, due to time
Chetan is
constraint,
there,
I
actually,
had
Rohit.
to finish
Can you
my
unmute?
presentation. Yeah.
Rohit, do it fast,
Ma'am,
actually.
please name बता दीजिए किसको करना है. Yes, ma'am.
Chetan
Please.
Pandey is
Dr.
raised.
Dwivedi,
Chetan Pandey,
I have
okay,
one
ma'am.
question with you. If you are able to hear me.
Yes, sir. Yeah.
Yeah. In fact, can you tell something about how these
Ma'am, Chetan Pandey can ask question
vaccines
right now.
can
Please
be...
unmute.
Sir, actually, there are many, I mean, बहुत सारे लोग बोल रहे हैं, इसलिए I'm not able to.
Can you hear me?
Yeah. Can for a moment other people can mute so that I can just raise one question with Dr. Dwivedi.
Yes, please, Dr. Mishra, please ask. Request others to please mute themselves.
Yeah, I was just interested to ask that how we can test these vaccines on preclinical human models. And does it reduces the requirement of animal models?
Actually, yes, sir. Actually, basically, what we developed this MTB mimic, and we named them PTL. So we did preclinical model, preclinical things in mice, but we are collaborating for preclinical human, as you said, as you advised. We are collaborating in Texas Biomedical Research Institute for NSP studies, non-human primates. So they will tell us, the exact things what is going on in human lung, because they have almost means many similarity with the human. Because my study cannot, we cannot say that, doing in my study, we can claim for any molecule. But until unless it is not doing in NSPs or, very similar model with human, we cannot, go for clinical trial. So we are still doing in NSPs. Yeah.
Which institute you are collaborating?
It's a Texas Biomedical Research Institute, and Professor Deepak Kaushal is helping me in doing these experiments.
Okay,
Yeah.
okay, that's
So
great.
this molecule is in nasal phase, where Southeast Asian and African countries. I have also collaborated in Durban, South Africa. They have, they have many samples of HIV, TB co-infection. So the data what I showed for double positive T cell. They have both harm, CD4 and CD8. They can take care of both TB and HIV. At a time. So I was interested in doing. I was interested to enrich this molecule in the lung of mice. I'm still doing, but hopefully, in next meeting I'll be able to show some data.
No, that's
Clinical
really
data.
great, and you've given a detailed elaboration of this vaccine process.
So
how
clinical
vaccine
experiments are still going on.
Okay, great. And you have really got great publications too. Hence, with
Thank you,
that
sir.
note, I just sum up these two lectures on pharmaceuticals, Dr. Madhu Dikshit and Dr. Divedi on vaccine. And now we are moving forward for our third lecture, Dr. Mariam Imam from the Norwegian College of Fishery Sciences, the Arctic University of Norway. As I request Dr. Nikhat Siddiqui to please read about.
Thank you, Professor Mishra.
Yeah.
Dr. Mariam Imam, she is a skilled and motivated researcher with a strong background in biomedical sciences, exercise biomedicine, and fish immunology. She has a PhD in biomedical sciences from ICGEB, New Delhi, India, and an advanced master's degree in exercise biomedicine from Karolinska Institute, Sweden, and she has experience in variety of study fields like infectious illness, protein biogenesis, host pathogen interaction, etc. So, Professor Mishra, you can request, may I request you to invite Dr. Mariam Imam to deliver her talk?
Yeah, Dr. Mariam, you are really stalwart in this field, and I really most welcome you. By the time we start your lecture, we are quite close to reaching to this session time, but still, your lecture is really so important that it would really be very important for our participants. Hence, I would just request that if you can make some magic in 15 minutes and give a glimpse, and
Yes.
obviously that must be able to bring a lot of energy in the participants because the ultimate purpose so that they can take advantage. And most welcome, Dr. Mariam Imam. Please.
Thank you so much, Dr. Mishra. I would like to first share my screen, but I am unable to do that because it says one participant can share at a time, but when I'm clicking, I'm not getting it.
Can you mail it to the organizer and if they can share it?
But this is strange, actually.
No, ma'am, you can share actually. You are already co-host.
Yes.
Yes, you can share. Actually, Nikhat, can you stop your sharing? This is
yes.
If
I am not sorry, I'm not sharing any screen.
Okay, so by the time
Dr. Divedi has stopped sharing his sharing.
I think so.
Yeah.
I have stopped. Yeah.
Okay.
Okay, ma'am, please.
I'm trying because I'm also the host, but it's not working for me, unfortunately.
Okay, ma'am, can you mail us by the time we can share you?
All right, I will try that.
Yeah, just email a copy. So
I
that
think you can again log in and then it will work.
Okay, that I can try that.
That again is a way.
Yeah.
By the time, can I ask a question to Dr. Dwivedi? Hi, I'm Chetan.
Yeah, Chetan, you can ask.
Yes.
Sir, I also work on the plant Berberis asiatica or Berberis species, and your lecture was really informative. I wanted to first ask, like, what made you choose berberine over some other phytochemicals or antimicrobials that you might have tried to test the cells upon? Like, what activity of berberine made you specify that, okay, this is what we should use?
Yeah. So good question, Chetan. Basically, I mean, you must have seen that table, what I showed for immunomodulatory molecule screening. So basically, not only berberine, there were 15 molecules. So why we chose berberine and vidaferin? Because that time during COVID, people were taking berberine and vidaferin as immunoprophylactic. So we thought, I mean, we were screening for antimicrobial activity, so we thought this is the time to show yes whether this has any activity, immunoprophylactic activity.
Visible. Yeah, please, Dr. Dwivedi, please.
Yeah, so that is why, I mean, see, we are also working on other molecule, and very soon they will be published.
Thank you, Dr. Dwivedi. And if you have any additional question or related thing, Chetan, please just email it to the
Yeah, I'll be
organizer,
happy. Yeah,
and
you can.
it will reply.
You can email me.
Detailed reply will reach to you.
Okay,
and
sir. Thank
Dr. Mariam, it's over to you. You may just scroll down your PPT to check it. It is visible, and you may
Okay.
proceed.
Can you hear me, everybody?
Yeah.
Yes, ma'am, you are.
Okay. Thank you so much. I'm really honored to be the one of the participants and also the speaker for this international conference. And I also thank my very good friend Tabish for inviting me for this. I have a strong bonds with ICGB and CDRI, and I was the speakers with those people. So I feel very, very honored. So since I've got very less time, I will be going through an abbreviated view of what I'm working with. So I'm trying to, yeah, I can't. I don't know why my cursor is not working.
Okay, you are not able to scroll it.
Yes.
Okay.
Why so?
Although listing of your PPT is there.
Yes. I can't see my cursor actually.
Okay.
Yes.
In the mean, what you can do, in the mean, you can just email a copy to Dr. Tabish Kidwai. I think he will.
Yes, ma'am, you can mail. We can just write down the email ID and you just mail on this.
All right.
Yeah, I already told you actually, no? So then we can arrange it if any problem. Or yeah, you can send to the Dr. Tabish also.
Yeah, I'm sending to
yeah.
I hope it. Yeah. Okay, it says file is in use, so I have to stop here and then I will try. Yeah.
India is a very big consumer of fish, and your topic is really very important.
All right.
In India, Hilsa fish is one of the most popular fish. Although it is only found, I think, near West Bengal, but there is a Chilka Lake in Odisha.
Yes.
I think that is one of the biggest area where that is found.
Yeah. Tabish, I have sent you the email. Could you please go through it if you have received? Meanwhile, I'll try once more if I can.
Tabish,
Yeah.
you see if you can present her PPT.
That is very, very strange.
हाँ मेरी आवाज आ रही है
Yes,
मरियम
yes, yes, आ रही है.
हाँ अच्छा
मैंने आपको मेल कर दिया है डॉक्टर ताबिश.
हाँ एक मिनट
These are small technical glitches, and it is a part and parcel of science and technology.
Exactly. And
Yeah.
we were just recently trained because of the COVID situation to go on the Zoom online and Teams
Yeah.
conferences.
And
And,
these tools have helped us a lot, but
exactly.
sometimes there used to be some problems. But I think that will be worked out. That's not a biggie. Do you have similarity in fisheries in India and in Norway?
For Norway, Atlantic salmon is a economic crop. So they have large farms in sea for Atlantic salmon, and the government is basically giving a lot of grants for the fish health. And before I entered into the aquaculture research, I never knew that the fish, each and every fish in Norway is vaccinated. And unfortunately, it's not the case in India, although India is one of the biggest producer in aquaculture. So, so it was very
really
fast.
be very difficult to vaccinate each and every fish?
Initially it was, but now they have mechanized things, so not now.
It's a oral vaccination.
So before they put it for, they are very small smolts, like very small in infants. They are vaccinated and then put in fresh water, and then from fresh water they go to the seawater in the farms after the vaccination.
Okay, okay.
Yeah. So
And
I
you have some
joined.
bodies where this sea salt water and fresh water also meets like brackish water.
Actually, there are facilities. There are very mechanized, high technology farms here. So there are so many in vitro fertilization of the eggs takes place, and then they have the fishes in the facilities, and then they transfer it to the farms, which are actually nets, circular nets in the sea, basically. So they are not doing much in terms of harboring seawater, but basically putting their farms into the sea directly. And most of the farms are in the Arctic region where I am situated, actually.
That's really
So,
great.
yes, so
In
by
the I would request Dr. Mariam,
yes.
In case your PPT gives trouble and even Tabish is not able to present, you can just tell a great story out of your PPT.
Okay.
And that will be important for the audience.
Yeah, I can do that. Sure,
Yeah,
sure.
because
So
they
basically,
would be learning about that. Yeah.
exactly. So
Ma'am,
basically,
I think screen is going to share.
oh,
So
nice.
yeah.
That's very nice.
Yeah. Or Tabish sir, can you send me? Then I will share it.
I think his system is a bit hanged for a moment. Maybe he has to wait till it is. participant would be satisfied to see at least your PPT is there.
Yeah, I'm sorry about it.
Just check if it is moving, slides are moving.
Dr. Mariam, please check.
Yeah, I can see now, but I don't have a control, so probably you have to orchestrate with me to.
So okay, I will scroll the slides.
Thank you so
Just
much.
check if it is scrolling.
Yeah, it is definitely. So basically, I have.
Dr. Imam, I think you are now again welcome to take it forward. And
Yeah, please.
Time we have now sharp 10 minutes and just
Sure.
tell the brief story.
No worries, no worries. So I'm going to
Sure.
make a abbreviated overview of my work, and I will
please.
also make it interesting for the students and the people who are not from aquaculture industry. So basically, my institute is having a fish health department, which is working on fish health for aquaculture industry, and Atlantic salmon is a very big economic crop for Norway. Unfortunately, this industry also has a threat from the parasites, which are ectoparasites, and also the bacteria and the viruses, like sea lice, which is on the surface of the fishes, and it kills the fishes and make them diseased, as well as the viruses. So my work has been divided into different projects, but I'm going to work today. My work will be on the salmonid alpha virus infection, which causes pancreatic diseases in the salmonid or Atlantic salmon. Can we scroll down? What we know about Atlantic salmon and what has been done for it, as we know, vaccine is the biggest choice as a prophylactic measures for every microbes. And definitely vaccines are working for Atlantic salmon, but not for all the diseases. And the reason to it is that we know very little about the fish immunity. So there are overlapping immune responses and key components of adaptive and innate immunity, like the mammals and other invertebrates. But definitely there are differences and need to be explored. For example, the genome has been duplicated millions of years before for Atlantic salmon. And also the RBCs are nucleated. It doesn't have IgGs, and the MHCs work very special over here. So my lab is designated to understand the non-classical MHCs. Next slide, please. So what we know about Atlantic salmon immune system is that it has only single classical MHC, which is MHC UBA. And I'm trying to put my pointer if it is visible. And it has different non-classical MHCs, which are U, S, and L lineage. So basically, what are MHCs? These are the glycoproteins which are on the surface, and we are talking about MHC1, so they are present on all the nucleated cells. So what they do, they are antigen presentation molecules, and they are taking the antigens, which are basically peptides and lipids, from inside of the cell. And when they are presenting it to the T cells, this is called MHC restriction. And this is where we are trying to understand the non-classical MHCs in Atlantic salmon. So the study is focused on L lineage, and it has different members. I was on that slide, Tabish. So it has different members like LGA and LIA. and they are responsive to virus as well as bacteria, and we have some publications before, and that was the reason we are going to focus on these molecules. So what I did in my 4 years here is we investigated the kinetic studies on these stimulations. Tavish, can you stop it for a while, please?
Yeah. Okay.
Yes.
Okay.
So what we have done is that I'm just going to give an overview on this slide because I will not go in details because of the loss of time. We have cell lines for the Atlantic salmon. We have done the kinetic studies for these two non-classical MHC1s. And understanding their mode of of their signaling pathway, we have understood that they are working in response to interferons, the chemokines type 1 and type 2 interferons. And to establish that, we have used a pan-JAK inhibitor for the first time for Atlantic salmon. And apart from that, we are also making MSC tetramers to study the T cell immunity and MSC restrictions. Apart from that, we have learned quite a lot about the promoter regions of these two genes, and they are functionally distinct, although both have been established by us as interferon stimulatory genes. Other than that, we have established cell lines which are overexpressing both of these proteins on the surface, and we have collaborated with the physics department to do turf nanochip dual mode microscopy and imaging further. Can we go next? Yeah. So this is a very big experiment of virus challenge on the fishes, where we have taken attenuated viruses, and if I just go on one of this. Yeah. So in the heart tissue, we see there is a transient upregulation of LIA, which is correlated with interferon A, and LGA is also upregulated, all these duration of SAF challenge. Next, please. So we saw that the LGA and LIA are both responding to the SAF challenge expression. So going on to the time course analysis, we saw interferon GABA was the major player for its response, both for LIA and LGA, the two molecules. And of course, interferon, the type 1 interferon A was also giving up regulations to it. Please, next slide. So there is a schematic of JAK-STAT pathway. I will just take it quickly, where we have added the inhibitor. So the interferons bind on the cell surface. They phosphorylate the pan-JAKs, which are in the transmembrane domain, which further dimerizes the STATs as a homodimer for type 2. They translocate to the nucleus, bind to the specific elements like gas, and then the specific target protein is expressed like myxovirus genes as an antiviral response. So establishing that both molecules are responding to interferon gamma, we took pan-JAK inhibitor, and we tried to understand whether the response is suppressed or not. Next slide. Yes. So this was done for the first time in Atlantic salmon. So we took the myxovirus genes as our positive controls. In the Western, we saw that the inhibitor was working. And we also see there was a partial suppression in the qPCR analysis for LIA and LGA, and also for the MX genes. So we were able to establish in some way that the JAK-STAT signaling pathway is involved in expression of these non-classical MHCs. Next, please. So we learned a little bit about the promoter regions, both by in silico and luciferase assays, and we found out that in the proximal region of both the genes, we found the ISG elements like STAT and ISRAs, but they were distinct patterns for the both, and that might be the reason for their distinct expressional patterns as well, transcriptional patterns as well. So this is luciferase data where we have taken the truncated promoters, and we have also done the mutation of these as ISREs and STAT regions, and we found that they were responding accordingly to the type 1 and type 2 interferons. And we were able to establish positively that these are ISGs, and interferon gamma is one of the lead cytokines for their expressions. And they are also responsive for SAP. Next. So the idea is that when we see these proteins being expressed in response to the virus infection, what exactly they are doing. So in order to understand and also taking into the consideration the challenges which we face to study the salmon, because we don't have clonal fishes and not all the cells are reacting to other fish cells. So we needed the cell line. So we expressed these MSCs as surface membrane proteins as established cell lines. And we did the lysates of specifically separating cytoplasm and membrane, and we found that they were expressing on the membrane, both LIA and LGA. And after establishing this cell line, we went further to do the SAF challenges. So basically what we know about MSCs are they are antigen presentation molecules. Can we go down, Tabish, please? Next, after this, next slide, please. Tabish, next slide. Yes. So what we know about antigen presentation about MSCs are that they are processing the peptide and sending it on the surface and having MSC restriction. We also found in our study that there was in these overexpressed cell lines of MSCs, when they were challenged with the virus, we found upregulation of interferons and regulatory pathway genes like IFID5 and SOX, which shows that they are also the receptor signaling molecules. And these are very recent results, so we are working over it. Apart from that, we checked the viral titers, and we found that the cell lines which were expressing the LIA molecule showed at 10 days post-infection with the virus, there was a lowering of the titers when we compared it with the empty vector and with the wild type cell lines. So we found very novel results about this non-classical MSCs are directly somehow involved in lowering the virus titers, and they are also involved in somehow signaling pathways of regulating the type 1 interferons. Next, please. Next slide. Yeah. So next, what we did, we had a collaboration with our UIT department, which have patented nanochip nanoscopy, which is TURF microscopy, and which is also having the epifluorescence. So the idea of TURF microscopy is to have a evanescent field over the cell membrane. And because of this, the fluorophores, which are only on the surface of the membranes, are stained, and we don't get the background noise. And epifluorescence is just like the confocal microscopy, where the whole cell is illuminated. So the idea of using this microscopy was to see whether these proteins, which we are expressing, are actually coming on the surface, and seeing is believing. And we also are trying to understand the microclusterings of MSCs, which are important event to understand the to increase the avidity of the T cells when they are going for when we will be doing those assays further. So these two cell lines, we saw that both LI and LGA was surfacely expressed. And only last week we did this experiment. Can we go down, please? For the next slide. Yes. So with this multimodal turf imaging, we found that when we are doing some challenges to this cell lines, we found this protein was also being expressed in epifluorescence. And on the same cell, because we are doing the nanochip, and we can track the same cell for all the events. So by merging these two images of turf and epi, we found the challenges or stimulation of these cells caused the protein to be expressed highly and there is increase of microclustering, which is our next study to understand the role of these patches formed distinct punctate staining happening on the surface for these MHCs. Can we come on the conclusion slide now? Yeah. So what we concluded from our study is that Atlantic salmon L lineages have low basal expressions, but they are highly and differentially upregulated in response to the SAV virus infection. LIA is one of the molecule which is induced in response to type 1 interferon, and LIA and LGA both are induced in response to interferon gamma, which is type 2. And LIA and LGA have subgroup-specific evolutionary conserved promoter regions with interferon response elements. They are found on the surface, and overexpression of these molecules results in enhanced expressions of type 1 interferons and ISGs and antigen processing and presentation genes. So overexpression of LIA and LGA may reduce the viral burden, and that is what we are trying to go further in our studies. Yes, next slide is very important, Tavish. So thank you for your attention. And this is my small island, which is Tromsø, where Tromsø University is located. And this is the night view. And this is of the summers. And this is the night view. Right now, we are having the polar nights. Thank you so much.
Thank you, Dr. Mariam Iman. It's a really very insightful talk, and it provided really a great knowledge in the area of fishery sciences.
Yes, I think so. I'm also very excited to work in this field and try to understand how the immune system of different vertebrates work and how much is to be learned further.
Absolutely. Can I have one small question with you?
Sure, if I can answer.
Nowadays, people are talking about human on chip, organ on chip. Is there any concept like fish on chip?
So basically, when we use these words, these are for the layman, not for the scientists, basically. So idea is that if we have a functional cell or a group of cells which can work on the molecular basis, giving those results, like what we are trying to do is making artificial antigen presenting cells from a cell line. And this is a way of developing the tools and assays for quite a big repertoire of Atlantic salmon. We can say that it is a way of preventing sacrificing more of the animal for the model studies, as well as it can be economic. So we are moving in that area,
Great.
definitely.
In fact, today's session was really very insightful, beginning with Dr. Madhu Dixit, great stalwart, and even for me, she is like a mentor, and she has made a great contribution. Then Dr. Ved Prakash and you, Mariam, and Dr. Nikhat Siddiqui. She has been wonderful throughout, and once
Thank you, sir.
I got muted, she took it forward, and
Thank you.
organizers really choosing a very timely topic. I must thank all of you and giving us an opportunity to be here, and wonderful participants, because it was all for you to take advantage of this gathering. And over to Nikhat Degi, if you would like to say something.
Thank you. Thank you, Professor Mishra, and thank you, Dr. Mariam, because this was an interesting lecture, something which we are not used to in our regular lectures, what we listen to. And it was really informative for me also. I would just want to ask you that you were telling that fishes are vaccinated there. So when you vaccinate a fish, I mean, what is its effect on the consumers when we consume these fish? Are there any biological changes going on inside the fish, and how does it affect the human consumption of the fish?
So basically, Norway is very, very concerned about their food and commodities, but whatever is going into the body. So the idea of using the vaccine is actually that there is lot many viruses which are now jumping from different animals into the fishes, and then they are into the sea waters. Uh, Vaccines are definitely protecting them. But what your question is very deep, and we are having a separate department which is working on fish health when they are vaccinated, and they do some deep sequencing and histochemistries to study what is the inflammatory pathways being ignited by immunizing the fish. But as much as I understood this sector, fishes which are vaccinated are highly safe to be consumed, and that is the idea of pumping so much of money into the research to bring up to the fourth generation DNA vaccines for the Atlantic salmon and other fishes like trouts.
Thank you. Actually, it was a news to me that fishes are being vaccinated there because I never heard about it before. Thank you for the nice lecture.
Thank
And
you
thank you,
for inviting
Professor
me.
Mishra, for being a nice host and chairperson of this session.
I'm sorry for this all glitches, but I try to give my maximum
But
in
your
this
lecture
meeting.
made up for all that.
Even I had to offer various speakers a differential time. You can understand
Yes.
our limitations.
Yeah.
I must thank Dr. Tabis Kidwai, a outstanding scientist who could connect us all. And it was really a great time over here, being a part of this conference. Thank you so much.
Thank you so much.
Thank you.
Uh,
Thank
th-
you. And thanks,
thank you,
Dr.
Mishra sir.
Tavish.
Thank you, Nikat ma'am. Thanks, Mariam.
Yes,
I can leave now, na?
I formally extend my thanks
Dr.
to
Tabis, I can leave now.
Uh,
Sir,
yes, sir.
sir, just wait.
What?
Actually, we just give you a formal thanks,
What?
actually.
Thanks.
Vote of thanks.
Sure, please.
Yeah, please, sir. Okay. Yes, Vinita ma'am.
Sure. Thank you, Neha. So as we come to the end of the session too, so on behalf of all the organizers, I, Vinita Narula, extend my sincere thanks to the chair, Professor B.N. Mishra, and co-chair, Professor Nikhat, for successfully conducting this session. And my heartfelt thanks to all the speakers of the session, Professor Dikshit, Dr. Divedi, and Dr. Imam, for sharing their research work and current scenarios in chemical and biological sciences. Thank you so much, every one of you. So their field of research is truly inspiring, and I'm sure it must have inspired our students and motivated our students as well to come up and share your ideas in their work as well. So now, as per the program schedule, we proceed for a lunch, and we'll resume back at 1 o'clock. So a short break for lunch for everyone. So we'll start with the session 3 at 1 o'clock. Thank you, everyone.
Thank you, Dr.
Thank you.
Vinita. Thank you so much.
Thanks, sir.
Thank you, sir.
Thanks.
Thank you, ma'am.
Thank you, sir. Thank you, ma'am.
Hello, Dr. Neha. Can we start?
Dr. Ritika, yes, you can start.
I hope Dr. Khan and Dr. Ruchi have already joined.
Yes, Geetika.
So Dr. Khan and Dr. Ruchi have joined, I hope.
Yes, I'm there. Hello, ma'am.
Yeah, hello, Dr. Ruchi. And Dr. Khan?
Yeah, maybe they are going to join, huh, Geetika?
Just waiting for them.
मैम प्लीज खान सर का पूरा नाम ही अनाउंस कर दीजिए ताकि मैं उनको कोहोस्ट बना दूं।
Dr. G. Khan. It's
ओके मैम, ओके।
Ghayasuddin Khan, yeah.
रुचि मैम, हाँ जी मैम।
Sir, I've joined, sir. Dr. Kidwai, I'm there.
मैम खान सर ने किसी और आईडी से तो नहीं ज्वाइन किया है, बिकॉज उस नाम से कोई आईडी दिख नहीं रही है।
ठीक है रुचि मैम, आप सेशन स्टार्ट करवाइए। रुचि मैम।
Tavishi, Dr.
I
Ruchi
think
is here.
Dr.
Yes, I'm there, sir.
Dr. Khan will join. रुचि मैम।
जी सर, जी सर।
ठीक है मैम, शुरू करते हैं। तो अभी डॉक्टर खान ज्वाइन कर लेंगे।
Okay. Let me start, Ruchi ma'am.
Yes, sir, please.
Yeah,
Yes,
yeah. So good afternoon, all of you. So after a short lunch break, as we move forward with the third session for the day, I would like to mention that Dr. G. Khan and Dr. Ruchi Chawla will be the chairing and co-chairing the session respectively. Dr. Khan is a forensic medicine expert and currently serving as Joint Director at UP State Medico-Legal Cell, Lucknow. He has completed his MBBS degree and later qualified as MD in the field of medicine. Now he is pursuing PhD in forensic medicine. We welcome you, sir. Co-chair of this session, Dr. Ruchi Chawla, is an associate professor in the Department of Pharmaceutical Engineering and Technology, IIT BHU. Her area of research includes tuberculosis, brain disorders, diabetes, cancer. She has 10 years of teaching experience and has been awarded Outstanding Researcher in Pharmaceutics in 2018 by Venus International Foundation. We welcome you, ma'am. Now, I would like to hand over the session to Dr. Khan and Dr. Chawla. Over to you, ma'am. Thank you.
Thank you so much, Dr. Gutika. Nice meeting you. I hope we are meeting for the first time.
Yeah.
Thank you, Dr. Tabish. And I welcome Dr. Khan. I hope Dr. Ghyasuddin Khan. I hope I'm right with the name. Hope he'll be joining soon. So, sir, shall I start the session or shall we wait for...
Dr. Ruchi, you can start the session actually. We are
Okay.
yeah.
So the first speaker, which is going to start the talk, is Dr. Durga Mahor, right? So Dr. Mahor is a research scientist, BioSev at Institute of Microbiology, CES, Czech Republic. She has with her more than 4 years of research experience in various universities. She is an enzymologist with excellent analytical skills, leading clear articulation of the research problems and able to deal with complicated projects. So I welcome Dr. Mahor, Dr. Durga Mahor. So please start the session. So we will be listening to Dr. Durga now. So over to you, Dr. Durga.
Yes, thank you, ma'am. Thank you for your kind words. So I hope you can see my slides. I'm not sure.
Yes, your slides are visible.
Yes, so thank you for your kind words and welcome to you all. So today I'm mainly talking about which like are surrounded or around the antibiotics. So I would like to first introduce to my topic, which is just a minute. ABCF ATPase LMRC, whether it's a regulator or it's an antibiotic resistance. So before I go deep into my topic, I really would like to introduce my lab, where we are situated. So we are situated in a Czech Republic, Europe, and our lab name is a Laboratory for the Biology of Secondary Metabolism. The whole lab working in a two parts. So one part is working in a BioSafe, which is led by the Dr. Gabriela Balikova-Novotná, where I am working, and the another part, which is led by the Dr. Iri Yanata, which is a Czech Academy of Science, Institute of Microbiology. So we both the teams working together. Yes. Okay. So we both the teams working together, which is more or less for the antibiotics. And I think we all are aware why many groups are working on antibiotics. So we just look back and see in a whole century, we developed many antibiotics, but parallelly we cannot ignore the antibiotic resistance is also a very big problem for us. And it's already declared that the AMR, the antimicrobial resistant, it's a fundamental threat for the human being. So to concern all of these, the whole group is focusing on a three aspects of the antibiotic. First and foremost is the biosynthesis. So we are really aiming for developing a more efficient and the less resistant antibiotic. Of course, for that we developed the metabolic platform, so we can analyze some of the small organic molecules. And the third part, how these antibiotics develops resistance. So I'm mainly working on this part, and we are working at a molecular level, so we can know what's the mechanism for the resistance. So today I am mainly talking about this. So just to recall, there are many antibiotics and their mode of actions are different. Sorry for this. Yes. So if you see in a left panel, there are targets for the antibiotic, which include the cell wall, DNA, RNA synthesis, fluid synthesis, cell membrane, and protein synthesis. But microorganisms are also very smart, and they also found a way so they can tackle with these kind of situation, and that's how they develop some of the resistance mechanism, in which efflux is a most common. Most of the researcher thought the target modification, antibiotic inactivation, bypass, and the target protection. protection. So which protection? So I'm mainly talking about the ribosome protection mechanism, which many antibiotics do this, and it is mainly they would like to inhibit the protein synthesis. Now, if we move further and just focus on a ribosome, there are various sites where the different antibiotic class binds. For example, if we go for the chloramphenicol, it binds to the 50S subunit and inhibits the formation of the peptide bonds. Similarly, linezolid, which prevent the 30 and the 50S ribosome complex formation. But we are focusing on this group of antibiotics, which is actually macrolides, clindamycin, and streptogramine, which blocks the polypeptide access tunnel on the 50S and block the protein synthesis. So that's how this category of the antibiotics work on a ribosome. So where we are playing role and what we are studying. So if you just see the right panel, if I show this picture, most of you or most of the even student can recognize this picture and say this is a ABC transporter. But if we go really little bit deeper, what is ABC transporter? These are the ATPase binding cassettes, and this is not very old enough, but recently some of the 2 and 3 decades researchers found that ABC protein is a really very big protein family, and their function is not only restricted for the transportation, but they have a wide array of functions. As you can see in this, they are really involved in a different categories of function. But what we are focusing, because we are targeting the 50S ribosomal antibiotics, they are mainly targeting on the ABCF protein. Those have any role in related to the translation. So this class of the protein are not well explored. They are still people are choosing some proteins and studying there. But what unique about them? Because I told they are not they are playing in a transport role in a translation. So definitely they have capability to bind with the ribosome. And if you see on a left panel, there is no transmembrane domain. It means they are not playing any role in a transportation. So if you see just a fundamental architecture of the ABCF protein, they have the 2 nucleotide binding domain because they fall in a ATP family. So of course they have the signature motif from the family. They have a linker and they have arm. Some of the ABCF protein also has a C-terminal domain. As I already told, these proteins are not very well studied, so function of each part is not very well known. But some of the protein from this class have been studied, and they found, for example, one of the ETTA, it regulates the translation. The another 2 protein, MSR and the VMLR, they play role in an antibiotic resistance. So similar to we are targeting the 50S ribosomal unit, the some of the protein they have capability to bind this active side of the ribosome, in which I am today talking about the LMRC, which is also one of the ABCF protein. So what exactly the LMRC? So if you see, LMRC is a part of a lincomycin biosynthetic gene cluster. So in a gray, you can see all the biosynthetic genes and the LMRA, LMRB, and LMRC. These are the playing role in a ribosome protection. So if you see LMRA, its function is a efflux. It means it thrown out the antibiotic from the cells. 23S RNA methylation, another protection mechanism, and the LMRC is also a ribosome. It's also gives some role in a resistance. And if you clearly see, the LMRC is adjacent to the LMBU, which is a transcriptional unit. So when we were studying this protein, we found this protein is not very well important for the resistant, but then what's its role? So then we come up with the idea whether it's giving any signal or regulating something, and how we come with this idea. So just see this graph. In a gray, line, it's like a lincomycin resistance. Yellow or the mustard is the clindamycin resistance. And clindamycin is a chlorinated version of a lincomycin, which is also using in a clinics. So, and these black dots are the lincomycin biosynthesis. So when we have all the three, which is more or less wild type, the organism is a lincomycin resistance and the clindamycin. And if we delete the LMRC, there is no difference in the resistance. But if we delete LMB and the A, we have a little bit less resistance. So we know the LMRC shows some extent of resistance, but also it is not very essential. LMRA and LMRB is more important for the resistance. Then we did the second experiment where we are proving that LMRC somehow regulate the LMBU transcriptional unit. And how we did this? So we did the knockout for the LMRC and complemented with the constitutive promoter. It means it's always expressing. Then again, we did the knockout of the LMRC and complemented with the inactive version. So we did the mutation in the ATP site, and this protein are the ATP binding protein. So there is no ATP release, so the protein is not active. So we complemented with the inactive form. So if you see, even without any antibiotic, when we complemented with the LMRC, we can see the LMRC production and the LMBU production. But when we complemented with the inactive, we can clearly see the LMRC production, but there is no LMBU. So this actually give us an idea, maybe this is really regulating the another transcription unit, which is giving more lincomycin biosynthesis. So the ATP active LMRC actually induces the LMBU transcription. So on the basis of all result, we actually propose a cascade, and where we are telling that LMRC and LMBU, they are really working in a fine tune. So for example, if you see, there are the antibiotics and they bind with the ribosome. Then because of the ribosome mediated attenuation, they actually overexpress the LMRC and actually giving LMRC to produce more, and somehow this LMRC induces the LMBU. But on this part, we are really not clear how this LMRC induces the LMBU, which is the next part of my talk. So if you see, we know this first part, in response to the antibiotic, the LMRC is induces, but how the LMRC induces the LMBU overexpression, we are not very sure how it does. Maybe it's a protein driven, it's something which is related with the ribosome splitting or the recycling or any other repressor or any other regulator. So we already knew this first part a little bit more in detail, but we are not known everything about the second part, how some of the protein can really regulate the another transcription unit. And for that, we have actually would like to study in a much more detail, and that's why we divided the whole study in a two part. One part where we would like to study in vivo, and the another part where we would like to study in vitro. So in vivo, we would like to do some of the mutagenesis as the LMBU is just upstream of the LMRC. So we would like to do some of the mutagenesis study and study with the reporter assay. Then we also plan to do some transcription translational assay. So we have a in vitro data which hopes so similar with the in vivo. Then the toe printing, and of course, because we would like to know how the molecules and the proteins are interacting, how they have a relation with the ribosome, we would like to do the cryo-EM. So today I'm focusing on one of the technique, the toe printing, because I just got good result from this in a past months. So I would like to share with you all. And this is also a new, it's not a new, but it's very, a very powerful tool, which actually it's a biochemical technique, but somehow you can also know what's the mechanism. So this Am I audible to you all? Because I don't know, I'm getting a message.
Yes, ma'am, now you are audible.
Yes, okay, thank you. So this is a very powerful technique where we can really know where the initiation start in a translation. And this technique is really helpful because, for example, if you are giving some small molecular ligand and you would like to know where the ribosome actually stall on a interest of sequence, then we can precisely identify these sequences. So what this technique is about, sorry. Okay. So because the only drawback about this technique, you should really be know what sequence you are interested. So first of all, you synthesize the DNA because you are aware that which sequence you are going to study. This sequence along with the RBS with the primer sequences. So first we design the DNA template, single stranded DNA template, and then we do the in vitro transcription. So you are producing mRNA from the DNA, and then again we do the in vitro translation. In vitro translation, where we would like to study which antibiotic we usually provide that and the ribosomes. So now we are aware of the whole sequence. And if you assume when we give all the machinery for the translation, the ribosome will stall at the position where it should be stalled. And then we usually perform the reverse transcription with the reverse transcriptase. So reverse transcriptase form the cDNA, which is really like a complementary to your mRNA. Now, the position where the reverse transcriptase collide with the ribosome, it will fall away. And now, because this technique is so precise, we clearly know the ribosome P side till the position of the reverse transcriptase fall. It's mostly time 14 to 18, but the 16 nucleotides. So by this, we can precisely locate where the ribosome usually stall. And why this technique is really important for me, if you see this scheme, there is a LMBU and this is a LMRC. Upstream region of a LMB, you can see the 3 ORF, but the major problem, these 3 ORF are the overlapping with each other. So we really didn't know which ORF is translating when we are giving any antibiotic. So that's why this technique is really important for me to identify which ORF is really translating in response to the antibiotic. So for that, I use the NAB Pure Delta Ribosome Kit. This kit actually providing all the translation machinery to you, and every kit has some of the delta. For example, in this delta ribosome, it means the ribosomes are not provided by the kit. So in a first experiment, what I have done, I just give all the kit component and the mRNA. There is no ribosome, no antibiotic. So I should assume there will be no translation. So I hope I won't get any band for this. Now in a second, I really provided the kit, the mRNA, which I am interested, the ribosomes, and of course the antibiotics. It means if there is any translation in response to the antibiotic, I should see some of the cDNA bands. So if you now look, these are the sequencing because the template is designed by me, so I can really generate the sequencing reaction for each basis, and this I did. So I know the sequence and everything, so I can really like read my sequence by this band. This is based on a Sanger sequencing thing. Now, as I told in a first well, I didn't give any antibiotic, any ribosome. It means I should not see any band. So, okay, so if you see these band, these are the runoff reactions. So you can really avoid these band. And these, some of the bands are the secondary structure of the template. But as I have a sequencing reaction on a left side, I can clearly locate where the AUG, and then I can see if my interest of band is there, and we know the ribosome P site and the position where the RT reverse transcriptase fall is 16 nucleotide. So when I see AUG, I can calculate 16, and I assume I have to see some of the band in this position. So I did. Then I provide the erythromycin, because the erythromycin from the another class, it should not bind. So I'm not getting any band again with the erythromycin. Now, if you see lincomycin, I have really a very sharp band, which is of my interest. So I know, okay, in this position, the initiation has been started. And similarly, when I put the clindamycin, I can see the band, the pleurometine where I can see the band, and similarly for the tiamulene. So if you see only this, so when I really provide the ribosome antibiotic and the mRNA of my interest with all the translation machinery, I can say in which position is initiation started. And this I precisely know. And again, I can correlate with my sequence because I have designed the template. I know all the sequences. So in my case, because I have 3 overlapping reading frames, I have known after this technique that ORF3 is translating in response to the LSAP antibiotics. So that's why this technique is really powerful, because if you would like to design some of the mRNA which you are not sure whether which is translation is started, this techniques give you a really precise result, or maybe sometimes also tell you the mechanistic insights of the machinery. So from this overall, like this few experiments, I really know that LMBO expression is triggered by the LMRC. It means it's maybe participated in resistance, but is much more in a regulation and in a signaling. And we would like to study the signaling part. From this also we know there were 3 ORF overlapping reading frames, but in response to the LSA antibiotic, ORF3 is translating. For the future work, I really would like to do some more toe printing with the same template in presence of the LMRC and its variant mutant, so we can really see what these protein can do with the initiation complex. And in a further future, we would like to study in much more deeper. So we would like to do some of the in vitro complex assembly and try for the cryo-EM. So this is all. And at the end, I really would like to thank my team, the Irianata and the Gabriela Valikova Novotna, and these are my fundings. So thank you. Am I audible, or I really don't know where are
Yes,
my...
Yes,
Yes.
Dr. Durga. Ruchi ma'am?
Ma'am,
Yes.
in your template that you designed,
Yes.
Was the open reading frame like not possible to, not get overlapped after that, like in the design one?
No, so maybe, okay, so if you see this scheme, we actually took whole this sequence. So from the bioinformatic analysis, we know there are 3 ORF, but these are really overlapping. So if you see this like a TGA, it should stop here, but again, it is like starting with the TGT.
Okay.
GTG, sorry. And
रोहित सर,
similarly,
रुचि मैम को अनम्यूट करिए, वो अनम्यूट नहीं कर पा रही हैं.
And similarly, when we are ending the second one, it's already started for the third one. So we know there is a sequence and where the 3 possible ORF, but we are not aware which ORF is really translating. And that's why we took the whole sequence for the designing the template.
Rohit sir.
Yeah, sir. It's getting unmuted now. Okay. I'm really sorry I was there, but I was not able to unmute maybe because of some technical fault. Thank you, Dr. Durga. It was a nice presentation, though late, but it's open for questions if there are any. I think one person is Dr. Chetan Pandey has already interacted. Anyone else interested in knowing something can please ask questions from Dr. Durga. Okay, I am new to this. What you're doing? So can you please tell me what is toe printing? Dr. Durga.
Yes, so ma'am, actually toe printing, if, for example, if you are not, okay, so if you have some of the mRNA, but you are not sure where the initiation started, or in response to the some of the antibiotic, the initiation is started a little bit later, or if it is specific some of the amino acid. So toe printing is a very good choice for these kind of experiment where you can really know where exactly ribosome is stalled in response to the any ligand or small molecules.
Okay. Thank you, Dr. Durga. Anyone else?
किसी की कोई क्वेरी है तो प्लीज हैंड रेज करिए, मैं अनम्यूट कर दूंगा। अगर किसी को कोई क्वेश्चन पूछना है तो आप हैंड रेज कर सकते हैं।
Ma'am, I had one more question. What is the fluorescence probe, or for this translation to happen? What is the fluorescence probe that you used, like to see screening?
It's a cyan, it's a yellow YFP, and this is actually with the primer. So when, for example, when you design the DNA template, we actually consider all the things. For example, the ORF which you are interested, the RBS, and also you take some of the primer, for example, T7, and because you already designed this reverse transcript like primer with the fluorophore which is CF5P in this case, you also take these sequences. So when you're designing a template, actually we are considering all these things, and then you can able to do the further, because for the first set of the primer you really need some of the 5' and the 3', so you can get the whole mRNA. And when you are seeing, okay, there may be some translation will be going on, you are able to again do the same primer with the fluorophore. But it's not like only one fluorophore you can use. I think you can really use some more.
Okay. Thank you, ma'am.
Any more questions? I think there are no more. So thank you, Dr. Durga, for such a nice presentation, and it apprised at least few of us of the new technology and new terms, right? So we wish you all the best, and hope you submit and come back and with your future work and enlighten us with your work. Thank you so much.
Thank you, ma'am. Thank you, Scott. Thanks.
So can we call Dr. Tabish? Can we call another?
Yes, ma'am. You can.
Yes, ma'am. Yes, ma'am. Sure.
So our next speaker is Professor Dinesh Yadav. Professor Dinesh, are you there? Okay. So we welcome Professor Dinesh, who is a professor at the Department of Biotechnology and presently Director of the Research and Development Cell and Nodal Officer of the IPR Cell at DDU Gorakhpur University. He has been the Dean and the Faculty of Rural Sciences, so he has many administrative positions to his accolade, and he has also availed DST Boycast Fellowship at the Australian Centre for Plant Functional Genomics. So he's an enlightened researcher, and he's the life member of Scientific Society, namely BRSI Trivandrum, and SBC Bangalore, Indian Science Congress Association Calcutta, UPAAS Lucknow. He has delivered more than 100 invited talks and lectures. So, and he has performed several research projects with funding agencies like DBT, UGC, UPCST. He has published more than 150 research papers, including book reviews, chapters, and his research area is molecular biology, bioinformatics, plant biotechnology, and enzyme technology. So we have a very enlightened and distinguished researcher amongst us. So we request Professor Dinesh to please start with his presentation.
Okay. Whether the slides are visible or not?
Yes, your slides are visible.
Okay. So before I start, I would like to thank the organizer, especially Tapish, who has given this opportunity to present actually the work which we are doing for the last 23 years. And the best part is that we are trying to incorporate the new developments, basically the genomics and the bioinformatics in our research. And the two basic areas where we are working is basically the plant transcription factors and the microbial enzymes. So I would like to give a very brief introduction about these two different aspects of the work, one related with the plant system and the other related with the microbial system. And the second thing is that what we are doing, starting from the conventional part and coming to the recent omics-driven research part. So if there is any question in between, also you can ask. So these two areas which we are working is, one area is the genome-wide identifications, characterization and expression profiling of the two different transcription factors are there. One is DNA binding with one finger, and the other is nuclear factor gamma. And this we are trying with the different crops, basically the sorghum, pigeon pea, chick, and sugarcane. The other aspect is on the microbial enzymes, where we are trying to go for biochemical, molecular, metagenomics, and bioinformatics of the microbial pectinases. And this group of enzyme is extensively utilized for different commercial applications. So we are concentrating on this pectinases, and in this particular group, we are more emphasizing on the pectin lyases as compared to the polyelectrolysis and the peptide lyase. Now, if you talk about the microbial enzymes research, if you try to see, there are three-dimensional aspects are there. One aspect is related with the production part, where there has been several innovation has been done. The other part is the basic characterization of the microbial enzymes, where you try to go for stability, activity, kinetics, and the specificity part. The third part, which is more important nowadays, is basically related with the innovations or the manipulation of the microbial enzymes. Now, this part is where there is an intervention of bioinformatics, there is an intervention of molecular biology, where you can try to clone a desired gene coding for the microbial enzymes and go for an expression. Second part, you can also go for a site-directed mutagenesis in order to have some specific function. There is also possibility of rational protein designs, and the most of the best, or you can say the state-of-the-art technology in the enzyme technology is the directed evolution, which you might be knowing that recently the Nobel Prize has gone basically with this technology. So this directed evolution is basically to manipulate the enzymes for a desired functions. The metagenomic approach is coming up because we know that most of the microbial system which we are using are the limited microbial enzymes which we are able to explore because we don't have the tools for it. But metagenomics provides to explore the remaining 98 to 99% of the microbial genomes, where there is a potential for different types of enzymes, different types of metabolites. And the bioinformatic part has started with the availability of the genome sequences of the microbial system, where people are trying to predict the types of the microbial enzymes which is there in the different types of the fungal or the bacterial system. So these are the three major aspects of the enzyme research, and we are trying to use all these three aspects for the pectinases group of enzymes. So we have extensively worked with the pectin lyase. These are some of the reviews and the chapters which we have published for the last many years. This one of this review is widely acclaimed also. These are the initial part where we started the microbial enzymes, where we started searching for the fungal strains, which has got a potential for production of the pectin lyase or the polyelectrolysis. And these strains are indigenously strains which has been isolated from the soils. They have been characterized for the pectinases and the PGs, and further applications for retting and fruit juice clarification has been demonstrated. These are the two major applications of these enzymes, which has industrial implication also. The outcome of this initial research is that we have more than 43 fungal gene sequences which has been submitted to GeneBank. Accession numbers have been allotted, and there are several pectidized and polygalectal gene sequences which have been submitted. So we are trying to use the sequences for further applications. We have also used this metagenomic approaches where we have tried to standardize the methodology, and we have tried to get some of the strains, some of these microbial strains with the potential for better pectinases. These are some of the publications which is solely based on the bioinformatic analysis, and this bioinformatic analysis is the analysis of the sequence which is available in the databases, where we have tried to characterize these sequences for different attributes of the bioinformatics, like phylogenetic analysis, multiple sequence alignment, motif distributions, three-dimensional structural predictions. These are some of the initial publications you can see, which is solely based on the bioinformatic aspects. This is a recent publication where we are trying to concentrate the fusarium genome, and we have a lot of fusarium genome which has been sequenced. So what we are trying to do is that we are trying to fish out the total number of pectin lyase genes which are there in these different species of the fusarium, and what sort of functional and structural diversity exists in it. So we have made an extensive bioinformatic based approaches like phylogenetic analysis. We have also carried out the three-dimensional structural analysis of this pectinases of different groups as per the phylogenetic analysis which we have achieved. And these are the initial things which have a bioinformatic approach, like multiple sequence alignment. These are the structural analysis of the pectin lyase from the fusarium genomes. So this part, basically what we have done initially is that the intervention is initially the purification and the characterization, which is the conventional part. The second part is the in silico characterization of the pectin lyses, polygalectins, and pectin lyase protein sequences, which is representing different types of the source organism, followed by the validation in terms of PCR amplification, sequencing, and sequence analysis of the pectin lyse, pectid lyse, and the PGs. Then comes the genome-wide analysis. This is the most important thing, because once the genome is available, you can carry out the genome-wide assessment. So we have carried out pectin lyse genes from whole genome of Aspergillus flavus. We have also tried to go for the 28 pectin lyse proteins of Aspergillus species, especially if emphasizing on the three-dimensional structural predictions. And we have also tried to see that what sort of a genome-wide identification or diversity is there in the PG-like genes in the different plant genomes. And the genomes which we have selected is Medicago, Vitis, Horizon, and the sorghum. So these are the initial things which we have done in the microbial pectin lyse. Now, the future work plan in this direction is that we have wanted to go for expression of the cloned pectinases. We wanted to characterize some of the novel pectinases as screened from the soil using metagenic approaches. We also trying to get some enzyme emulation using some nanomaterials. This is the work which we have not yet started, but still is in plan. The last part, which is the most important, is the directed evolution of the pectin lyse for the enhanced catalytic activity and thermostability. This is the large, it's a long-term goal, but it's still some sort of initial work has been done. So these are some of the financial supports which has been there with reference to the microbial enzymes project. And you will see most of these projects are the postdoctoral fellowships and some of the fellowships to the PhD scholarship, but still we have some UGC projects also. Coming to the next part, which is on the plant transcription factor, people may ask why you want to go for a plant transcription factor. So you know that in terms of agriculture, there are a lot of constraints are there. The constraints basically emerges from population expansion, urbanization, shrinking of arable lands, biotic and abiotic stresses, and the climate change. So in order to address these constraints, we have a lot of technological innovations for the last, starting from the conventional plant breeding to the various type of genome editing technologies. Each and every technology has some benefits, and that is what we have to take into consideration if you want to go for a production or higher production of the crop production basically. So with this development, everybody knows about the green revolutions, the evergreen revolution. All this basically reflects the technological evolution, which basically aims for the global food and the nutrition security. Now you will see there is an amalgamations of different omic technology nowadays. People are always talking about there are different types of omics. You can call it as a genomics, proteomics, transcriptomics, metabolomics. So there should be an interface where we can use this type of information in order to address some of the constraints which is not being addressed by the conventional plant breeding. It is not that conventional plant breeding has failed. It is nothing like that. But definitely there is a limitations where we have to get support from the recent technologies. So this is how you can see in the crop development. a lot of genome sequences has been deciphered for the last 20-25 years. You will see several plant genome sequences has been is available now, and this sequence availability is the initial step. So once you have a genome sequence availability, then only you can think about identifying the genes, identifying the regulatory sequences, which could be a potential target for the modification or the manipulation of the plant system. Indian has always been you can say plant scientists, they have achieved a lot. And in fact, the first thing which started with the rice genome sequencing, where India participated in the international genome sequencing program. So India has a lot of expertise available. So India participated in rice genome sequencing. They have participated in the tomato genome sequencing. They have also deciphered the, you can say, these pulses. This is another thing. Then chickpea, pigeon pea genomes have been sequenced, where India has participated. One of the most complex genome sequences is the wheat genome sequences, and India has also participated in the International Wheat Genome Sequencing Consortium. So this basically reflects that the government of India has given a lot of money, a lot of interest that this genome sequencing of plants should be done, because this will provide you an information where we can try to go for the manipulation of the plant system for different aspects. Either it may be to the yield, or it can also be to address the biotic and the abiotic stresses. So with reference to plant system, I just told that we are basically working with the two different transcription factor. One is DOF, DNA binding with one transcription factor, and the other factor is the nuclear factor gamma. So these are the two different transcription factor, and they have a different domain basically, because transcription factor, they are characterized based on the specific type of domains there. So DOF DNA binding is a you can say it is a plant specific transcription factor. It is not found in other systems. And one of the most important aspects that why we should go for a transcription factor is that once the genome sequence has been deciphered, people have found that more than 5 to 10% of the annotated genome sequences, they basically codes for the genes of the transcription factor. So definitely they have some specific application in the regulation. So this DOF has a conserved 50 to 52 amino acid domain. You can see the structure of this DOF domain having a zinc as in the center. And they are playing a diverse role related to the growth and the development of the plants. As far as the bioinformatic part is concerned, you can see, if you try to see the DOF DNA transcription factor from the different plant systems, this is just a representation of the multiple sequence alignment. There are some conserved regions, like CPRC region is there. So based on the conserved domain only, you can try to fish out the diversity, or fish out the total number of DOF genes present in the different plant system. And these are the outcome of the bioinformatic analysis. You can see there is a lot of diversity. What we have worked is basically we have worked on sorghum, where we have identified 28 DOF genes. We have worked on saccharum, where it is a 25 genes, Cajanus 38 genes, and Sisal 37. And now we are working on the millets. So basically, with the help of the bioinformatic, we can predict that this number of genes are present in the this plant system, and they have a diverse role. You can see carbon metabolism, nitrogen metabolism. They are also involved with the seed storage, protein accumulation, biotic, abiotic stresses. So several functions are being governed by this transcription factor, that is the DOF transcription factor. The other transcription factor is the nuclear factor gamma. This is a very complex transcription factor in the sense it is a trimeric complex having 3 different subunits A, B, and C, and there is a different types of interaction. First, where B and C interact, and ultimately it interacts with the A to govern a particular function, and they are binding with a specific region, that is CCAAT, that is the cis regulatory element. And this CCAAT is one of the most commonly observed regulatory elements which can be formed. And the best part is that this nuclear factor gamma, initially it was found in the animal system, where each subunit was being coded by a single genes. But in plant system, it's different. Each subunit is being coded by a number of genes. So you have a number of combinations of the NF5 genes in the plant system, which could be involved with a different purpose. The basic initial reports has been found that the application is more on the drought resistance. This nuclear factor gamma has been more appropriate as far as the incorporation of the drought resistance. So this is this structural analysis. If you can see the domain of A, B, and C, what are the interactions domain, what are the DNA binding domain, and these are the different regions which can be, which has already been identified based on the sequences of the NFI A, B, and C. So the bioinformatic part which we are doing, this is a overall picture what we are doing in the bioinformatic analysis. It starts with the availability of the genome sequences, then in silico predictions, then annotation and physiological characterization. You can also go for gene organization and chromosomal localization, motif distributions, cis-regulatory analysis, evolutionary study, diversity analysis. You can also go for in silico expression, or you can call it as a digital expression analysis, gene ontology studies. The other aspect is you can also go for the structural analysis. So if you can go for a three-dimensional structure, you can also go for the talking study. So with the availability of genome sequences, you can do a lot of work. And that will provide the initial step for further expression or further wet lab-based experimentations. So starting with the sorghum gene, we started with the sorghum where in 2009, this genome was sequenced. So using this same methodology, we have predicted the total number of genes. And these are the 28 DOF transcription factor genes which has been identified. We have tried to characterize them in the gene, basically the gene structure, whether it is intronless, 1 or 2 introns. These are the chromosomal localization of the sorghum DOF genes, 28 sorghum. You can easily see that in many of these chromosomes, there are multiple DOF genes are observed. And in many of them, there are only single DOF genes. So there is a lot of diversity as far as the appearance of the DOF genes on the different types of chromosomes. This is the multiple sequence alignment. Again, you can see the CPRC region, which is the conserved in the DOF genes. This 4 cysteine residue is very important because this is associated with the zinc fingered structure of the DOF family, which is shown here in the sheeted form. These are some of the phylogenetic analysis where we have tried to go for a substantive phylogenetic analysis of the sorghum along with the other crops. This is an extensive, you can see, where we have talked about the phylogenetic analysis of sorghum with the 2 model system, that is Arabidopsis as well as with the rice. So Arabidopsis is the dicot model and the rice is the monocot model. So why we have done that? Because most of the information was already available with the rice and the Arabidopsis, and we wanted to see how this sorghum DOF genes is correlated with these 2 different systems. So after this validation, the next step starts with a wet lab experiment. So we have gone for a amplification cloning sequencing of all these 28 DOF genes. I will just go fast because this is a very regular, very routine process. This is the genomic DNA isolation of the 2 from the sorghum variety Panchari 5. These are the different DOF genes which has been amplified. Then it has been cloned into 2 different vectors, PGMT-AZ vector and PZ12. There are 2 different types of vectors, but we have tried to clone all of these genes. These are the cloning steps, which is very common. And after cloning, again, we have sequenced it. So earlier it was a predictions, but after cloning, again, we have sequenced. We got the accession number also, and we have found out that most of the predictions which we have done, it was correct. So then we went for the 3-dimensional structural prediction because it was not available at that time. So we went, there are different methods. So we went for ab initio modeling based methods. And these are some of the initial steps where you go for the identification of the templates by iTaser methods. These are the different types of proteins, their energy minimization, after minimization. And these are the structures of all the 28 DOF genes. You can see these are the structure which has been predicted. So these are the structure. These are the information about the Ramachandran plot, whether the model which we have prepared is correct or not. So it was definitely based on the percentage, it was validated. These are the structural motif distribution of all the 28 DOF genes. Their distribution in terms of different like sheets, beta alpha, beta units, beta hairpin, gamma turns, and all that. Then comes the final step, which is the expression profiling. So you can see predictions, then cloning, and then comes the expression. So we have also gone for a real-time based expression of this 28 SB DOF genes. And this is the real-time expression profiling heat map, which basically was subjected for different stages, starting with the 5, 10, 15, 20, 25 day after flowerings. And expression profiling, I will just go what was the outcome. The expression profiling basically revealed different types of ubiquitous high level of expression was observed by SB DOF 8, 12, while DOF 9 and 23 revealed a very low level of expression. Similarly, if you can see that 50% of the total DOF genes, they are expressed during the seed development stages in the case of sorghum, which was very much similar to the rice, wheat, and Arabidopsis DOF genes. Further, if you see, there are SP 6, 8, 20, 28, they have revealed a very higher transcript level in seedling stage, irrespective of any specific DAF period. And the transcript level of DOF 10, 14, 15, 16, 25, 26, 27, they were relatively lower in all organ testers as compared to the other SB DOF genes. Now, when we subjected it to stress, what we have observed, the 23 SB DOF genes analyzed for expression under salt and drought stress revealed 16 DOF genes showing differential expression in at least one stress. So expression profiling under salt and drought stress was done with the help of actually facilities available at NIPJ with Dr. Naveen Best. So we have done this expression profiling, and ultimately we found 3 or 4 important genes which were showing response to abiotic stress, both the drought and the stress tolerance. Then what we did is that we also thought that why not to use this DOF transcription factor as a functional marker. So we tried this DOF domain and gene-specific primers we have designed, and we have taken different crops. Some of them were cereals and millets. Almost 12 different cereals and millets were taken, and we went for the PCR-based amplification. And these are the amplification profiling which was analyzed with the help of the phylogenetic-based analysis and similarity coefficient. A dendrogram was made, and it revealed that whatever DOF domain and gene-specific primers are there, they definitely can be categorized and they can be used for the classification which was as per the conventional classification. So it can be used as a functional marker. The next step, what we did is that we wanted to make a comparative analysis of sorghum with the sugarcane, both at C4 plants, C3, C4 plants comparisons, and it was solely a bioinformatic-based analysis. And this is again another work. The similar type of work we did in the P, identification of the genes, DOF genes, and characterization. Then we did the same work in the chickpea crop. The crop is different, but most of the activities are similar because the tools are same, but the analysis part may be quite different. And we also try to go for the promoters of the PBF DOF genes to see that how exactly they are varying. And we have made this again, the genetic diversity assay with chickpea cultivars, again to see it whether it can be used as a functional markers or not. Next, NFI, you can see NFI is a very important factor I have already told. So we have also identified different types of NFI transcription factors. Some of this transcription factor was used for extensive analysis. And this structural part has also been done with the nuclear factor B2 and C15. We have gone for the expression profiling where B2, B4, and C15 genes, they have shown different tissue level expressions. So these are some of the expression profiling. I'm not going in detail that how exactly we have done, but what we have done is that we have identified one of the NFI genes which is very much expressive under the drought tolerance conditions. So this has been published in experimental botany also. This is the paper which came. In fact, this was the work which I did in Australia. So this is the constitutive overexpression of wheat NFI-B4 gene in transgenic wheat significantly improves the grain yield. That means you are increasing the grain yield also, and you are trying to incorporate the drought tolerance. This is one of the basic, very important work which we have tried to work there in Australia. The same type of work as far as what we have done in the DOF, we have tried to carry it out in the case of nuclear factor gamma. So we have gone for genome-wide identification of nuclear factor Y in sorghum crops, and we have identified the total number of genes which is there for Y, A, B, and C. So these are the total outcome publications, and these publications are, I would say, it is more of bioinformatic and genomic-driven research which has been carried out in different crops with reference to two different transcription factors, the DOF and the nuclear factor gamma. So the future plans is basically we wanted to go for further expression analysis of some of the NFI and the DOF genes, and we have to see whether this could be further utilized for the crop improvement or not. These are some of the financial support as far as this work is concerned. Again, you can see there is Australian Boycott Fellowship is one important support, but we have some DST women scientists also who have worked on plant system, basically the DOF and the nuclear factor gamma. These are some of the recent publications. This is the one paper, book actually, which we have published, where we have tried to go for giving a brief description about the bioinformatics in agriculture. And this has been forwarded by my supervisor, Professor N.K. Singh, I think, who is worldwide known for the genomics work for the sequencing. He is the stalwart in the genome sequencing and the crop improvement. Particularly now, presently, he is a national professor at Indian Institute of Plant Biotechnology, Pusa. These are the recent 2023 publications. Most of them, they are reviews working on the two different dimensions. One, we've talked about the microwave pectinides, pectinases, millets model, where we have tried to go for nuclear factor gamma. So this is the recent 2023 publications of our group. These are some of the other publications. Thank you very much. If you have any query, I would definitely like to answer it.
Thank you, Professor Yadav. The house is open for question answers.
Sir, I had a question. First of all, the lecture was really interesting. And sir, there was this one slide in which you were showing DOF transcription factors.
Yeah.
They were increasing as complexity of the plant was also increasing. So Chlamydomonas had like one DOF, and like others had like a lot of DOF. So is this a lineage specific trait that you would like to say that it's lesser?
Actually, this answer cannot be complete in the sense that because we have not predicted in many of these genomes. So unless until we are going to predict these DOF genes in almost all gene sequences, then only we will come up to know whether there is some sort of a linearity is there or not. But though it is predicted, as the genome sequences complexity increases, definitely the number of genes coding for the transcription factor may be definitely higher. That's what we are predicting.
Okay. Also, sir, like as the DOF gene transcription
Yeah.
factors were responding to stress, like during expression profiling, can we predict that this expression profiling will also be obtained if it is subjected to infectious stress?
Definitely. There is actually people are now working on two different aspects. One is abiotic stress that is there, but people have also reported that this DOF transcription factor or nuclear factor gamma, or there are a number of transcription factors there. It's not like the only two transcription factors are there. They are somehow related with the biotic stresses also.
Okay.
So people have reported different types of transcription factors because we are working with these two transcription factors, but there are a number of other transcription factors where people are working on it.
Okay.
Okay.
Thank you, sir.
Okay, thank you.
Any other questions? Sir, I have one. Sir, I have one question.
Yes.
Sir, when you modify, as you study the gene sequences, so you said that the government of India is paying a lot of attention on the study of these gene sequences. So, do you plan to modify these sequences, and would they be classified as genetically modified food?
No, not like that actually. Actually, what I want to convey is that the government of, because genome sequencing is a very initially it was a very costly business. That's why India has not participated in the human genome sequencing project. But later on, government of India realized that if we are not able to get the expertise of the genome sequencing, we be losing the race of what the improvement is there. So if you are going for a genome sequencing, you are basically first trying to know that how many genes are there, what are the different types of regulatory sequences are there, and then these gene sequences. For example, there are maybe some genes of agronomic importance, which may not be possible by conventional breeding to identify. It may take a lot of time. But with the help of the sequence availability, you will be able to identify the genes of agronomic traits. And then these genes could be further modified for either in the same crop, where you cannot go for a transgenic approach. You can go for the recent based genome editing technologies, where you don't have to go for the transgenic approaches. And you can try to modify the crop system. That is what I want to convey.
So, to the extent I understand, that means you select the best breeds amongst them, and then you'll.
Sure.
Oh, that is what it meant, right?
Sure.
Okay. Thank you. Any other questions?
Sir, if we would like to understand expression, like overexpression profiling, where should, what are the best sources of understanding this technique, of gene expression profiling?
No, actually, in what way you want it? Because you have to study the textbook. That is the first initial thing. And then you have to go for the review articles if you want to go for the expression profiling history. You're working in some particular system or what?
I just wanted to know, how is expression profiling at ease to a person when he wants to do it?
Actually, nowadays, there are a lot of review articles are available exclusively on the expression profiling approaches. You have real-time based, you have a microarray based, there are different approaches are there. So if you try to read some of the recent review articles, you will be able to know that what is the state-of-the-art technology available with the gene expression part or the overall genome expression.
Okay, sir.
If you want, I can give you some of the papers which will be there.
Sure, that would be great.
Sure.
Any other queries, questions, suggestions? So if there are no more questions, so I would like to thank Professor Yadav. You're doing a commendable job, and as we can see, you have extensive work and extensive experience. So definitely would take India on to some international platforms with some good publications. Already you've taken, and maybe some products are also going to come, because being from IT, I think my focus is only on products and patents. So we wish you all the best to see you there. Thank you so much.
Thank you very much. Thank you.
Thank you.
Thank you, Dinesh sir.
Thank you very much. Thank you.
So, Professor Dr. Kidwai, shall I proceed with the vote of thanks? Or
Yes, ma'am.
okay.
Yes, ma'am.
Okay. So, Professor, Dr. Yes, first of all, at the outset, I would like to thank the organizing team for inviting Dr. Khan and myself for the for chairing or actually coordinating the session. Chairing is a big term, so it's just coordination, and it was a very enlightening talk from both these speakers, Dr. Durga and Professor Yadav. They made us aware of the new technologies and the work which is going on in the diverse field, especially for me and many other students and the delegates who have joined. So it was a nice presentation, nicely conducted within time, beautiful slides, lot of matter, actual matter, scientific matter. Thank you very much for sparing your time, and we wish that such conferences, online, offline, are conducted so that there is sharing of knowledge. Thank you so much. Thank you, Dr. Neera and Dr. Kidwai. Thank you very much.
Thank you
Thank you,
so much, ma'am.
Ruchi ma'am.
Thank you so much, ma'am.
Yeah, anytime.
Ma'am, I would like to extend my heartfelt thanks to Dr. Khan and Dr. Ruchi Chawla for chairing the session so smoothly. My regards to Dr. Mahar and Dr. Yadav for enlightening us with your knowledge and your gracious presence during the event. Next, we will move forward with the oral presentations, and I would like to hand over the entire session to the next team, session 4. Thank you so much.
Farooq sir, good afternoon. Farooq sir, good afternoon. रोहित सर,
जी 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 सर।
सर अनम्यूट कर दीजिए सर को, और
ओके ओके
जो ओरल प्रेजेंटेशन देने आ रहे हैं उनको भी को होस्ट बना दीजिए, जिससे वो अपने
हाँ
आप
हाँ
को
उनको भी ओपन कर दिया सर,
अनम्यूट
पहले
कर
आप
दें।
ब्राउज करके उनको मैं देख रहा हूँ किस
हाँ,
नाम से ज्वाइन है।
पहले ठीक है,
जी
फर्रुख सर को अनम्यूट कर दीजिए, ये शायद कर नहीं पा रहे हैं सर।
फारूक फारूक फारूक
फर्रुख सर, गुड आफ्टरनून।
How are you, Dr. Tabish?
Fine, sir. I'm fine, sir.
I think we are in the last session we are ready for the oral presentation.
Yes, yes. This is the last session.
Okay. I think the first speaker is just a minute. Dr. Preeti Mathur.
Okay. Dr. Neera, you can unmute yourself, and by the time you can introduce.
Am I audible?
Yeah.
Yes, you are audible.
Yeah, okay. So now we are going to start our session 4, which is basically a oral presentation round. And in this round, we have our chairperson, Professor Farooq Jamal, and I welcome you, sir, for presiding over this session. And I take the privilege to introduce Professor Jamal. He's professor in Department of Biochemistry at Ram Manohar Lohia, Awadh University, Ayodhya. He has over 22 years of teaching experience and more than 27 years of research experience in biochemistry, which include the area of reproductive biochemistry, plant proteins and enzymes in wastewater treatment, and insect pest management of agriculturally important food crops. He has around 74 research publications in reputed international and national journals. He has around published a monograph, and edited 2 books by international publisher. Beside guiding several research students, he has completed several projects sponsored by UGC, CST, UP, DRS, UGC, SAP, and state government of UP. He is also editor of few international titles and has been bestowed with fellowship from CSIR and Ministry of Health and Family Welfare. He has been conferred with Excellence in Teaching Award and Lifetime Achievement Award from the Society of Agriculture Innovation and Development. Under his leadership, the Department of Biochemistry has flourished with excellent teaching, research, and success of students in qualifying CSIR, UGC NET, DBT JRF, ICMR, and other national level examinations. His engagement in different capacities include Director IQAC, Coordinator NACSEL, Coordinator UGC Cell, including Coordinator of RUSA scheme, and many more. Now, along with my team members, Dr. Anju Singh and Dr. Kunal Singh, I welcome you, sir, and I humbly request you to take over the session. Thank you, sir.
Thank you, Neera ma'am. Am I audible?
Yeah,
you are audible.
Anju. Yes.
Yeah. With the permission of chair, now I would like to invite Dr. Preeti Mathur for her presentation. So, ma'am, please start.
Dr. Anju, please brief about the guidelines of the oral presentation.
So you all have 8 minutes, 6 minutes for presentation and 2 minutes for question ask. So kindly stick to the time and stick to your limits. Okay, so we'll start with your presentation, ma'am.
Am I audible? Am I
Yes,
audible?
you are, ma'am, audible.
Yes, you're audible. You're audible.
So,
Hello.
good afternoon, everybody
Hello.
present over here.
थोड़ा busy हूँ मैं.
I am Dr. Preeti Mathur, a senior faculty member from Amity University of Biotechnology, Amity University, Lucknow campus. So here I am giving presentation on my work, Flow of Vibhure in Living Planet. I am taking you of world of color. So first I want to ask everyone present over here, what we think about color? Only for recreation? Only to paint beautiful paintings, or to wear what clothes we have to wear, what color we have to paint our walls, what type of furniture, what color should be the furniture and our sofa set, and what color of our clothes. Beyond that, I don't think we think, but I have started thinking on this color flow, because I believe there is a color flow in this universe, in biotic and then abiotic. So I started my work 5 years before, and I am getting very significant results, significant points on this topic, and continuously filing copyright to Indian Patent Office. Have you ever seen feather of peacock? I think everybody have seen feather of peacock, but feather of peacock, please go through very minutely, and you can see the same color of the rainbow, the sequence of the rainbow. We find same sequence in the feather. Mean it is starting with the violet, indigo, blue, green, orange, yellow, orange, and red. The same sequence. Why it is so? We never thinking on this. Actually, we don't think much beyond our books, journal, present, the content on the internet, but we must, as we are in the field of science, we must think that some new things In this way, I want to tell you here that I am continuously working, means I am 30 years experience in the teaching and the research, and I have developed one herbal antibiotic that is in the patent and now going to the market. And the second thing what I am working is the flow of color, what I am discussing here. So we are only limited to existing knowledge, although in our universe that is so vast, and it is made before the 4,500 million year ago. So there are many things that is hidden in the nature. It is hidden, and we have to means decode that information. Our Earth, as I have just discussed, our Earth is the 3.5 billion year ago. So evolution has been taken place and continuously taken, and there's a much things we cannot discover. We have not discovered so far. So this is the color. It's a world of color that I am going to discover, and I am finding continuously I am getting very good result with the help of faculty members of MIT Institute of Biotechnology, MIT University, and also the help of the students. Color, as you know, it's everywhere, from the living organism, the non-living organism, from the bacteria, algae, flower, everywhere there is a color. And we know the one photon of light, it is distributing itself into the 7 colors. Everybody knows. We are doing the experiment on the prism from very 8th class onwards. So I am taking you to the amazing world of bacteria system, prokaryotic system, and we know that there is we have find out and we have find that there is purple bacteria, means again all the bacterial system is there according to the color of the rainbow webcure. We have purple bacteria, we have blue bacteria, we have green bacteria, we have yellow, we have orange, and we have red bacterial system. Algae, the primitive plant on the earth, again it is showing the 7 colors. World of sponges, corals, they also show the 7 colors. Plant system, again showing the 7 colors. Our animal world is showing the 7 colors. Do you know we have rainbow fishes also? Birds, which is showing the colors. Butterfly, the 7 colors. Maybe in the different species 7 color, different genus, but maybe the same in the same species also there are the 7 color. We have 7 color in our metabolism also. Human, which is means we are the topmost on the evolution, and we have the 7 colors, not the superficial level, but internally metabolism, our important metabolism is controlled by the 7 colors, like rhodopsin, the eye color, deoxyhemoglobin, the blue color, cone pigments, again they are showing the blue colors, and some other color. Biliverdin is again showing the yellow color, and the bilirubin and other pigments showing the 7 colors. Means we are internally regulated by the pigments, some pigment, very important 7 color pigment, which is very important for our metabolism. Again, when you do any experiment in the laboratory, the result will be the limitation of the 7 color. We cannot find the other 8 color or other 6 color on the universe, or in the laboratory, or in the chemistry. It's only the limitation is the 7 color. Why it is so? Our means biotech, okay, the biotech, the plant, the animals, microbes, single cell animals, single cell plant, all they are showing the colors, 7 colors. Even in the chemistry, even the metals, non-metals, they are only limited to the 7 colors. So we must think on it. Your gems, the precious gems, they are again showing the 7 colors. The limitation is the 7 color, and all the 7 colors are present in the gems. We display our we color our cloth, we display anything with the limitation of the 7 color. Again, the very important what we have not find so far, and I am working on the same aspect also, why the chakra in our body showing 7 color. Why it is so? And it is even in the sequence. The chakra is in the sequence showing 7 color, means violet, indigo, blue, green, yellow, orange, and red. Means our body system is again the means our system and our means aura is the controlled by the color and even in the sequence. So I have developed this concept, and what I believe that the vibgyor is trapped by the microorganism, and it is in turn it is trapped by the lower plant, lower animal, then the higher plant, higher animal, and after decomposition it goes back to the nature. Means it is again the cyclic process. As you know, nature believes in the cycle. So same with the colors, they are in the cyclic process. So I have concluded.
Dr. Mathur,
yes.
Dr. Mathur, I would like to interrupt you. Already your 6 minutes is over. I think you must try to wind up your presentation
okay.
as early as possible.
So I am coming to the conclusion that everything is in the cycle, and you can see the whole vibgyor. Whole it is in the cycle. We can see only half, but actually this rainbow is the cyclic, and you can see it is touching the earth and goes back to the nature. Again touching the earth and goes back to the nature. So I am going to find out, and I am filing patents. I have filed 6 patents. And 6 patent, it is having more, means the 1 patent having 2 and 3 laws, means I have developed 15 laws so far. And I want to share same, the patent, and then the first patent, second patent, like this. There is a many patents. I have published 1 book also. And I want to ask everybody present here to just have this book in your library and introduce your student, because it is the very new science. So benefits will be more if we find these, because there are more than 1,000 rules that is our earth is following. But we will many benefits we will get. Like we can understand the disease, what the disease is, the problem, and where it is started, where to stop, and the metabolism also. So there are many, and the time is limited. So I am just concluding. Thanks for your cooperation. Thanks for your listening. Thank you very much.
So the presentation was very interesting. At least you try to catch the attention of the audience on something that is very trivial and frivolous. Okay, you have talked about the colors, the 7 colors, and there's a strong correlation between the 7 colors, which the nature shows you, and what is happening in the metabolic system of the organisms on this planet. And you have touched that even the bacteria and all those microorganisms, they are also of multi-hued, and these 7 colors, they appropriately, if they are balanced, then think of it that you may not be suffering from any disease. So if any color goes down or any color goes in excess, then perhaps I presume that a person may be suffering from one or the other disorders. So you have basically focused on the visible range that ranges from 400 to 600, or let's say 400 to 700 nanometers.
400 to 700, yes.
This is the limitation of the eyes, because these are the colors that can be observed, that can be seen by the eyes. Okay, what about those which falls in the ultraviolet region or in the infrared region? Are they not colors? Because colors, if we go deep down into it, then we will say that it is nothing but some wavelength that can be perceived by the eyes. But there are wavelengths in the ultraviolet region, and there are wavelengths in the infrared region, and these may be of certain consequences. And I would like to ask you that you should also do some work, some research work, some exploration on these aspects. Otherwise, the talk is interesting.
Dr. Farooq, I want to tell you that this 400 to 700 nanometer, this range, this is the limitation of color. Because the ultraviolet and infrared color and ultraviolet, it is again affecting our body. Our skin is also means UV. It's a UV range, which is the means for melanin and for the other metabolism. It is the UV range, which is also affecting along with the visible range, but only this visible range having color, not other wavelength.
Well, that is well said, but the problem is that you see the informational molecule, which is the nucleic acid, they have got the heterocyclic ring, and they basically absorb in the ultraviolet region and does many wonderful things in the if the light is in the ultraviolet region. Similar is the case with the protein, that there are many aromatic amino acids that are affected in the ultraviolet region. So just to focus our attention only on the visible region seems just to narrow our perception about the colors. When you are exploring the things, then the perception should be vivid, wide, and profound. Otherwise, for the sake of the presentation and for gaining our attention, I must appreciate that you have tried to touch a topic which is least talked about, and at least from the perspective of human disease and disorders, this may be quite helpful for treating certain disease, that balancing the colors is actually balancing your life.
Ultraviolet is again affecting our body. Along with the color range, ultraviolet is also. Thank you very much.
Thank you.
Should I unshare? I stop sharing. I am stop sharing. Thank you very much.
Thank you, ma'am. So I would like to call Vivek Harris to present his talk. Vivek Harris,
Yes, ma'am.
42.
Yeah, I'm sharing the screen. 1 second. Hello.
Yes, Vivek, you can start your
Sir,
presentation.
1 second. I'm trying to share the screen, sir. 1 second. Sir, good afternoon. So, good afternoon, one and all. So, before starting the presentation, I would like to confirm whether my screen is visible to everyone or not.
Yeah, you are audible and visible both.
Yes, it is visible.
So, thank you, one and all. Today, I would like to thanks everyone for allowing me to present my presentation on my topic, which is AI-driven advancements in malaria diagnosis, for unleashing the power of enhanced mobile net V2 for precision of Plasmodium vivax detection. So coming to the introduction part, here I would like to say a few words about the malaria. So malaria is a tropical severe disease which spread to people through the infected Anopheles mosquito bite. It is one of the most contagious conditions in the world. And also the WHO data on malaria says that these parasites are responsible for over 200 million malaria cases every year, and which more than 4 billion deaths, not 4 billion, so 4,000 deaths globally every year. Basically, this malaria in people comes from 5 types of Plasmodium species. Among them, Plasmodium vivax and Plasmodium falciparum are really dangerous. It is a big problem, but finding the disease early can help us a lot. The most favored technique for diagnosis of malaria Plasmodium is examining under microscope slides of blood smears in malaria infections, especially compared to falciparum. But the problem is this way takes a long time and needs an experts to identify the parasites. And basically the challenge in this is it is very hard to find low level of parasites. So that is why we have come up with the CNN model technique. So where it will be time consuming and very easy to identify the parasites. So the objectives of our study was like the main objective of our work is to generate a computer-aided, automated, and systematic diagnostic approach for malaria disease caused due to Plasmodium vivax. So one of our objective is to develop a MobileNet V2 model comprising of bottleneck identity and implementing the developed framework in thick blood smear images of PVAX for its rapid detection. And after that, to validate the performance of PVAX detection on patient level with the proposed framework. And once it is validated, then we will compare the performance analysis with already developed models like YOLO, Cascade, etc. So as you can see, this is the methodology which we have done. It's like the very first step is like data collection. So the data collection have been done from the data set, which is broad image bioimage benchmark. In this, it comprises of 1,328 images, where we have subsetted it into the 80 to 20 test ratio. And this accuracy surpasses the 75% threshold and suggesting that the model generalize well to new unseen data. So there we can get the precision recall and F1 score values at 76% reflect the model's ability to correctly identify the positive instances while minimizing the false positives and false negatives. So while here we have selected MobileNet V2 as a classifier, and this choice was because of the accuracy and low interference value. The higher speed detection has been accomplished as a detector with the MobileNet. And MobileNet is a model basically, and the MobileNet V2 is a improvised version of MobileNet with improved accuracy. And as you can see here, this is the architecture of the model where it have been incorporated with 19 basic blocks of bottleneck residual blocks. And the final layer is called as a classification layer, in which we utilized a modified version of MobileNet V2. And this mobile network is suitable for smaller images by varying the filter size and padding and stride as well. And the images of thin blood smear images from image datasets was utilized for proposed network for testing and training. And the images which we have inputted, like they are compressed with the cost-effective 1:1 convolution. And these are the modifications for the MobileNet we have done. So like bottleneck identity with the modified filters and strategic padding and stride adjustments and enhanced data augmentation, specialized pre-processing and customized classification layer, fine tuning hyperparameters and performance matrices for malaria diagnosis. So in these parameters, we have trained the model for the detection of PVAX, like data preparation, data augmentation, feature scaling, model architecture, customized pre-proposing, and customized classification layer, fine-tuning hyperparameters, and all. So coming to the results parts, we have taken the data and we have given like a few trainings to the model, like red blood cells. For the uninfected cells, red blood cells and leukocytes. For infected cells, it is like trophocyte, ring, zooxanthellae, gammacytes. And the model has given us the accuracy of 75%, and the precision is 76%, and the sensitivity was 76%, and the Epsilon score is 76%. So as you can see here, these are the marking, like what is which cell is a ring and which cell is zygote and all those, as you can see in the images. Hello.
Yes,
So these are
Vivek,
the images.
I think your
Yes,
time
sir.
is almost up and you must try to
Yes, sir.
conclude your work.
Yeah, these are the measures, and I am concluding my matter. So, in summary, I would like to tell that our approach was notably breakthrough for PVAX detection in blood smear images, and the sensitivity and robust accuracy achieved through our carefully tailored mobile unit architecture was good. And consequently, our study not only strive toward more effective healthcare outcomes, not only in PVAX detection, but also in broader applications beyond the scope of malaria diagnosis. Thank you.
So, Vivek, your presentation was interesting, and the performance matrix you mentioned was around 76%. It
Yes,
was
sir.
less than 80%. Okay.
Sir, we are
So,
improvising in some other parameters also.
yeah, can it be improved to more than around 80% or 85%?
Yes, sir. We are working on that, sir, as of now.
So, is it specific only for the Plasmodium vivax or some Plasmodium falciparum or something, some other
For
Plasmodium
everything, sir.
species?
For everything, sir. Previously, there were models like YOLO, Cascade YOLO, and mobile net. Basic mobile net was there, but this was used to identify the Plasmodium falciparum itself. So those models were not unable to identify the vivax. So because of unidentified parasites, so it was not easily detectable. So that's why we have come up with the different architecture to identify the vivax also.
Okay.
Yes, sir.
So now I would like to invite Tahmina Khan. We'll start with her presentation. Tahmina Khan, OP3. Tahmina, are you there?
Hello.
Yeah, Tahmina, you're audible. Kindly share your screen.
Would you share the screen or I have to share the screen? Hello.
Yeah, you have to share your screen, please.
Okay, okay. I'm sharing my screen.
Yeah, sure.
Is it visible, ma'am?
Yeah, it is visible and you're audible. Please start.
Okay, ma'am. So, good afternoon, everyone. The topic of my presentation is synthesis, characterization, computational studies, and antibacterial activity evaluation of selected thiosemicarbazones and their copper-2 and zinc-2 complexes. As we all know that since the discovery of cisplatin, metallodrugs have been developed for different medicinal applications. And this slide of mine summarizes some of the important metallodrugs. However, due to some toxic effects or poor solubility in water, there is still scope for improvement. So, coming to the class of ligands upon which I have worked, thiosemicarbazones, they are versatile class of Schiff bases, and they are formed by the condensation of primary amines and carbonyl compounds. They usually contain nitrogen and sulfur donor atoms, and they coordinate very readily with metal ions, especially with the partially filled d orbitals of the transition metals. And thiosemicarbazones have also found to inhibit the DNA biosynthesis by probable blocking of the enzyme RRR, that is ribonucleotide diphosphate reductase. So this slide summarizes the structural features of the thiosemicarbazone ligands. The structure formula of the TSC depicts the formation of an imine, that is C double bond linkage, which is formed by the condensation of the carbonyl group from any aldehyde or ketone and the amine group of the thiosemicarbazide. And owing to their polydentate nature, the TSCs coordinate easily with the transition metal ions. So keeping in mind the utility of the thiosemicarbazone ligand, we designed to synthesize substituted 2-chloronicotinic thiosemicarbazone ligand along with its complexes with copper and zinc salts in +2 oxidation state. Further, the virtual drug likeness assessment and molecular docking studies were also done using automated softwares, and the antibacterial activity of the synthesized ligand and its complexes was tested against 8 bacterial strains. So these are the various materials and methods used for the study. Now, this slide shows the preparatory scheme of the ligand and its complexes. The ligand was synthesized in a 1:1 molar ratio of 2-chloronicotinic acid and thiosemicarbazide through refluxing in ethanol for 4 to 5 hours. And the metal ligand complexes were synthesized in a 1:2 molar ratio of the metal salt and the ligand. And the solution was refluxed in ethanol. And the precipitate was filtered on a Whatman filter paper and washed with ethanol. This is the characterization data of the synthesized ligand and its complexes. The ligand was basically identified by characteristic peaks of thione sulfur and iminic nitrogen in the FTIR spectrum, which got shifted upon complexation as reported previously in literature. And in the 1H NMR spectra, the aromatic proton hump was observed between 6.5 to 7.5 ppm, and the NH, NH2, and OH protons were observed downfield due to the difference in electronegativity. Now, this is the result of the antibacterial activity evaluation, which was tested using agar-well diffusion method. The complexes had improved antibacterial activity against the selected bacterial strains, and the complexes were particularly active against the gram-positive S. aureus and gram-negative E. coli. Slide 11 shows the molecular docking results, which were performed against 2 selected proteins, that is TGF-beta and Janus kinase. And once again, the complexes, particularly copper, exhibited a very good binding energy. Now, these are the other results of the computational studies. The physicochemical properties were calculated using mole inspiration. The MLOC-P value was less than 5, suggesting a probable good oral bioavailability of the compounds, and not more than 2 Lipinski's violations were found in either case. The bioactivity score was also calculated against some of the known drug targets, and mostly it was found to lie in good category. And further, the absorption, distribution, metabolism, excretion, and toxicity properties, that is ADMET, they were also calculated, like the HIA, human intestinal absorption, which was found to be positive, indicating the probable absorption of the compounds. And the epithelial, the human epithelial cancer cell line, CACO2, which is used as a model for how medicines and other substances are absorbed by the digestive tract. And the findings for that also suggested probable permeability. So in future, after a thorough structural characterization of the complexes, other medicinal activities will also be tested, and we will also prepare their mixed ligand and mixed metal complexes. So these are the references used in my study. Thank you so much.
Dr. Tamima, you had done some good work, and there seems to be a lot of potential behind the compound that you have chosen. So you
Yes,
have tried to check its antimicrobial activity or antibacterial activity. Have you
No,
checked
sir,
the
antibacterial activity, sir.
antibacterial activity? So
Yes,
what was the result?
So I have shown the results. The compounds were tested against these 8 bacterial strains, and sir, streptomycin was taken as the standard. And sir, against S. aureus, as we can see, good results were obtained, followed by E. coli. Yes, sir. But sir, we have sent these complexes for X-ray determination so that full structure of the compound is elucidated. And after that, we will proceed with other activities as well.
Okay, good. Nice work. You are carry on with.
Thank you so much, sir. Thank you, sir.
Now it is time for OP4. Ankit and Harshit, kindly share your screen. Ankit and Harshit,
Yes, ma'am.
kindly share your screen.
I'm trying to share my screen. I guess my screen is visible.
Yes, it's visible.
So, good
Maximize it.
afternoon to one and all.
Harshit, kindly maximize it in slideshow.
Okay, ma'am, just give me a second. Trying. Is there some problem?
Maximize it.
I guess it's visible now.
Yes, visible. And please put it in slideshow.
Sure, ma'am. Ma'am, I'm audible.
Yes, yes. Start, please.
Okay, ma'am, just a second. I guess there's some lag. Okay, so good afternoon to one and all present here. I, Harshit Gauri, an undergraduate third-year student from St. Stephen's College.
And I, Ankit Sharma, a third year student from Hindu College, a
Will
university.
be presenting on green chemistry, Odyssey towards sustainable chemistry. We will be talking about reinforcement of cellulose in PMMA. PMMA stands for polymethyl methacrylate. Polymethyl methacrylate is a synthetic resin which is produced from the polymerization of methyl methacrylate. It is a promising polymeric material having several desirable properties like good weather ability, high strength, excellent optical clarity, and dimensional stability. As a transparent and rigid plastic, it is often used as a substitute for glass in products such as shatterproof windows, skylights, illuminated signs, and aircraft canopies. Cellulose, a linear homopolymer composed of beta-1,4 linked glucose molecule, is the most abundant biopolymer on Earth. Characteristic behavior of cellulose mostly depends on its unique structural hierarchy and its biological origin, which provides excellent opportunities. Properties may include high mechanical strength, biodegradability, high strength, high specific surface area, low thermal expansion, and low density. If we talk about cellulose, cellulose is available in different forms. First, we'll talk about microcrystalline cellulose. Microcrystalline cellulose is micrometer-sized cellulose particles which are obtained by the controlled hydrolysis using dilute acids. Cellulose nanocrystals that are CNC, they are obtained by the strong acid hydrolysis of cellulose fibers. They are nanoscale crystalline particles with high aspect ratios. If we talk about the other type of cellulose, that is cellulose nanofibrils, which are obtained from the mechanical disintegration of cellulose fibers, which consist of nanoscale fibrils. Other cellulose derivatives are bacterial cellulose, which is obtained by bacteria, regenerated cellulose, the recycled cellulose, nanocellulose, and there is a combination of CNC and CNF, which is generally used uh, while uh, uh, while combi with the while impo for combination with PMMA, which improves both mechanical and thermal properties. Now we're going to talk about PMA cellulose composite. PMMA cellulose composite are created by incorporating cellulose nanofibers into the PMMA matrix. This can be dispersed into the PMMA matrix by various methods like in situ polymerization, pseudo dispersion polymerization, autopolymerization, and various other methods. The importance of these PMMA cellulose nanocomposites are that they have increased mechanical strength as compared to PMMA, with high tensile strength, stiffness, and good modulus, increased thermal stability, biodegradability and sustainability, weight reduction, and cost reduction. Applications of PMA cellulose composite, they have a very promising future. They can be used as a packaging material because of the enhanced mechanical strength and biodegradability. They can also be used in automotive components because of their lightweight and strong durability. They can be used as interior components, dashboards, and door panels. They can also be used in biomedical devices for fabrication of transparent medical devices, drug delivery systems. They can also be used in construction materials, optoelectronics, coatings and films in paint industries, aerospace components like aircraft interiors. Now I'd like to hand over to Ankit to explain the experimental section.
Thank you, Harshit. Talking about PMMA cellulose nanocomposites, how they were designed. The PMMA, which was a polymer, was directly used available in the market form. And talking about the cellulose nanofibers generation, we took the discarded jute bags. From there, we took on the jute and subjected to the acid hydrolysis, following which resulted in the granulated form of the cellulose nanofibers. Followed by the suspension was created for both of the PMMA cellulose composite. After it, the granules that were obtained of the composite that was designed were dissolved in the chloroform as a solvent, and then they were followed by the solution casting method on the two petri dishes. The film was created, which was dried at the room temperature and then subjected to the hot air oven. And the films of the nanocomposites, which was PMMA cellulose composite, was obtained. Talking about the target area is the water purification, that is the removal of the bacteria or any kind of viruses from the wastewater treatment. On the left, on the right hand side, we can see this is the Na plate of which 3 replicas were prepared, and the bacterial colonies growth was very maximum. When PMMA cellulose composite film that was made was subjected to the Na plate, on the extreme left, we can see that the bacterial growth is nearly negligible to what was observed on the Na plate. And not only the water purification, that antibacterial study, this can be explored. Many of the application are yet to be explored on the same topic. Next slide, please. The only target research area behind this particular research is PMMA metal nanocomposites have already been in demand. They have already been synthesized. The only thing that has been added to it is the green chemistry aspect, which is the nowadays demanding, because it is totally sustainable as well as the eco-friendly approach we are using, because the solvent selection, energy efficiency, and recyclability is what may playing a major crucial role in this. As we can see, the source of the cellulose was the waste jute bag that was discarded. So it is the prevention of the waste and using the creating the waste material into the useful material. So this is the basic approach that we had undertaking, and implying the current overall research towards the green chemistry principles around which it is revolving. Not only if you have seen it, we had used the acid hydrolysis method, so we are also trying to incorporate the use of the greener solvents and moving near to more and more near to the greener approach, which also reduces the extraction and the solvent that are toxic and still in the loop of the work that has been designed. And not only this, incorporating different cellulosic materials like sugarcane, bagasse, rice and wheat straw, recycled cotton, wood fiber, and wood flour can also be incorporated. And we are also looking for it once the characterization results are still awaited. And once they come, we'll be exploring the more of research on the same topic.
Thank you so much, everyone, for listening to us.
Okay, Harshit and Ankit, this piece of work seems to me quite interesting and it has got a lot of potential. Okay, but I can say it is only in a state of infancy, and much more needs to be done before it is translated for use. It is so. My suggestion to you: you carry on with this good piece of work, and which is going to pay a lot in years to come. Because you see, you said that from the jute bags, you tried to get this work done. So many such natural products are there which are treated as a waste material, and then it can be recycled. So this is work is interesting. I think you should. It holds a lot of potential also.
Thank you so much, sir.
Thank you so much, sir. Thank you so much, everyone.
So now it's time for OP5. Zareen Harris,
Yes, ma'am.
kindly share your screen.
I would like to share my screen. Is it visible?
No, it's not visible. I think you have to do something in order to make it visible.
Yeah.
Yeah, it's visible now.
Okay, sir. Hello, everyone. This is Zareen Haris I am a research scholar from Microbiology Department, AMU, Aligarh. My topic is quorum sensing and biofilm interference by bioactive plant extracts with a focus on Moringa oleifera. Now, it's not moving.
Zareen, can you please?
Yes, sir. This is the background of my study. Here, screening of 10 plants was done for the antioxidant. Yes, ma'am.
Please do a slideshow.
Yes, ma'am. Please.
Go on to the slideshow and then click from the current slide. Then it will be visible.
Okay, sir. Is it visible now?
Yes, better.
Yes. Please start.
Yes. This is the background of my study. Here, screening of 10 plants was done for their antioxidant activity. Highest antioxidant activity and total phenolic content was found in methanolic extract of Moringa oleifera. Then liquid fractionation of Moringa oleifera was done in different solvents of increasing polarity, which is further screened for highest antioxidant activity. Now, the most active fraction was evaluated for anti-QS and anti-biofilm activity, and then the phytochemical analysis through LCMS and GCMS was performed for most active fraction. Now, based on this, let's move to the introduction. Infectious diseases, as we all know, are one of the major cause of mortality and morbidity in human and animals. The development of antimicrobial resistance in bacterial pathogens is a major global threat to human health that further complicates the management of other chronic and lifestyle diseases. As per WHO 2019 report, at least 7 lakh people die each year due to infections caused by drug-resistant microbes, and it is expected that by 2050, antimicrobial resistance will become a major cause of mortality, surpassing cancer if no action is taken. Involvement of bacterial biofilms in pathogenesis and its role in providing high level of resistance has further decreased the efficacy of common antibiotics in the treatment of diseases. The progress in the discovery of new antimicrobials with novel mode of action is globally poor since few decades, while the emergence of antimicrobial resistance among bacterial pathogens increased several folds both in clinical and environmental pathogens. It has been realized by major national and international agencies that if no immediate step is taken, we may reach a pre-antibiotic era and control of infections related to MDR will be difficult. Therefore, the development of alternative strategies for combating the AMR problem is globally recognized, and attempts are going on in many directions, including exploration and exploitation of traditionally used medicinal plant extracts and derived compounds with antibacterial, antivirulence, and anti-resistance properties. Indian medicinal plants are known for their rich diversity and therapeutic efficacy in the Indian system of traditional medicine, which prompted us to explore their in vitro efficacy, targeting their growth inhibitory and anti-infective properties regulated by bacterial QS and biofilms. Since plant extracts are known to exhibit several biological activities due to its unique phytochemical composition and properties, therefore, considering the importance of these two global health problems, there is a greater need to investigate and evaluate the plant extracts with dual properties to make it more effective in the management of antimicrobial resistance individually and in combination. Now, these are the materials and methods. These are the bacterial strains which I've used in this study: Chromobacterium oleiacum, Pseudomonas aeruginosa, and a laboratory isolate Serratia marcescens. These two are the antioxidant assays: DPPH free radical scavenging assay and ferric reducing antioxidant power assay. These are the assays which I've used in my study for determining anti-QS activity of plant extracts. Now this table is showing the list of medicinal plants which I have used in my study: Allium sativum, Andrographis paniculata, Brassica gensea, Gymnema sylvester, Moringa oleifera, Murraya quenijai, Tinospora cordifolia, Ecorus calamus, Carum carvi, and Viola odorata. Now coming on to the results. Here, screening of methanolic plant extracts was done for antioxidant activity via DPPH radical scavenging assay and FRAP assay. Here, we found Moringa oleifera as most antioxidant-rich plant extract from both the assays. Now, this table is showing the total phenolic content of methanolic plant extracts, and Moringa oleifera showed the highest total phenolic content, followed by Murraya quenijai and Andrographis paniculata. Now, on the basis of antioxidant activity screening, following plant extracts were selected, and Moringa oleifera has got the highest antioxidant activity, whose fractionation was done in different solvents of increasing polarity: hexane, chloroform, ethyl acetate, and aqueous fraction. Now, this table is showing the minimum inhibitory concentration of different plants against bacterial pathogens: Pseudomonas aeruginosa, Chromobacterium oleiacum, and Serratia marcescens. Now, coming on to the fraction-based antioxidant activity of Moringa oleifera, which has got the highest antioxidant activity. Here we got the ethyl acetate fraction as the most antioxidant active fraction from both assays, that is DPPH and FRAP assay. Now, this is showing the effect of subamices of Moringa oleifera ethyl acetate fraction on violacin pigment production by Chromobacterium violaceum. And at the highest tested subamice of 1000 microgram per ml, approx 78% inhibition in violacin production was observed. And this table is showing the effect of subamices of Moringa oleifera ethyl acetate fraction on inhibition of virulence factors in Serratia marcescens. And it was found that at highest tested subamice of 1000 microgram per ml, there is it was found 71% inhibition in proteoglycan production, 73.43% inhibition in protease activity, and 77.91% inhibition in swarming motility of Serratia marcescens. Now, coming on to next slide. This slide is showing the effect of subamices of Moringa oleifera ethyl acetate fraction on virulence factors in Pseudomonas aeruginosa. And it was found that at highest tested subamice of 1000 microgram per ml, there is 67.63% inhibition in pyocyanin production, 57.16% inhibition in pyoverdin production, and 65.55% inhibition in exoprotease activity, 61.76% in rhamnolipid production, and 65.32% inhibition in swimming motility of Pseudomonas aeruginosa. Now, this slide is showing the representative light microscopic images, scanning electron microscopic images, and confocal images showing the inhibition of biofilm formation in presence of highest tested subamices of Moringa oleifera ethyl acetate fraction. Now this table is showing the list of major phytocompounds as identified by LC-QTOF MS analysis. This table is for the positive polar compounds, and this table is showing the list of major phytocompounds as identified by LC-QTOF MS analysis also, and this is for negative polar compounds. And this table is showing the list of major phytocompounds of Moringa oleifera ethyl acetate fraction as identified by GCMS analysis. Now, finally, to conclude, screening of selected 10 plants for antioxidant activity revealed crude methanolic extract of Moringa oleifera as most active by DPPH and FRAP assays. Methanolic extracts of the three most promising antioxidant active plants, namely Andrographis paniculata, Murraya quinagei, Moringa oleifera, showed IC50 values of 101.05, 36.45, and 20.15 microgram per ml respectively. Other plant extracts showed less than 50% inhibition of DPPH radical. Allium sativum, Gymnema sylvester, Andrographis paniculata, Murraya quinagei, and Moringa oleifera at maximum tested concentration, that is 100 microgram per ml, showed potent antioxidant activity by FRAP assay. The remaining methanolic extracts of Brassica gensea, Tinospora cordifolia, Aquarius, Calamus, Carum carvi, and Viola odorata exhibited weak reducing potential. Methanolic plant extracts contain total phenolics in the range of 1.47 to 132.82 mg per gram of gallic acid equivalent. Fractionation-based evaluation of Moringa oleifera resulted in the identification of the most antioxidant fraction, that is ethyl acetate fraction. Varying level of anti-infective activity in terms of biofilm inhibition by Moringa oleifera ethyl acetate fraction against different gram-negative bacterial pathogens indicated its broad spectrum antibiofilm nature at subamices. The antioxidant active fraction of Moringa oleifera, that is MOEF, also demonstrated varying level of antivirulence activity by inhibiting the production of various QS-linked virulence factors and other bacterial functions in Chromobacterium violaceum, Pseudomonas aeruginosa, and Serratia marcescens. This has clearly demonstrated the broad spectrum anti-QS role of MOAF in different pathogenic bacteria. Phytochemical analysis by GCMS and LC-QTOF-MS analysis of Moringa oleifera ethyl acetate fraction reveals the presence of different class of bioactive phytocompounds. These detected phytocompounds may be largely responsible for the observed bioactivity. Thank you.
So Zareen, you have done a lot of work regarding on Moringa oleifera, and you found that it has got substantial antioxidant activity.
Yes, sir.
So, and you have checked the virulence also.
Yes,
That,
sir.
so what do you conclude from this study? Like, what do you say? Like, if a plant extract has got a huge amount of antioxidant activity, it will
Then it
always
will be
have.
responsible. Yes, sir. It will be responsible for the antivirulence and anti-resistant properties of that bacteria. It will be helpful.
So it is that means any compound which has got a high antioxidant activity will necessarily be responsible for antivirulence.
Actually, it is also it also depends on the major phytocompounds which are detected in particular extract of fraction. It also depends on the phytocompounds also. So actually phytocompound based studies should also be done to check the bioactivity also.
Okay, good work. Nice piece of work. Carry on with it.
Thank you. Thank you, sir.
Now we move on to OP6, Jaisip Chauhan. Zareen, please stop sharing your screen.
Okay.
Jaisip Chauhan, are you there? Zareen, please close your screen. Jaisip Chauhan, are you there?
अंजू मैम नेक्स्ट को पुकारिए.
Okay, OP7, Chetan Pandey. Chetan Pandey.
Yes, ma'am, I'm there.
Yeah, start your presentation, please.
Give me a
Share your
second, ma'am.
screen.
Just want to share this with you. Is my screen visible?
Yes.
Yeah, it is visible. Carry on, please.
Okay, so a very good afternoon, everybody. And I'm Chetan Pandey, and I'm from Hindu College. I have a master's in plant sciences, and today I'll be presenting my work that I've done with Dr. Neha Kapoor and Dr. Vinita Narula. about understanding the differential distribution and activity of some phytochemicals of Berberis asiatica, which are distributed in a very interesting manner. And what about it, I'm going to be explaining in my presentation along with some breast cancer associated HER2 molecular docking research. So, talking about the abstract of my research, we all know how devastating a fungus can be to a plant, and that plant can get infected to such an extent that even a healthy plant like wheat, which is very important to us as humans, can be under the encroach of that particular fungus. So Puccinia graminis triticale is one such fungus, and it infects wheat. And it's a very smart fungus, I would like to say, because when the fungus is under the danger of the weather in the plains or in the plains region of India, it flies all the way up to the Himalayas or northern regions of India to establish its sexual life cycle on the Berberis asiatica plant, or Berberis species, as we can say. And its sexual life cycle, when it is complete and when the easterly winds blow during the February season, the fungus goes and infects the wheat and completes the rest of its life cycle in apt conditions. Now, we wanted to find out that why is the fungus only infecting the leaf of the plant and not the stem? So for that, we saw a lot of literature and we saw a lot of studies done, but we never saw much studies on the leaf. So we did a phytocompound analysis to first check, is the leaf potent enough for the fungus infection to happen or not? And is the stem potent enough to have sustainable phytochemicals, which would lead to cytotoxic or anti-cancer activities? So what is the importance of studying Berberis species, the host of Puccinia graminis triticale, or the secondary host of Puccinia graminis triticale? This plant has been highly used in homeopathy. This plant has been highly used for its antimicrobial properties. This plant has been highly studied for Puccinia's life cycle. But still, after having such a high antimicrobial activity, how is it not able to stop Puccinia from infecting it? So we came up with the hypothesis, which was that let's find out the low potency of the plant's leaf in comparison to the plant's stem. And before getting into the genomic or genome-wide studies of seeing what transcription factors are actually responsible for the gene's resistance or susceptibility to the fungus in the plant, we did chemical analysis to find differences or fundamental commonalities in the leaf and the stem of the plant. And we also did an in silico analysis for the stem's phytochemicals in the treatment of breast cancer-associated HER2 receptor. So my images are not being visible. Just a second. Yeah. So as we can see over here, this is the infection of the fungus on the barberry leaf, and the lower images are the infection of the fungus on the wheat leaf. And the life cycle of fungus is so smart that it is first staying in the wheats, and then it's moving on to the barberry leaf for its digenetic host or secondary life cycle. Now, these are the leaves that were collected by us during our study, and they were highly infected, and these are the non-infected leaves. So when we did the chemical analysis or when we did the experimentation in our lab, first we checked that whether the phytocompounds are present in the leaf and the stem, and which extract can be chosen, or which is the best extract that can be chosen for gas chromatography, mass spectrometry analysis to see the phytochemical presence or absence. And we found that the methanolic extract of the plant had maximum amount of alkaloids, flavonoids, tannins, saponins, terpenoids, steroids in comparison to the other extracts that we had prepared. And then we sent it for GCMS analysis. And as we had predicted, the leaf showed very less phytochemicals in the range from 290 to 345 or 400 molecular weight, which are especially the phytochemicals responsible like berberine, berberine, jetrorizine for antifungal activity, and they were absent in the leaf. And this is the GCMS analysis of the Berberis asiatica stem, which was a study by Nag et al. And they reported berberine, palmitine, and phenolic contents to be present in the stem. But our leaf analysis showed the absence of these phytochemicals. Another important stem phytochemical that we found in our stem GCMS analysis was dibutyl phthalate, whose antimicrobial activity has been discussed in various researches when obtained from other plant extracts. So the outcome of this small first part of our research was that the leaf is, for a reason, prone to the infectious a fungus like Puccinia graminis triticale, and the stem is a rich source or an efficient source of anti-cancer and antimicrobial phytochemicals. And to prove that, we did an in silico analysis against the breast cancer-associated HER2 receptor, in which the natural drug 3OQ, whose PDB ID is 3OQ, which shows a binding affinity of around -14. The other phytochemicals present in the berberis stem also showed binding energy very much near to it, of -11.52 by berberine, -11.02 by zatrorizine, and even their drug likeliness or ADME profiles were pretty good. They were showing maximum no violations to Lipinski's rules for berberine, zatrorizine, as you can see in my table. And these are the 3D molecular docking images of our phytochemical interactions with the HER2 receptor for responsible for breast cancer. And the binding energies obtained were pretty good. And these are the 2D molecular interaction visualization images of our molecular docking from the phytochemicals that are present in the stem of the plant. And yeah, so the discussion or the final aspect of my presentation is that the confirmatory test and in silico analysis of Berberis asiatica extracts prove it to be a collective in-house natural source of cytotoxic phytocompounds. Leaf appears to be a minor source, and now the battle between plant and pathogens that has been discussed from so many years, we can finally move on to understanding the genetic basis or the genomic basis behind the fact that why the expression proteins and why the phytocompounds released in the leaf are so less in number. So this is a special acknowledgement to everybody.
Ethan, your time is over.
Yeah. So thank you for your time.
Okay. Concluded. So again, it seems to be an interesting presentation, and you tried to find out why the infection of this fungus is quite smart in infecting the leaves and completing its life cycle on the leaves. Exactly. So it's, I think, is there, what was the compound that was responsible for this? Can you just elaborate on this?
The absence of the compounds was responsible for this. If compounds would have been there, then they would have been.
4 मिनट में सबको निपटा दीजिए क्योंकि अभी 7वां चल रहा है, ज़्यादा हम लोग.
So the absence of the compound was the reason for the infections, and the presence of compounds were making the stem susceptible and the leaf, the stem resistant and the leaf susceptible.
Presentation. Okay, keep it up. Carry on with the work.
So now we move to oral presentation 8. Sonam Yadav.
Yes, ma'am, I'm here.
Kindly share your screen.
Okay, ma'am.
सब एक जो इनवाइट करना है तो वीडियो ऑन रखनी है मेरे को.
I hope my screen is visible to everyone.
Yes.
Okay. So a very good afternoon to everyone. My name is Sonam Yadav, and I'm a PhD research scholar from Department of Biotechnology, SRNU Lucknow. So the topic of my oral presentation is use of machine learning techniques for the detection of monkeypox virus using skin lesion images. So first we will understand what is monkeypox. Monkeypox is a viral zoonotic disease that occurs primarily in tropical rainforest areas of Central and West Africa, and it's occasionally exported to other regions. So basically, it is caused by monkeypox virus, which is a member of the orthopox virus genus in the family Poxviridae. It's usually a self-limited disease with the symptoms lasting from 2 to 4 weeks. So this is a pictorial representation that how monkeypox virus spread. So primarily it spreads through animals like rodents, monkeypox, etc. through bites, scratches, consumption of bushmeat, etc. Secondly, it transmits from human to human through close contact with infected respiratory tract secretions or skin lesions. The symptoms are intense headache, swollen lymph nodes, backache, fever, chills, etc. So the objective of my work is database development of a robust classification-based machine learning method to perform a feature-level fusion extraction process using convolutional neural network to accomplish excellent classification. So coming to my methodology, so the very first step was to collect the data. It was collected from various sources like websites, journals, news portals, and publicly shared samples. After that, the image is loaded from the data set for pre-processing, and all the images were resized into 64 into 64 bytes so that all the images will be of similar size. After that, data augmentation is done to expand the quantity of data by doing slight changes like vertical slip rotation, horizontal slip, etc. Then feature extraction is then done through ResNet 50 and VGG16 due to its efficiency, and to categorize the images in dataset as it is whether monkeypox or the normal one. Then this is the overall architecture of my model. Like first, the input images are the pox viruses dataset, which is collected from various sources. Then the image is pre-processed so that unwanted noise will be removed, and the image is resized so that to alter the size of the pixels. Then ResNet 50 and VGG16 architectures were selected for the feature extraction process due to its efficiency, and the outcomes of both these models are merged together through feature concat process. Then feature fusion process is done to learn the configuration of the internal features of the image. Then PCH perform for the dimensionality reduction. Then the model is train tested through train test split technique is executed to develop model and to compare the performance of various models. After that, finally, the classification of digital images is analyzed by using the XGBoost algorithm for the evaluation of modified statistical line loss to create a training model. After that, the training model is utilized to run the input images, and the classification images was done whether it is the monkeypox infected one or the other one.
Sonam, you can come on to the result. You can come
Okay.
on to the results. Yes.
Okay, so my result was the model was implemented, and there was a quick diagnosis of orthopox viruses again. And my developed model possesses high degree of accuracy when compared with existing models. And in terms of classification and the detection accuracy, other metrics prove that my model is efficient. So the overall conclusion was that the monkeypox virus is not eradicated yet. It's spreading in many nations. So there is a need for early detection so that to classify whether the skin lesion images is of monkeypox infected ones or the normal ones. So these are the references that which I have cited. Thank you.
Okay, Sonam, your model that you have developed is much better than the earlier models. Okay.
Yes, sir. Yes.
This is what you want to say regarding your presentation.
Sir, like I have done, I have compared my model with the existing models too. So the accuracy rate was 90%. Earlier it was 80 to 85%. So on that basis, I can say my model is very efficient comparing to existing.
Oh. Okay, Sonam. Nice. Continue with the work.
Thank you, sir.
Next speaker,
Jasmine
please.
Chauhan, OP6, he want to present, sir, video permission. Can we allow?
Yeah. Please.
Okay.
Please.
Jasmine Chauhan, kindly share your screen.
Good afternoon, sir. This is audible?
Yeah, you are audible. But is there any slide?
Yes, sir. I am sharing. Mhm.
Kindly share your screen, Jasmine.
Yes, ma'am. This is share.
Yeah. No.
Hello.
Yeah.
No.
Your screen is not visible.
Yeah.
But there is show to seeing is shading. Wait a minute. Stop sharing and again share screen. Entire screen. This is share.
Yes. It is visible now. You can start.
Okay. Good afternoon, everyone. Myself, Jaidev, Research Associate in Indian Pharmacopoeia Commission, Ministry of Health and Family Welfare. I am here to overview about validation of HPLC method for pharmaceutical analysis. What is the validation? Validation is defined as the estimate documentation evidence that provide the high degree of assurance that the specified procedure will consider the procedure, produce a product meeting of predetermined specification of quality attributes. This is used for identification, determination of impurity, and assays. Why validation required? To object the objective of an analytical measurement to obtain a consistent, reliable, and accurate data. Validity analytical method play a major role in achieving this goal. Validation of analytical method is also required for the most regulations. Parameters for validation: linearity and range, specificity, precision, accuracy, and recovery, robustness, limit of detection and limit of quantification, and system suitability. Linearity. Linearity is the ability to obtain the test results that are directly proportional to the concentration of analytes in sample within the given range. This depends on the correction coefficient, intercept, or slope of the uh, regression line. Second, range. The range of an analytical procedure is the interval between the upper and lower levels of analytes that have been demonstrated with the suitable level of precision, accuracy, and linearity. For drug substance and drug products, for assay test method, 80 to 120% of the test concentration. For CU assay, 70 to 130% of the test concentration. For dissolution test method, it is uh, plus minus 20% of the result value of the dissolution. Precision. Precision. The precision of an analytical procedure expresses the closeness of the agreement between the series of the measurement obtained from the multiple sampling of the sample harmonization sample under the prescribed condition. In this test, sample prepared in replicates on the same day and analyzed as the same method. The precision is reported in the term of RSD, relative standard de- uh, deviation. Precision. Precision may be considered in the three levels: repeatability, reproducibility, and intermediate precision. Repeatability. Repeatability expresses the precision under the same operating condition or a short interval of time. Intermediate precision. Intermediate precision is expressed the validation within the laboratory such as different day, different analysts, different equipment, and for others, different system and system column. Reproducibility. Reproducibility expresses the precision between the laboratories. It's assured that the means of an intra-laboratory trial. Accuracy. Accuracy is the
Ashu,
closeness of
if you
the
have any results, sorry to interrupt you, but if you have any results, you can just show it to us.
okay, sir. Conclusion. When the method is properly validated, consistently reliable and accurate result of the is obtained. Also, validation of analytical method is also required for the regulation bodies. Has the very importance to validate any analytical method to has been developed. Thank you.
Okay, what are you trying to emphasize on what aspect you are trying to emphasize through this presentation? Just one or two lines.
Sir, I want to precise the importance of the validation of any analytical method, and to emphasize the result is consistent and reliable.
Okay, good. Next
Okay, thanks,
speaker.
sir.
So now we move on to OP9, Sandhya Maurya. Are you there, Sandhya? Okay, so Sandhya is not there, I think. So it's OP10, Vinay Kumar. Vinay Kumar. Vinay Kumar Bhiman. Vinay Kumar, are you there? Unmute yourself, please. Dr. Vinay, please unmute yourself. रोहित, आपने उनको co-host बनाया हुआ है? Dr. Vinay, kindly unmute yourself.
Hello,
Yeah, share your screen, please.
hello, ma'am. Good
Yeah,
afternoon. Hello.
Yeah, you are audible. Just show your
listen,
slides.
you are audible.
Yes,
Please share your screen.
yes, sir. Uh, um, sir, actually, my PPT is not supporting file. I don't know why.
So we can come on to at the end. I think the next speaker must be invited.
Yeah.
Yes.
Dipankar,
Yeah.
Dipankar, are you
Yeah,
there?
you tell me.
Sandhya Maurya is there, I think. Sandhya, OP9. Sandhya,
Dr.
Hello.
Deepankar.
yeah, Sandhya, kindly share
Yes,
your
ma'am.
screen. We will come to you later on.
Okay, ma'am. Okay.
Sandhya, you present your screen.
डॉक्टर अंजू इनको अनम्यूट करिए डॉक्टर दीपांकर को
Dr. Dipankar
रोहित
को
सर
अभी से संध्या
सर
मौर्य
कह रहे
को
हैं डॉक्टर दीपांकर सर रोमिन को।
हाँ इनको डॉक्टर दीपांकर को अनम्यूट करिए
Hello, ma'am. Should I share?
yeah, you can please.
यस हाँ मिस संध्या प्लीज शेयर योर हाँ
Hello, I am audible.
Yeah, you are audible. Please continue.
Hello, good afternoon, sir. Good after everyone. I am Sandhya Maurya. I am going to present on the topic assessment of heavy metal pollution, associated human health risk in groundwater, a case study of the Raebareli district, UP, India. These are the issues and challenges of my work. Poor groundwater quality, issues like heavy metal pollution, health risk, lack of bioremediation techniques. These are the major research objectives of my work. First of all, I have collected sample and analyzed by using statistical techniques like heavy metal pollution index, evaluate the health risk, both non-carcinogenic and carcinogenic, total hazard index, and also suggest the remedial measure for the toxic heavy metals. Next is introduction. Water is a very useful source for all domestic and industrial purpose and highly polluted for some year, and it is having a bad effect on people. It causes genetic disorders like neurotoxic disorder, kidney, skins, and cancers. And the increased concentration of heavy metals in groundwater might have been caused by either geogenic and anthropogenic activities. Geogenic like rock weathering, and anthropogenic like sewage discharge and using application of fertilizer, pesticides. This is the physiography of the my study area, and this is the water sampling locations and conducting health survey in my study area. This is the research methodology of my research work. And next is the reconnaissance survey of the study area. After health survey, it was found that significant number of individuals are experiencing gastrointestinal issues, arthritis, sore taste, hair loss, high blood pressures, as well as dental fluorosis. These are the methods which is used in my study, use for the statistical analysis of water sample like carcinogenic health risk, total hazard index, heavy metal pollution index, and HQ. This is the distribution of heavy metals. According to BIS 2012, it was discovered that 93.75% of the total water sample are contaminated, mainly lead, arsenic, iron, and
cadmium. And the analysis of groundwater quality using total hazard index, total 1.01 to 8.52 male and children are affected due to total hazard index. And the highest THI value was found at sampling location R16 in the Khiro block of the Raebareli district, UP. And potential human health risk assessment of groundwater. After analysis carcinogenic health risk, the contribution of PB was not detected for cancer risk, and the result also indicated that cadmium had the highest concentration towards the carcinogenic risk with an average contribution of 78.2% children and 45% of male. An analysis of heavy metal pollution index. After heavy metal pollution index, the 60% sample fall under the critical pollution category, means more than 100 HPI values. And these are the bioremediation techniques used for the heavy metal pollution remediation, mainly using natural adsorbent and natural coagulants. Because the chitosan powder used for the remediation of heavy metal pollution, because the chitosan-based material have more sustainable, renewable, low energy requirement, antibacterial, antioxidant, good selectivity, and fast separation rate can be used at larger scale for water purification. These are the conclusion of my research work. The carcinogenic risks were found to be higher for children as compared to male for all the sampling location. And in my study area, the heavy metal pollution caused due to geogenic and anthropogenic activities both. And hence it is recommended that all the sampling stations require interventions and remedial measures to control the level of these toxic heavy metals to prevent the possibility of any irreversible damage. And it is possible to make chitosan powder sources and distribute them to the people of village so that they can drink contaminated free water. And these are the references of my work. Thank you.
Okay, Sandhya, you are doing good work, and you have assessed the water quality, and you found that water is contaminated with many different types of heavy metals and many toxic compounds.
Yes.
So a lot of work has been done, and you are still exploring certain areas where the water quality is, very poor, very bad.
Yes,
So
sir, like Pratapgarh.
yes, yes, yes. Carry on with this work. I would advise you that you may hit somewhere like there should be some way by which you can ameliorate or improve the water quality. Okay,
Yes.
it was nice to hear you.
Thank you, sir.
Next speaker, please.
Sandhya, kindly close your screen. Vinay, are you ready? Vinay Kumar? Okay, now I'm handing over to Dipankar. He'll conduct next oral presentation. Dipankar?
हाँ दीपांकर, आप यहीं से बोल दीजिए, यहीं से बोल दीजिए।
Dipankar, please
Yes, ma'am.
start with the next presentation, OP11.
Now I would like to call upon Pooja Singh for presenting the slides.
Hello, sir. Just a minute. Just sharing my screen.
कोई बात नहीं, आप स्क्रीन शेयर कर देंगे, हमारा लास्ट में हो जाएगा।
Hello.
Yes, you are audible, but you're
So my screen is not sharing.
no.
हाँ पूजा, स्क्रीन पे कुछ दिख नहीं रहा है।
60 seconds, sir. I'm just sharing my screen.
नहीं, मैं तो
जी सर कर दिया है।
Can we do for the next?
Yes, I think
Yes,
it
I
will be
think it will
wise.
be wise. Next.
Now I would like to invite Dr. Prashant Kumar for presenting the slides.
Thank you, sir. Let me share my screen. Is my screen visible to all?
Yes, yes, you are audible and visible. Please continue.
Okay, sir. So, okay. So, slide. So, okay. So, very good afternoon to everybody. So, the topic of my presentation is palladium catalyzed approaches for the selective functionalization of 2-phenyl benzoxygenone. So we know that nowadays we talk a lot about the development of sustainable approaches for the synthesis of various important organic molecules. So I think catalysis is one of the approach by which we can achieve this target, that is development of sustainable approaches. So we can see the importance of catalysis in organic synthesis by few things like the Nobel Prizes given in organocatalysis, or you can say metal catalysis. So we know that in 2005, metal metathesis, this alkene metathesis has received the Nobel Prize, and in 2010, the metal catalyzed carbon-carbon coupling reactions, and then in 2021, this organocatalysis has received the Nobel Prizes. So these Nobel Prizes, they clearly indicates the significance of this metal catalysis in the organic synthesis or organic reactions. So before proceeding further, so a little thing about the CH activation actually. So what is the CH activation and we call? So CH activation basically is the formation of carbon-carbon or carbon-oxygen or carbon halogens bond or other heteroatoms bond directly without doing any pre-functionalization or modification in the carbon-hydrogen bond. And a number of methods are available, mechanisms are available for achieving these coupling reactions or these carbon-carbon bond formation reactions. So in this CH activation approach, actually what happens here, so first metal get introduced between the carbon-hydrogen bond, and that activates that carbon-hydrogen bond in this way by forming a organometallic species. And then this intermediate then react with the other substrate or reaction partners to functionalize a carbon-hydrogen bond selectively. And there's the various significance of this, you can see CH activation. As you can see, we can do the reactions in one step. If we go conventional method, use conventional method, so we need to do first like modification of the particular center, then we introduce our functional group, and then so many things. So using metal catalyst, we achieve this target in single step, and there's no, you can see no pre-functionalization is required. We selectively a particular carbon-hydrogen bond can be functionalized, and it is easier to modify an existing drug or molecule that we call late-stage functionalization using this CH activation approaches. And in this CH activation approaches, these directing groups, they play a very important role. Actually, we know in organic molecules, there are a number of carbon-hydrogen bonds. And if we want to functionalize selectively a particular carbon-hydrogen bond, then for that, we need a directing group. In heterocyclic molecules, the heteroatom plays that role of a directing group, so we can say atom. But in case of aromatic and aliphatic systems, we need to introduce some heterocyclic species or molecules, which they regioselectively enables the formation of carbon-carbon bond by activating this carbon-hydrogen bond. A number of examples are available of these heteroatoms or molecules which acts as a directing group. You can see in this figure on the right-hand side of my slide. So in this catalysis, we generally use palladium, rhodium, iridium, or ruthenium-based catalyst. But the palladium has received much attention because of several reasons, like the ligand-reactive carbon-hydrogen functionalization using this palladium catalyst at palladium centers can be, we can install many bonds, like carbon-oxygen bond can be introduced directly, or carbon-halogen bond, or carbon-carbon bond, or carbon-sulfur bond can be introduced. Even carbon phosphorus and carbon boron bond can also be introduced directly using these palladium centers. And there's the various reacting groups are available with which this palladium catalyst is comfortable. And they, unlike the many other transition metals, this palladium promotes the activation at both sp2 carbon as well as sp3 carbon sites. And there's no need to take care of reaction conditions. We can do the reaction in ambient air or moisture conditions. Else, there are many catalysts we require, we need to use dry conditions. And moreover, the palladium has the ability to exhibit various oxidation state, like from 0 to 4. So because of these advantages of palladium catalyst, it has received much attention. And that's why we have focused on the use of this palladium. So this is the paper that was published by BC Rana in 2016, which prompt me or prompt me to do the CH activation. You can see there's the reaction is here, in which they carried out a selective orthofunctionalization of benzoxazine using this alpha-oxocarboxylic acid.
Prashant Kumar, I'm interrupting
Yes,
you. You please come on to your results and
okay,
conclude.
sir.
As our
Actually,
discussion.
my result is linked with this. That's
Carry
why.
on then.
Okay, so they did this selective functionalization of this compound, but there is some issues with this, like the expensive keto acid, liberation of CO2, low atomic economy, and requirement of AgNO3. But it is well known in the literature that aldehydes, toluenes, and benzyl alcohols also provides the formation of acyl radical that is reported by them for the acylation. And they are much more cheaper, easily available, and they have good atomic economy and good product yield. So we decided to replace this alpha-oxocarboxylic acid with these reaction partners, and we did our initial screening, and we find our target was to do this preparation of this acylated product, but we have obtained something else, that is this cyclized product. If you look these two molecules, these two molecules contains equal number of carbon, hydrogen, nitrogen, and oxygens. And the aromatic protons are in the same region. The molecular mass is the same. The only difference is between the carbon, C13, of this carbon group here in this acylated product and this amide. And we also confirmed this structure by the single crystal studies. Then we decided to carry out our work targeting the formation of this product, and we optimized the reaction conditions. And with that, a library of 10 molecules was prepared using the toluene as a reaction partner for this acylation, and TBHP we have used an oxidant. We have also screened the aldehydes, aliphatic as well as aromatic aldehydes, to carry out the reaction, and delightfully we achieved our this cyclized product, and we could synthesize the 19 product in moderate to good yields. We continued, and then we took the benzyl alcohols to see the scope of these, and 5 products could be achieved with the benzyl alcohols under the same reaction condition that we have used for the benzaldehyde. So after screening the substrates, the next target for us was to design the mechanism for this transformation.
Okay, you don't go on to the mechanism. Please try to conclude
I
it.
will not discuss the mechanism, sir, but
no. You just conclude it now.
So this is the control experiment. This is the mechanism. Paper was retracted. This is my second work. Acylation using alpha-oxocarboxylic acid. Control experiments, divatizations. Other work, divatization. Other substrates. Acknowledgement. Thank you so much.
Okay, nice work you are doing. You have got the lead from some paper. Okay, please carry on with this good piece of work.
Thank you, sir.
Okay, the next speaker, please.
Now we move on to speaker OP13, Abhishek Singh. Please present your slides. Abhishek Singh, are you there?
No, Deepankar, next, please. I think he is not there.
Yes, sir. Now we move on to Sunita Arya. Please present your slides.
Yes, sir.
Sunita Arya, are you there?
Yes, sir.
Yes, please.
Sunita, please do fast.
Yes, sir. The screen is visible?
Yeah, your screen is
Yes,
visible. You are audible, and just with a brief introduction, come on to your results.
Yes.
Okay.
Sir. Yes. Sir. Good afternoon to respected sir. My name is Sunita Arya. I am research scholar under the supervision of Professor Rubina Aman, Department of Chemistry, Kumaon University, SSG Campus, Almora, Uttarakhand. Today I was like to present
on monoorganosilicon alkoxides with 2-hydroxyl naphthalene, 1-aryl methylene amino acetic acid, synthesis, characterization, and pharmacological activities. Schiff bases are considered as a valuable compounds in coordination chemistry due to their potential for stable complex formation with metal ion. The organosilicon complexes with oxygen, nitrogen, and sulfur donor Schiff base ligands are well known for their stability as well as for versatile application in pharmaceutical and chemical industries. These compounds derived from nitrogen and sulfur containing ligands as well as known for their anti-carcinogenic, antibacterial, antifungal, insecticidal, and pharmacological activities. Amino acids are dynamically implicated in a part of biological process, and they possess the NH2 and COH coordinating sites which can be bonded the aldehydes and ketones for synthesis Schiff base which are easily coordinated with the metal ion. Herein we reported the synthesis, characterization, and pharmacological activities of 6 new monoorganosilicon complexes. These are the synthesis of Schiff base ligands, and these are the synthesis of organosilicon complexes and these pharmacological activities. Results.
Just move your slides. It is not
Yes, sir.
moving. Change your slides.
Yes. The reaction results in the replacement of methanol and ethanol owing the acidic hydrogen from Schiff bases and methoxy or ethoxy groups from monoorganosilicon alkoxides. For figure 1 of here, the reaction and proposed structure of the monoorganosilicon complexes where R is equals to methyl and ethyl and X is equals to methoxy and ethoxy. These are the elemental analysis table and the results. The 1H NMR in the case of Schiff base, phenolic OH signals is observed at 14 ppm, which is disappear in the spectra of the silicon complexes, and the a sharp singlet proton signals of the azomethane group was observed at 10.8 ppm, which are appears at 10.8 and 10.9 ppm in the spectra of the complexes due to the coordination of azomethane nitrogen to the methyl ion. In 13C NMR, azomethane group of the ligands appears as 163.92 ppm, and the spectra of the corresponding silicon complexes these appears as 162.34 to 163.89 ppm. The IR results free ligands band at 1592.32 attributed to the azomethane, and their silicon shows a major shift to a higher number of azomethane at 1592 to 1619 centimeter inverse, suggested the coordination of the azomethane nitrogen with the silicon ion. These are the pharmacological activities as follows, and the conclusion of the pharmacological activities is that the IC50 value of monoorganosilicon complexes are nearest to the standard value of IC50, so they exhibit as good and pharmacological activities as compared to the ligand. And these are the figure 2 is antioxidant activity and figure 3 shows anti-inflammatory and anti-diabetic activities. And conclusion that the ligand act as a bidentate, tridentate, and coordinated through imine group nitrogen and carboxylate oxygen to the silicon atom. It was concluded that the monoorganosilicon complexes shows better pharmacological activity than the ligands. The pharmacological activity increases with the electron donating group. In the present investigation, ethyl substituted complexes shows highest pharmacological activity as compared to the methyl substituted complexes. These are the references. Thank you so much.
Okay, Sunita. Since your slides could not move, it did not scroll on the screen. So we could hear from whatever you have said that this compound is showing good pharmacological activities.
Yes.
Okay,
yes.
so I think work is good. You may carry on with this work.
Okay. Thank you, sir.
Next speaker.
Now we move on to OP15, Divyansh Singh. Please present your slides.
Yes, sir. Is my slide visible?
Yes, it is visible. Please carry on. You are audible and visible both.
Good afternoon, everyone. Today I am Divyansh Singh, the second year MBBS student from NIMS Greater Noida. I will present on the topic diabetes mellitus based on theme medicinal chemistry. So, what is diabetes? diabetes is commonly known as diabetes. It is a epidemic metabolic syndrome that can affect the people of any age group. This is a chronic disease characterized by hyperglycemia, that is high blood sugar levels, glycosuria, glucose in urine, hyperlipidemia, high blood lipid levels in blood, and sometimes ketonemia. In when we do long fasting or long duration fasting, we see ketone bodies present in the bodies. Diabetes mellitus may also cause long-term specific effects like retinopathy, neuropathy, cardiopathy, peripheral vascular diseases, cerebrovascular diseases, obesity, and etc. There are basically two types of diabetes, type 1 and type 2. Type 1 are seen in very less population because it is an autoimmune disorder, and type 2 diabetes mellitus which is the most common diabetes we see nowadays. There is also a third type of diabetes, also known as gestation diabetes, which are generally seen in pregnant women. Now, insulin. What is insulin? Insulin is derived from a Latin word, insula, which means islets. In 1869, Langerson identified alpha and beta cells present on islets of pancreas. Insulin was the first hormone that was extracted in the pure form. Scientists injected an extract in the diabetic
Divyansh,
dog.
I'm interrupting you. If you have any results or if you want to show any results, I think you should switch on to that
Sir,
slides.
basically, since I am just in second year, we are not allowed to touch the patient, but we volunteered around 12 to 13 patients because it's very difficult to find diabetic patients which are not associated with other pathologies. So we volunteered around 12 to 13 patients, um, which we asked them to change their lifestyle rather than going for the medications, and the results were quite positive as we could see the decreased levels of glycated hemoglobin from 13.6 to 7% to 6.9%, which is a huge success. And we are trying to find more volunteers, and I hope we will be able to keep diabetes at check, and we are trying our level best.
Okay, Divyansh, it is nice to hear you. And since you are doing this work, carry on with this work because you see, changing the lifestyle is one important way of treating the people with just who have just been diagnosed of diabetes type 2.
Yes. Thank you, sir.
Okay. Next speaker.
Now I would like to invite Nishita Chauhan for for the presentation.
Yeah, am I audible, sir?
Yeah, you are audible and you are visible also.
Okay. Good afternoon, everyone. Myself, Nishya Chauhan. Topic of my presentation is identification of gene with the role in environmental adaptation at low temperature in common carp, Cyprinus carpio, through global differentially expressed gene analysis. Aquaculture is one of the fastest growing sector in the world. India is the second largest producer of aquaculture. This graph is showing the fish production in 2020 and 2021, according to the report of FAO. My fish of interest is Cyprinus carpio, commonly known as common carp. This is the third most introduced species worldwide in 86 countries. This species is reported to have a strong acclimatization response to much more thermal changes and can be habitual to the rapid thermal change. It has a wide tolerance range of temperature, 0 degree and 30 degree. Objective of my research is to identify the environmental adaptation related genes in common carp exposed to two different temperatures, 20 degree and 30 degree. This is my experiment plan. We have taken same size of fishes, and after that we acclimatize them in 20 degree centigrade and 30 degree centigrade with stepwise cooling. After treating them with temperature with in 2 hours, we have collected the tissues and freeze them in RNA later for stability and store them in 80 degree centigrade. For after that, we have gone through for RNA extraction and Illumina high-sec sequencing. For differential gene expression study, we perform DE-seq. For protein-protein interaction study, we uses the database string. These are my results showing for differentially expressed gene. We found after KEGG analysis, KEGG database identification, we found 26 differentially expressed gene under environmental adaptation category with the maximum number of genes 16 in thermogenesis pathway, 8 were upregulated and 8 were downregulated in followed by 11 genes in circadian entity with 4 upregulated and 7 downregulated genes, and in 7 genes in circadian rhythm with 4 upregulated and 3 downregulated genes with significant p-value. This is the pathway, thermogenesis pathway, showing our differential expressed gene in pink color. We have AMPK related genes, adenyl cyclase related gene, CBIR1 related genes, which is affecting the fish at low temperature. After protein-protein interaction analysis, we found the geoclassification of these genes, these differentially expressed genes, which are involved in environmental adaptation. In biological process, we found 11 terms. In cellular component, we found 16 terms, and in molecular function, we found 9 terms. This is the graph showing the count of genes in each terms in biological process, cellular component, and molecular function. After that, we prepared a network for the protein-protein interaction, the genes we have found in the study. This is a network which shows that how much interaction the genes were showing. These are the cluster identified in our differentially expressed gene. We have 6 clusters there with 10 genes, 8 genes, 7 genes, and 4 genes. Outcome of my research is the current study would reveal the better understanding of the mechanism of regulation of low temperature of common car. List of differentially expressed gene identified, which can form the basics to identify the potential marker associated with the environmental adaptation related genes and thermogenesis related genes to utilize the genomic selection and genomic editing, enhance production and sustainability to aquaculture. These are the references, and thank you.
Nishita, the work is good. You have identified a number of genes which are related to thermal regulation. So can you just tell me briefly that how do you identify so many genes which are interacting among themselves and they are responsible for the regulation in the temperature, change in temperature, that the fish
Actually, sir, we
acclimatizes
have
to the
planned
change?
sir, actually, we have planned the experiment with 2 temperatures. After that, after we get the sequence of 2 differential expression in 20 degree centigrade and 30 degree centigrade, we performed the KEGG database analysis for upregulated genes and downregulated genes. After that, we categorize them in environmental adaptation category. It's a category in the database. We selected these genes and studied them.
So you first try to find out the expression of those genes, no? Like proteins,
Yes.
proteins,
Yes, sir.
and after you have hit the
have
proteins, then you move on to
Yes,
the
sir.
okay, a good piece of work. Carry on with this.
Thank you so much, sir. Thank you.
Next speaker.
Now, I would like to invite Anjali Singh for the presentation. Anjali Singh, are you there? Anjali Singh.
Next, please.
Now we will move on to OP18, Nishu Nan for the presentation.
Yes, sir. A very good afternoon to all. I'm Dr. Nishu. So I'm going to present my thesis work on title G quadruplex formation at human DAT1 gene promoter, effect of cytosine methylation. So I'll start with a brief introduction of DNA. In 1953, Watson and Crick proposed the structure of DNA, a double helical B form of DNA, which is made up of 2 strands of nucleotide. And there is a complementary base pairing take place between adenine and thymine and cytosine with guanine. And this pairing is known as Watson-Crick hydrogen bonding. Now the basic structural unit of nucleotide, it consists of nitrogenous base, a sugar moiety, and a phosphate group. Since DNA bases have numerous hydrogen bonding sites, so this gives rise to structures like hairpin, cruciform, G quadruplex, and hence it shows DNA polymorphism nature. And among all the 4 nitrogenous bases of DNA, guanine shows the peculiar property and found to play an important role in various cellular processes. So G quadruplex formation take place when 4 guanine bases associated through Hoogsteen hydrogen bonding and it forms a square planar structure called guanine tetrad, and such two or more G tetrad can stack on top of each other to form a G quadruplex structure, which is further stabilized by the presence of a cation like potassium, which sits perfectly in a central cavity of the tetrad. So coming to this epigenetics topic, which is an emerging field of science that studies heritable changes in gene expression without altering in DNA sequences, it involves an interesting theory of nature and nurture. Since nature is all about genetic information that we inherit from our parents, and nurture tells us that we are not defined by our gene, and it is our lifestyle choices that can actually impact our genetic codes. So therefore, epigenetics theory suggests a combination of both nature and nurture. So we can say that genes and environment are always working together. Not talking about the significance of the epigenetics. So epigenetics has a potential to explain the mechanism of human development, aging, as well as origin of cancer, heart disease, mental illness, and addiction. And hence these topics play a very crucial and important role. Talking about the DNA methylation is a type of epigenetic modification and which occur by the addition of a methyl group to DNA at the fifth carbon of the cytosine ring, resulting in 5-methyl cytosine, and thereby it modify the function of the gene and affecting gene expression. Now this methyl group project into the major group of DNA and where it inhibit the transcription. So it stops the transcriptions just because we added methyl group at the cytosine position. So based on the literature work we did, so we have taken the following sequences: DAT26, DAT26 complemented methylated DAT26 for our studies, and we have methylated the following cytosine in DAT26 sequences to check the stability, to check the effect of methylation over our sequences. And first we did NCBI blast technique to help to analyze and interpret the biological data, and we have found that the sequence is located on chromosome 5 in the promoter region of that gene, where this gene encodes for dopamine transporter. That stands for dopamine transporter, which is a member of sodium and chloride dependent neurotransmitter family. And this is also responsible for the principal regulation of dopamine synaptic levels and is involved as a key target in many psychostimulants. So next I used cluster W. So multiple sequence alignment here reflected that this sequence is fully conserved in humans and partially conserved in chimpanzees, rhesus monkey, mouse, and Norway rat and dogs. Further, Alibaba 2.1 helps us to determine the transcription factor binding site near our sequences and its proximity and on these DAT sequences. And we have found that the SP1 transcription factor are abundantly binds to or near the DAT sequences. So SP1 transcription factor, it shows high affinity to G-rich sequences. So it involves in regulation of gene expression and also associated with cell mechanism. Further, we have conducted the native page here to check the molecularity of our DNA sequences, and we have seen that the DAT26 sequences in both sodium and potassium as well as in methylated. So in unmethylated sequences, we have observed we get 2 bands, and in potassium we have observed the 4 band for methylated and unmethylated sequence. And when we compared the with control size marker, we have found that we have allotted this to uni, bi, tri, and tetramolecular species.
Dr. Nishu, you may come on. I'm interrupting you. You may come on to the results. Okay.
Yes, sir. So these are the results which I'm discussing.
And finally,
here.
you should conclude at the
Just give me 2 minutes. I will cover all this.
Hmm.
So we observed that in potassium, in sodium, we observe bimolecular and tetramolecular species, and in potassium, we observe uni, bi, tri, and tetramolecular species. Further, we have conducted circular dichroism study to check the conformational of our DNA sequences. We have found that in sodium salt, we have observed the 2 positive peak at 261 and 295 nanometer, and in potassium salt, we have observed 263 peak. So this we have assigned to the parallel and anti-parallel G quadruplex structure based on the signature peak of G quadruplex. And for duplex, we have observed the peak at 265, which is for the duplex species. Now, talking about the thermal stability of our sequences, we have observed that our sequences in our methylated sequences shows thermal stability lower than the unmethylated sequences, and this shows that the effect of methylation on our DAD26 sequences is reduces the thermal stability. So methylation over our sequences reduces the thermal stability of the G quadruplex structure formed here. And similarly, we have found that in duplex species as well, effect of methylation reduces the thermal stability by 7 degrees Celsius. And this shows the greater effect on the thermal stability. Based on correlation of these studies, we have proposed the hypothetical structure. We have represented here the parallel bimolecular and anti-parallel tetramolecular G quadruplex structure formed in sodium salt condition, and in potassium salt conditions, unimolecular, bimolecular, trimolecular, and tetramolecular species is formed. And for duplex, we have found that it is forming perfect duplex species. Talking about the biological significance, which is very important here. So G quadruplex formation usually suppresses the gene expression, and introducing over methylation does not affect, although the G quadruplex formation, but it does affect the thermal stability, and hence it will play important role in modulating the gene expression. And this is, I've already concluded my work here. And this paper is already, recently this paper has been published in BB Reports. Thank you so much.
Hello, Dr. Nishu, you did an excellent presentation. I want the next speaker to please start the presentation.
Now I would like to invite Rishabh for the presentation.
Yes, sir. The presentation is visible?
Yes, no. Just you start. Yes, it is visible now. You start.
Okay. Good afternoon, everyone. This is Rishabh this side. I am Assistant Professor Shri Ram Swaroop Memorial University, and the topic of my presentation is applicability of polycarboxylic ether and sulfonated naphthalene formaldehyde as superplasticizer in concrete at elevated temperatures. So concrete is one of the most extensively used structural material in the world. So in current use, concrete is basically, it is the mixture of cement, sand, aggregates that we use for construction activities. And with increase in its use means mineral admixtures in the form of fly ash, silica fume are increasingly being used so that the consumption of cement can be reduced, as well as the chemical admixtures are now being used that may be in the form of superplasticizers. These superplasticizers are basically used in concrete to enhance the properties as well as to reduce the cement consumption. Like for if you have to prepare high strength concrete, then we can reduce the lower water cement ratio. What happens is, because in high strength concrete, when we have to form, then the water cement ratio has to be kept comparatively lesser. So if we reduce the water cement ratio, then we can increase the strength of the concrete. Superplasticizers are being used. This study is basically focused on the use of sulfonated naphthalene formaldehyde and polycarboxylic ether to check which superplasticizer performs better at elevated temperatures, because in industry sectors where fire breakout can be there, or in workshops where the work is being done at high temperatures, we need to understand which superplasticizer is better, and it increases the strength of concrete. So this study was basically focused to study the effect of high temperatures on different grades of concrete like M20, M30, M40. These are basically the grades of concrete, the compressive strength which the concrete gets. Like M40 means 40 Newton per mm square will be the compressive strength of concrete. So we are just checking at elevated temperatures of 100 degrees Celsius and 200 degrees Celsius, which superplasticizer performs better. So for this, the concrete cubes were cast in the laboratory. For these standards, 150 mm size cubes are casted, and then sulfonated naphthalene formaldehyde and polycarboxylic ether was mixed while mixing cement, sand, and aggregates. And these specimens were heated to elevated temperatures of 100 and 200 degrees Celsius in the oven for up to 1 hour. And after the curing, the compressive strength results were tested for them. So these are basically the material proportions that were being used and the standards of the cement, their setting time, final setting time, soundness, fineness. These are basically the properties of the cement, and the consumption of material for sand, cement, and aggregates. This is being shown here. This is the oven in which the samples were placed, and the compression testing machine where the cube molds, which we can see, were casted of 150 size, and then they are tested with the help of compression testing machine of 2000 kilonewton capacity, from which we can determine what will be the ultimate compressive strength. My main results that were focused on, I will directly show that slide in which we can see all the 4 results. So we can see the effect. What happens when the temperature is being increased? At room temperature, we are taking 20 degrees Celsius as the room temperature, and the compressive strength at that point of time, that has been taken as the standard of 100%. So what basically happens as the temperature is being increased up till 100 degrees Celsius and 200 degrees Celsius, we can see that for lower grades of concrete, there is an increase in strength. But for higher grades of concrete, when M40, in that the cement content is comparatively higher and water ratio is lesser. So what happens? The shrinkage cracks when the temperature is being increased beyond 100 degrees Celsius. Then what happens? The water is consumed from the water cement ratio. Water is being consumed at higher temperatures, and the shrinkage cracks are being developed at higher temperatures. So higher grades of concrete are not suitable at very high temperatures. But when sulfonated naphthalene formaldehyde, that is SNF, and PCE was used, so we can see at means for M20, for M30, and M40, in all 4 grades, we can see that the orange bar basically represents sulfonated naphthalene formaldehyde. It shows the lowest strength, and the gray bar that is being shown, it is for polycarboxylic ether. We can see that the polycarboxylic ether shows the highest strength for all the 3 grades, whether it is M20, M30, or M40. So basically the experiment which was focused on was to determine.
Hello.
Yes.
You may conclude as early as possible, Rishabh Joshi.
Yes. So that means the basic objective was just to check whether in this we concluded that the polycarboxylic ether based superplasticizer increases the compressive strength at room temperatures as well as at elevated temperatures, because all the in industry sector or in fire sector, everywhere concrete is being used as the structural material. So at higher temperatures, when the work is being done, then polycarboxylic ether, when used as the superplasticizer, it improves the workability and the fluidity of the concrete. That is easier for casting and it performs better. And lower grades show increase in strength with the increase in temperature, but the higher grade concrete, that is M40, in that the strength reduces at very high temperature because the water content is comparatively lesser, and when the temperature is being increased, that water dissipates and it leads to the shrinkage cracks being developed, which leads to the failure of the concrete at very high temperatures. So that was all from my side in this. Thank you.
Okay, you are doing some good work and you should continue with this work. Okay, Rishabh.
Thank you, sir.
So
I want the last speaker to.
Sir, I think guest and our vice chancellor joined. Vice chancellor sir has joined.
Okay.
Farooq sir.
Yes. Yes, Tabish.
Hello.
सर एक लास्ट प्रेजेंटेशन है, वीसी सर ने ज्वाइन कर लिया है और गेस्ट ने ज्वाइन कर लिया, तो सर जल्दी
Okay, Abhishek Singh has to give the last presentation.
Sir, I'm sorry to interrupt.
Yeah.
Sir, this is Anjali Singh. So my presentation was scheduled 17th number, and due to some technical issues, I could not join then. So can I present it right now?
Okay, you can present it, but
Thank
you
you
should
so
only
much.
give me the results as well as the conclusion.
Okay, sir. I
You will be given
surely
only
do
3
that.
minutes, 2 to 3 minutes.
Okay. Thank you so much, sir. Sir, my work is on the self-healing property of concrete using Bacillus subtilis in cultured form. And in this particular project, what we did, that concrete is one of the most important building material that is used all over the world. But the main problem with concrete is cracking. And in order to control those cracks, the repair work and the maintenance charges and everything, it is so expensive, it is time consuming, that we need some environment-friendly solution. Why? Because the alternatives that are already available are non-degradable in nature. So therefore, we embarked on this bacteria-based concrete, which hibernates within the concrete up to 200 years, and it increases the lifespan or durability of concrete structure by self-healing action. Now, the significance of this project is that
You
because
come on to
these
the results.
Okay. The results were, sir, when we employed the bacteria in the concrete and we worked on different grades of concrete, that is M20, M25, and M30. And there were variability in the inclusion of these bacteria by 2.5%, 5%, and 10%. So an increase in strength was observed, and even the crack healing can be observed. And it is, it increases up to, as we can see, the optimum level of increase in the strength can be achieved when we use 5% of bacteria in concrete. And even the flexural strength increases by 16%, 21%, and 18% respectively in M20, M25, and M30 grade. So the conclusion is that this is a very environment friendly method, and the flexural strength gets increased, and an optimum increment in compressive strength is also achieved. And this is one of the best methods in which no human intervention is required, because the concrete can self-heal itself. So so that's it. Thank you so much.
Okay, Anjali, this is a good piece of work that you are doing. Carry on with this work. I would like ask the last speaker, Abhishek Singh, to please present his work. Abhishek Singh?
I think he is not there.
He's not there?
Sir.
So it is over. I can over to Dr. Tabish.
Yes. Sir, thank you, Farooq sir. Thank you very much for accepting our invitation and join us and for giving time. And thank you very much, sir.
Thank you, Tabish. Thank you very much.
Thank you, everyone.
Next.
Hello.
Devendra.
Ji, sir. Good evening, everyone. My name is Dr. Devendra Singh, Assistant Professor in FOBT IBST Department, Sri Ram Sarup Memorial University. Thank you, everyone, for your lecture. Now, I would like to invite our Honorable Vice Chancellor, sir, and would request him to share his thought. Mic over to sir.
Thank you, Dr. Devan. Very good afternoon, each and hello.
हाँ,
Yes, sir.
सर आपकी आवाज आ रही है जी सर
जी सर आपकी आवाज आ रही है
First of all, I would like to congratulate the organizing team on behalf of Ram Sarup Memorial University. I am thankful to the chief guest, Dr. Mitali, Principal Hindu College, Professor Anju Srivastav, learned experts, speakers, participants, and persons who are directly or indirectly associated with this conference. Certainly, this conference, which is focused on innovations and advances in genomics, proteomics, drug delivery, system immunobiology, green chemistry, and medicinal chemistry. These are burning topics, particularly after the long suffering from COVID-19. This is not the problem of only our country, but it is the problem across the globe. I hope certainly this participants
सर का म्यूट हो गया है डॉक्टर देवेंद्र
Thank you so much, sir. Now, I would like to call Rajendra Singh Sangwan, sir. He is an Indian biochemist, a professor and agriculture biotechnologist. He is a director and vice chancellor of the Academic of Scientific and Innovative Research, ACSIR India. He is founder and CEO of the Center of Innovative and Applied Bioprocessing, CIB, Mohali. He is also the former executive director of the National Agriculture Food Biotechnology Institute, Nabi, Mohali. Known for his contribution in the field of food and agriculture biotechnology, he is an elected fellow of the Indian National Science Academy, INSA, National Academy of Sciences, India, NASI, and National Academy of Agriculture Sciences, NAS. He is also elected fellow of the Indian National Science Academy, INSA, National Academy of NASI. Welcome you, sir. Hello, sir. Hello.
Yeah, Devin, I think sir is not there actually in the
Yeah,
room.
yes, ma'am. No issue. So it's time for announcing the winner name. I would like to invite Dr. Faruqi Jamal sir to announce the name of winner. Handing mic over to you, Faruqi sir.
Dr. Devendra.
Ji sir.
Thank you very much for inviting me on this occasion to co-chair this session and listen to all the good speakers for the those who have been called for the oral presentation.
It's our pleasure to have you, sir.
And when I was going through the oral presentations by a large number of candidates, I found that they are doing some marvelous piece of work. And even the undergraduate students, participation from the undergraduate students, especially by those two, Ankit and Harshit, it caught my attention. And both of them were equally eager to share their work over here. So that was something that incited me to say something on the aspects of certain aspects of presentation. As far as the slide goes, these days the digital technology is so advanced that the slides which are prepared by the students are just stunning and astonishing. And they have some of the slides were so good that they were exemplary. And it's good that digital technology has taken over the conventional method of expressing themselves, and now they can beautifully express themselves with these. Now, as far as the content is concerned, a large number of topics were taken up over here, and it included both the biological and the chemical sciences. And one of the presentation by Dr. Preeti Mathur it was really interesting that she had shared some thoughts on the way by which this Vibgyor color is responsible for different activities at the cellular level and at the cosmic level. Then there, just a minute, please hold on. See, I received a call in which I was told that we are running short of time, so I will not go into further details about the presentation, but it's time to announce the result. It's very difficult to announce the result, especially when all the participants are so enthusiastic regarding their work, whatever work it may be. It may be something very, very simple, something very complicated, but first of all, I would like to congratulate all the participants. They were exceptionally good. Now, among the good, it is very difficult to choose the best. So there is slight edge over the person who is best and who is good and all those things. So don't take it very seriously, because since the number of the choices are very limited, and out of these 20, I should start with the candidates who have been placed at the third position is Nishu, Nan, and Rishabh. They jointly were, in my opinion, they are for the third position in the in this oral presentation. Now, as far as position number 2, it is Vivek Morris. Okay, and I think as I told you, as I'm repeatedly telling you, that it's very difficult and don't take it to heart. Okay, this is just a phase that will come and go, and there are many more opportunities that will come in your way. So the opportunities are not limited. You can be a good orator, you can be a very good presenter. See, these things you have to learn stepwise as it comes in your life. So at the topmost position, I would say that the presentation by Zareen Harris was up to the mark, and from my behalf, congratulations to all the three who have been ranked at position 1, 2, and 3. Thank you very much.
Thank you, sir. Congratulations to all the winners. Now, I would like to welcome Dr. Neha Kapoor, ma'am. Ma'am is currently working as an associate professor in Hindu College, University of Delhi. Ma'am is convener of this international conference, which was jointly organized by Sri Ram Swarup Memorial University and Hindu College. Handing mic over to ma'am. Neha, ma'am.
Okay, thank you, Devendra.
Welcome, ma'am.
So first of all, I just want to thanks to Farooq sir. So good evening, all of you. And it is my privilege to have asked to propose a vote of thanks on this occasion of International Conference, Recent Trends in Biological and Chemical Sciences. I express my sincere thanks to Chief Guest of the conference, Professor Mitali Mukherjee, as she accepted our invitations and shared great experience. I would like to thanks to Dr. Rajendra Kumar for the valedictory address, but maybe some reason he left. And I wish express to my sincere thanks to Honorable Chancellor Sir, Honorable Pro Chancellor Ma'am, Vice Chancellor Sir, SRMU, and the Vice Chancellor of Delhi University. This is also very important to thanks our principal ma'am for consistent motivation and support in the enabling us to organize this conference. I am also thankful for the registrar SRMU and the vice principal Professor Reena Jain for the encouragement for this conference. I am grateful for the officiating director IBST and acknowledge my heartfelt appreciation to our teacher in charge, Dr. Meenu Srivastava from the chemistry department, Hindu College. I extend my thanks for the eminent professors, scientists, and the various institutions for being a part of this scientific event. This is very important to thank Dr. Tavish, convener of this event. Thank you so much. And we will plan to organize some these kind of events in the future also. I want to extend my generous thanks to the advisory board of members for their finest suggestion and the great scientific inputs. I am highly thankful for our speakers of the session, chairpersons, and the coordinators of the event. This is also very important to thanks Director TA of DUCC for providing a Zoom platform. I am thankful for our technical team, Dr. Dinesh, Dr. Rohit, and other members of the event. I am thankful for our coordinator for the event. Then the most important, our students. Our students are the driving force behind this conduction of the event. Without their cooperation, the conduction of program was not possible. So thanks to Mr. Pawan and Mr. Pooja from SRMU and the Hindu College. And I would like thanks to our student joining the audience in the inaugural session. And I am fortunate to thanks all the dedicated and well-motivated team of the organizing committee from SRMU and the Department of Chemistry of Hindu College, who are aware for their task and they are dedicated enough to making this conference for a great success. So thank you very much all the participants in the oral session for the joining the program and make it success. Lastly, I am grateful to Almighty for giving us strength to organize a conference of this level. And my apology if I missed out any name. Once again, thank you so much, everyone, and have a great evening and goodbye.
Thank you, Neha ma'am.
Thank you, Davish.
Thank you to all.
Yeah. Okay, so I think you people can fill the feedback form, and rest about the we can send their certificate on their mail ID. Tabish ji?
Yes, ma'am.
Okay.
Yes,
So
ma'am.
thanks all, and have a great evening. So we can leave now or wind up this event.
Yes, ma'am. Yes.
Okay.
Congratulations, Tabish ji and Dr. Neha Kapoor, for the completion of this successful event.
Thank you, ma'am. Thanks all. Okay. So I just request to Mr. Rohit, please end this meeting.
Okay, ma'am. Okay, end करते हैं. Thank you, everyone.